is Sangam, and I work at Accuric as a developer advocate. Accuric enables self-healing cloud infrastructure by codifying security through your development lifecycle. And today, security is the most important part in your DevOps pipeline. So that's lead to DevSecOps. And in this OSCONF 2021, I'll be speaking about what is DevSecOps, why DevSecOps, and how you can implement security into your DevOps pipeline. See you there and stay tuned.
I am Mitesh with Rudderstack. So Rudderstack is an open source data pipeline company. We have built our own multi-tenant system to handle multiple tenants. And I'm going to talk about the same like in OSCON 2021. If you really want to know how we build it using Kubernetes and by building our own custom operator, do register at OSCON 2021. Thanks, see you there.
Hello there, I'm Sylvain Combraque. I'm really excited and proud to announce that I'll be speaking about Go language and how to use it to create efficient apps at OSCONF 2021. We'll talk about my cache system I built using Go, and I'll show you which kind of features helped me to have the best performances. Be sure to register and catch my session at OSCONF 2021. See you soon, folks.
Frankel. I'm a developer for 20 years, and last year I was super happy to have presented at every OSCONF event that happened. Each time I had a different talk, so this year there is a new OSCONF event and I have another new talk. And you can guess, it's called Zero-downtime deployment on Kubernetes with Hazelcast. So please join me, join OSCONF, and learn about zero-downtime deployment. Have a good day.
Hello, my name is Suman Chakraborty and I am working as a senior DevOps engineer with SAP Labs India. I am thrilled and excited to speak at OSCONF 2021, and I'll be speaking on the topic from build to release. Let's codify all the things. Are you facing challenges in managing the complexity within the DevOps toolchain, or you feel intimidated using different set of tools in managing the complete CI/CD workflow? Then do join my session where I discuss the modern development workflow from build to release in managing and deploying a software application using HashiCorp's open source tool Waypoint in conjunction with Google Cloud Native Build Packs. See you at OSCONF 2020.
Hi, I am Aditya Soni, working as ATSC at Red Hat in OpenShift team. I'm excited to announce that I will be speaking about GitOps, the next big thing for DevOps and automation at OSCON 2021. I will be explaining how you can automate continuous delivery approaches on Kubernetes with Argo CD. So be sure to register today and catch up my session at OSCONF 2021. Hope to see you there. Thanks.
Hi all, this is Priyanshu.
And this is Preksha Jain.
In this OSCON, we are presenting about chaos engineering basics.
We would be covering topics like chaos engineering principles, why chaos engineering is important for better resiliency, getting started with chaos engineering, designing chaos experiment, and different tools used for chaos engineering, which would be followed by a demo.
Don't forget to subscribe OSCON event. Hope to see you there.
is Sangam, and I work at Accuric, the developer advocate. Accuric enables self-healing cloud infrastructure by codifying security through your development lifecycle. And today, security is the most important part in your DevOps pipeline. So that's lead to DevSecOps. And in this OSCONF 2021, I'll be speaking about what is DevSecOps, why DevSecOps, and how you can implement security into your DevOps pipeline. See you there and stay tuned.
I am Mitesh with RudderStack. So RudderStack is an open source data pipeline company. We have built our own multi-tenant system to handle multiple tenants. And I'm going to talk about the same like in OSCON 2021. If you really want to know how we build it using Kubernetes and by building our own custom operator, do register at OSCON 2021. Thanks, see you there.
Hello there, I'm Sylvain Combraque. I'm really excited and proud to announce that I'll be speaking about Go language and how to use it to create efficient apps at OSCONF 2021. We'll talk about my cache system I built using Go, and I'll show you which kind of features helped me to have the best performances. Be sure to register and catch my session at OSCONF 2021. See you soon, folks.
I'm a developer for 20 years, and last year I was super happy to have presented at every OSCONF event that happened. Each time I had a different talk, so this year there is a new OSCONF event and I have another new talk. And you can guess, it's called Zero-downtime deployment on Kubernetes with Hazelcourse. So please join me, join OSCONF, and learn about zero-downtime deployment. Have a good day.
Hello, my name is Suman Chakraborty and I'm working as a senior DevOps engineer with SAP Labs India. I'm thrilled and excited to speak at OSCONF 2021 and I'll be speaking on the topic from build to release. Let's codify all the things. Are you facing challenges in managing the complexity within the DevOps toolchain, or you feel intimidated using different set of tools in managing the complete CI/CD workflow? Then do join my session where I discuss the modern development workflow from build to release in managing and deploying a software application using HashiCorp's open source tool Waypoint in conjunction with Google Cloud Native Build Packs. See you at OSCONF 2021.
Hi, I am Aditya Soni, working as ATSE at Red Hat in OpenShift team. I'm excited to announce that I will be speaking about GitOps, the next big thing for DevOps and automation at OSCON 2021. I will be explaining how you can automate continuous development approaches on Kubernetes with Argo CD. So be sure to register today and catch up my session at OSCONF 2021. Hope to see you there. Thanks.
Hi all, this is Prashanto Priyanshu.
And this is Preksha Jain.
In this OSCON, we are presenting about chaos engineering basics.
We would be covering topics like chaos engineering principles, why chaos engineering is important for better resiliency, getting started with chaos engineering, designing chaos experiment, and different tools used for chaos engineering, which would be followed by a demo.
Don't forget to subscribe OSCON event. Hope to see you there.
Hello, everyone. Good morning, good evening, wherever you are across the globe. Thank you for joining us for OSCONF 2021 Live. I'm Savita Parekh, System Development Engineer for HPC and AI. I'll be your host for the day. Before we begin, let me express my gratitude for everyone on the call, speaker, organizer, and dear friends across the globe. Thank you all for your support who helped us shaping this event today despite the challenge we're facing during this pandemic. Let me tell you something about OSCONF. Open source community event OSCONF is a platform to connect and bring together leading meetup communities, cloud expertise, DevOps, all under one roof. Few things to take under consideration for this event before we start. As an attendee, you will not be allowed to speak as you will be muted. Any question to be asked should be asked on the YouTube live channel. There are volunteers who will help you addressing your question as respecting the time. We shall take few questions live. Make sure you respect the speakers, fellow members, and maintain code of conduct in your chat session. All the recording will be shared post the event, and I would like to welcome Ajeet. So Ajeet Singh Raina is a Docker captain and Collabnix community leader. He is Docker Bangalore community leader and ARM innovator. He has 13 years of industrial experience working in various domains like IT consultant, QA engineer, solution architect, and now he's a developer relation manager in Redis Lab. He is a developer relation manager working in Redis Lab and runs the largest Docker community in the world with nearly 10,300 plus members. So, with that, a warm welcome to Ajit. Over to you, Ajit.
Hello everybody. Thank you, Savita. Good morning, everyone. I am here super excited today to kickstart our own open source community conference 2021. I would like to thank each one of you who has joined us today for the sixth OSCONF event. Yes, you heard it right. So this is our sixth OSCONF event. This event is happening in collaboration with leading global meetup community all across the globe. First of all, I would like to thank all our speakers who worked really hard and find the free time to submit the CFP. They will be spending time with you today to share their knowledge. Secondly, I would like to thank our partners. Thanks to the official Docker Pune, Docker Bangalore Meetup Group, Octeto, Ecurix, and OpsMax for their continuous support in making this happen. By the way, there are plenty of exciting talks which are going to happen today. We have selected 12 to 13 talks ranging from Docker to Kubernetes to continuous integration and deployment to DevSecOps. We are going to hear from experts, learn from one another, and of course, you are going to see some amazing demos from our speakers. Based on the community ask, this time we are not just streaming this event to YouTube, we will be streaming to Twitter account as well. In case you are attending this event for the first time, let me tell you that OSCONF is powered by the Collabnix community. Collabnix is not a company, but purely an open community of around 5,300 plus DevOps engineers. The community was built with an intention to construct, collaborate, and contribute. That means we are here to help you to contribute to Docker and Kubernetes. And most importantly, we are here to see you succeed. The growth of the community Slack has been so impressive in the last couple of years. We added almost more than 1,000 plus members in last 2 months, which is really overwhelming. If you look at the contribution, this year Collabnix community members contributed to Docker community site that got launched during Docker community all hands. I would like to thank Sangam Biradar, Apurva Bhandari, and Gaurav Gahlot, and the other contributors for their continuous support and contributing handbooks for Docker community site. Lastly, but not the least, I would like to thank our volunteers, Sangam, Apurva, Vinay, Dijesh, Savita, and Gaurav for their contribution in making this event happen. Without any further delay, I would like to thank each one of you, and I would request you to sit back, relax, and hear from the industry experts. Thank you.
Thank you, Ajeet. Thank you for the wonderful keynote. With that, let's begin with the first speaker for the day. And I would like to welcome JJ Asghar. JJ Asghar works as a developer advocate representing the IBM cloud all over the world. He mainly focuses on IBM Kubernetes service and OpenShift, trying to make companies and the user have a successful onboarding to the cloud native ecosystem. He's also been known, for DevOps tooling ecosystem and generalized Linux communities. He has recently dove headfirst into Fedora since IBM buying Red Hat, but still secretly wants, free BSD wherever he is. So he's always trying to become a better web technology developer, though normally just uses Bash to get the job done. He's an amazing developer advocate. So with that, he's going to present to us a topic on we accidentally created a cloud on our IBM cloud. I would like to welcome JJ Asghar.
Hi, thank you so much. And oh no, I prepared the wrong talk. I set up migrating a monolith to cloud native and the stumbling blocks you might not know about. I'm so sorry if I got that wrong. It's still a good talk. Hopefully you'll be okay with that. I'm so sorry. But yes, hi, I'm JJ. I'm a developer advocate for the IBM Cloud, as Shriva said a moment ago. I am calling in from Austin, Texas. So it is actually very late for me. I'm very sleepy. So if I get a little loopy, please don't hold that against me. And I really do have the email address of awesome@ibm.com, and you can find me on Twitter at JJ Asghar. So let's get going. So I'm going to tell this story from a company called Asghar Labs. Yes, Asghar Labs is fake. And I'm going to be kind of using it as a guise to describe the stumbling blocks if you were moving into the cloud native ecosystem, to just kind of not understand what might be ahead of you. There's a lot of different opportunities, and Asghar Labs is just going to be a culmination of all these different companies that I've had an opportunity to work with as an IBMer, to be able to see, just kind of see these stumbling blocks to make sure that you might not know about these questions, and hopefully it'll work better for you. In all seriousness, it's just a fake company. It's just a way to kind of make sure that I don't actually call out different companies' names of companies that I work with. That I'll reference it here and there. So, what did Asghar Labs think they needed to do? They started their ecosystem, their move into the cloud native ecosystem just as they went from bare metal to VMs. You probably have some companies out there. You probably know some people, some companies out there that moved from bare metal to VMware or OpenStack to be able to run, to get more VMs or more consolidation of machines. Instead of having one big server, they have a bunch of little servers. So Asghar Labs thought, well, why don't we just, take the same process we did for bare metal to VMs and just do that to containers. They believe that same technique would just be the way for moving their monolithic application to cloud native. Well, where I come into the story is after they've kind of made that decision, and they've had a few migrations where successes they thought were successful. I disagreed, so I came in and had this conversation with them. They thought they were going to be successful with certain little changes here and there. And I came in as this cloud native person to be able to say, hey, you've wasted all this time and effort, and you didn't realize that these issues were down the line. So maybe if we take a step back and have a larger conversation, things will happen. So I started coming up with some really strong questions that honestly are a little bit awkward to have, but they actually do help make sure that you are going down the correct path. Excuse me for a second. Sorry about that. So let's take a moment and ask the questions that you should ask, but if you're moving from your monolithic application to cloud native. These are some very straightforward questions, but they are deceptively hard to answer. And when you start talking to your engineers or your leadership team, or your leadership team tells you that you need to move this way, maybe you should take a moment and take a breath and ask these questions. First of all, who containerized your app? Honestly, take a moment and think about that one application in your infrastructure and you've containerized it. Was it your dev team that containerized it? Was it your DevOps team that containerized it? Was it a completely different team that you have no interaction with apart from every once in a while? Do you have a couple status meetings every once in a while to see who got it done? Do you actually have a real feedback loop? That's a really hard question to ask in some more enterprises. You might just be shipped a container and told to run it. And there's so much more involved there. You need to have real conversations about who put your app together. You need to work and collaborate between the project teams and who shipped the actual thing. And the next question you need to ask is simply, why did you containerize your app? And Asghar Labs containerized their apps because they were told to. Some up on high executives said, we need to containerize our applications to make sure that we are next gen. Well, I mean, why? Like, if you have an application that is a monolithic app that makes you money or is in the black, right? Like, it actually brings in actual money. If you try to containerize that application and you don't understand what it takes to get to containerization, it's possible you'll start taking a loss there. And when you start talking to your CEOs or your CFOs or your COOs or your C-suite in general and say, well, we can containerize this application that does this thing for us, but we're going to have to take 6 months of engineering time, of 6 months of engineers spending their time and effort to containerize that, not to really gain anything. You're not going to get anywhere. That doesn't work. So you need to really take a moment and ask why. I've also seen another company out there that said that they just wanted to say that they were on the cloud, right? Like, they wanted to move from their co-located data center, that they had working machines making a good amount of money, but they had told their VC firm that they needed, or they were told by their VC firm to be on the cloud because they wanted to get rid of the co-location. It turns out the company went under because the migration was so bad. So you really need to ask why are you doing these things? And then next question is where? Like, where do you plan on deploying your application, or where have you deployed it? Like, did you get to choose the cloud you got to work with? Obviously, I'm very partial to the IBM cloud because I work for IBM. But if you've gone to one of my competitors, did you get to choose to go there, or was it part of some ELA? Like, if you went to Azure or AWS or IBM Cloud, was it something forced upon you, or did you actually do a moment and took a moment and ask, what are the benefits? One of the reasons why AWS is so successful is because they have so many other services there that you just start buying more and more of their services, and before you know it, you can't leave their cloud because your DNS is in Route 53. And that's a lot of work to get out of there. So you need to ask, where are you going to deploy this to? If you're going to go multi-cloud, that's a whole nother conversation that you have to think about. So take a moment and think about that too. And then finally, what did we actually containerize? Like, did we just take a WAR file and put it in the Java container and then ship it out? At Asghar Labs, I saw one opportunity where that's where I came in. They were like, JJ, we're cloud native. We've got a 3-node cluster here. We take our WAR file, put it into this Java container, and then we push it out to our CI, and it shows up. But it's weird because it only runs on one machine. Like, we have a 3-node cluster, and it's only on one machine's always ever working. And I asked them, I'm like, well, you have one container, and it's in one pod. You don't split pods across Kubernetes. It doesn't work that way. And they're like, what? And I'm like, yeah, you are literally wasting money. Like, you're not leveraging Kubernetes for what it needs to do. So let's take a quick little aside here and talk about some architectural changes that you need to start thinking about as you start moving down this path. this is that re-platform example that I just mentioned. And this is one of the first steps you have to think about. Obviously, I'm an IBMer, so I'm very partial to WebSphere. So you take your legacy application here, and you put it into the Liberty container or whatever container you want, and shove it on Kubernetes or OpenShift. I mean, arguably, that's a step in the right direction, but it's only a portion of it. If you're not leveraging Kubernetes or OpenShift for what it is, if you have one cluster to run that one application because you had your one application on that level just before on like one machine, you're not benefiting. You're not using cloud native for what it is. So take a moment and realize that this is just one of the steps to go there. You need to take more. And let's talk about some of those. The next step is repackaging everything as microservices. Microservices is relatively, on a theory level, it's pretty makes sense. Like if you have this application again, and you have a couple of WAR files and you have some middleware there, you start breaking up the WAR files into smaller little containers that now that they're spread over the whole cluster, it's a little bit easier. You have a shared message queue there. Things are starting to be a little bit better. Oh, I see a lot of companies stop here. And for me, I tell them no. You've made the first jump. Now you're getting to microservices, but now you have different levels, so you can release your applications at different skill or different times. You're not set to waterfall releases. Now you can actually release your software at the time you need to, because now it's all just deployments. That's great. But what you really need to go to is something called the strangler pattern and a refactor. And yes, I just told you need to refactor your code if you're moving into the cloud native ecosystem. And that's true. Like you are going to have to look at your application in a different way. The strangler pattern basically starts looking at different portions of your application and start turning them, like looking and being able to break them off as their own little process and then have their own little entity. And yes, it is a little bit challenging, and it does require a different way of thinking about it. But before you know it, working down that strangler pattern in the cloud native ecosystem, you start leveraging the platform for the power that it has. Kubernetes and OpenShift really do have this amazing ecosystem around them that allows it to scale to the level that you need to run your business at. But you will need to actually sit down and re-architect things and refactor your code. So let's talk about some of those. Well, I've already touched briefly on the architectural advantages and disadvantages, but let's jump into a little bit more specific things. First of all, one of the major advantages is velocity. You really do get better velocity because you start focusing on the different portions of your application, where now instead of having one person who understands the whole ecosystem, you have teams of people who focus on different widgets that allows for them to get the features out as quickly as they need to be. The joke is in this cloud native ecosystem and this new software development world, if you've come up with an idea, the longer it takes you to get that to market, your competitor will get it to market in that time frame. So you really do need to, as soon as you think about it, be able to get fingers on keyboards and deploy it as quickly as possible. Also, be able to scope your clusters to what you actually need. I know it sounds weird because, I'm an IBMer and I obviously want you to use the IBM cloud, but I don't want you to use a Kubernetes cluster, an OpenShift cluster in the wrong way. I want you to actually scope your clusters so you get the best benefit out of it. Like, yes, of course, it's nice for you to use my software and my hardware more for me to earn more money, but I would rather you have a good experience with it and not just spend $6,000 a month on something that doesn't do anything. I'd rather have you spend $3,000 a month on something that actually scopes and gives you business so you can actually see the value of what brings it in. But at the same time, there's some real disadvantages of moving down this path where you're going to require a much higher level of cooperation. And I'm going to say that throughout this talk, where cooperation is key to being able to move into a cloud native ecosystem. You'll need to build out more advanced integration tests. You're going to have to really sit down and think about a different deployment policy system because there's going to be different ways to deploy your stuff. No longer are you going to be sitting there in front of your CCB. Now, I didn't realize that this is a US-centric term, so I'm sorry about this. but at least in where I've grown up inside the industry, the CCB was also known as the Change Control Board. And I was at an Asghar Labs company once where they actually had a weekly meeting, just like they did in the Phoenix project, where they put all the middle management in a room and be able to do a thumbs up to say, yes, we need to release that change on like a Saturday night at 3 a.m. or something like that, right? So yes, the goal is to move away from the CCB. The goal is to remove that layer of bureaucracy so you can actually focus on moving towards the velocity that you need to for your business. It's really weird nowadays, especially because we have pipelines and automation around things. Just take a moment and think about it. Like, if you put something in the pipeline to get released, you should be able to get that out the door as quickly as possible. But if you had to make every single change go through a remedy ticket or a JIRA ticket that everybody has to click yes on, that seems weird, right? Like, it doesn't work like that. That's something from the older times, but it's still around. So the next question is, are we doubling up on things? Like, believe it or not, you probably are, to be brutally honest. Back to the Java application earlier that I was talking about, I thought it was really weird when I asked. I was like, so everything is this one pod, and this pod grows when new jobs are spun up inside of it. You realize Kubernetes is a scheduler, right? Like, if you created those as microservices and had the scheduler say, oh, I need to spin up some more pods to run these different microservices to do it, you're leveraging the platform for what it's powerful for. But instead, you have this one cluster, or this cluster with 3 nodes, one node on it that has the pod, and then at 6 a.m. every day, because it has to do its batch processing or whatever, that machine goes down because it overloads the machine with too much processing. Like, you're not leveraging for what it needs to do. So you really do need to take a moment and think about the things that you might be doubling up on. And by the way, yes, if you have any questions, please ask away however they've asked you to ask, and hopefully it'll get back to me. And I have a private chat going with the organizers, so I'd love to answer anything that comes down the line. Also, when you start looking into Kubernetes and the cloud native ecosystem, there's a load balancer built inside of there, right? So like, there's an actual like real load balancer built in front of Kubernetes and OpenShift now, like on the software layer. So if you're running an F5 inside your data center that runs your application, you need to think you might actually have multiple network hops before you actually get to your application, which is actually could be a real problem. So again, yes, it is very possible that we're doubling up on things. So isn't automation good here? Of course it is. Like, you need to leverage automation to make these things happen. Like, as you move down this path, you are going to start using more and more automation. But why are things so complicated? Well, I mean, honestly, they've probably always been this complicated. It's just now you have real visibility into it. A good friend of mine, Rob Kidd, said this in one of our conversations that I just immediately stole and put in this presentation. It's like, you got to imagine you had an ordinary bull mastiff. And if you don't know what a bull mastiff is, it's a dog. It's a really, really big dog. And now when you move to cloud native, you have 13 yipping chihuahuas that are just sitting there going, yip, 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 yip. Which, I mean, obviously they're different problems for different situations, but that's what you're doing. From the monolithic app to the microservices cloud native ecosystem, you have very different style dogs there, and you have to treat them in very different ways. So it's something to keep in mind. And then to take another quote from a great friend of mine named Ken, we've replaced our monolithic app. We're monolithic with microservices, and every outage is now a murder mystery. Turns out he actually stole this from someone else who I believe stole it from someone else. But I really do. This is true. When you start going down this path, you are going to need a way to standardize your logs for your different applications. You're going to need to be able to cooperate with the different teams to make sure that there's a level of standardization. Every unique log file you're going to have to walk through and basically treat it as a murder mystery. It's going to be challenging, but you'll eventually get there. So let's talk about some of the questions that you should ask about the cultural shift that'll happen. So with moving to cloud native, you naturally start allowing self-orchestration for rollouts and updates. You start building this trusted ecosystem. No longer is it so much command and control, because all the different teams now have their power to get something released out there, which is great. It allows this level of trust to make things happen. One of the most interesting things I saw at one of the things I saw at one of the Asghar Labs companies was that they actually took an engineer and a developer from each microservice they created and then shift them around to the different teams every sprint. So for the first couple of sprints, it was really awkward because you had to teach someone, a brand new person, every sprint how to deal with that microservice. But before they realized it, after a handful of sprints, their documentation was phenomenal. Just truly phenomenal, because you had to onboard someone brand new who knew the ecosystem but didn't know that little widget. And then before they knew it, there was no tribal knowledge anymore, because everybody understood where all the different portions of the app were. So then they actually their productivity skyrocketed. And before you know it, they met people they never knew that were literally in the same building. This was before COVID, obviously. So anyway, I'll keep going. Obviously, you need to build that pipeline. You need to back to the automation earlier, but you need to build a pipeline to make this happen. You need to be able to run everything through to make sure everything standardized. One of the reasons why Go is so easy to read is because of the Go format command. Well, it's because in every good Go developer, they leverage Go format from inside their pipelines to make sure it's standardized. That takes away a level of cognitive overhead that you might have, because you're not debating the nuances of how a comma or a parenthesis is there. And that goes back to the collaboration, because you have to learn to collaborate with other teams, and you need these standardizations to work across. So all of a sudden, this all starts coming together. You are moving to this cloud native ecosystem, breaking this monolithic app up. But as you're going down that path, you're making this cultural shift to be able to make these changes happen. And collaboration isn't just status meetings, right? Or looking at tickets that you saw that's coming down those lines. It's now working with a shared level and shared contracts between jobs and responsibilities. Jira tickets will still exist, and they'll only get you so far. But going back to actually cross collaboration makes things really, really happen. Unfortunately, there will be people who are detractors from this, because they've always done the way they've wanted to do it, and they've found a way to be successful. You're going to have that friction. But the beauty of it is if you can keep chipping away at it, before you know it, you're winning your business, because that's what you're doing. You're writing the software to make money. Like, be frank. Like, you're not writing this to do something else. You're writing this software to be able to make your company make money so they can continue paying you. So if you take down all the different boundaries to be able to make them make money quicker, if anything, they should be happy about that. Next thing you need to think about is visibility and monitoring. Asghar Labs once thought they could just buy one product and call it a day. Nagios isn't going to cut this stuff anymore. Like, you can still run, hell, I still run Nagios in my house where I'm talking to you from. But you start need to having much deeper visibility into your application. You're not going to have a single pane of glass. It's unrealistic. Back to the murder mystery joke earlier. There's so many moving parts. You're going to need that level of cooperation and understanding of the application. It's a huge cultural change when you start really digging into it. But the beauty of it is because you have visibility and monitoring into it, and you start gaining these things from cloud native, all of a sudden responsibility is shared, and things are becoming a little bit more successful. So I'm going to speed up just a little bit here to make sure that we have time to ask some questions if you have any. But I do want to touch on the economics of the cloud is different from the data center. Well, of course it is. It really truly is. OpEx is no longer is now the way it works. Your CFOs will be so much happier when you start moving down this path, because they can start projecting actual costs. But at the same time, you have to take an eye on it and spend the time on it, because that leaving that one EC2 instance up, you'll have issues. I have a question here. Well, what are the best security practices one can implement in moving to microservices from a monolithic app? That is a wonderful question. And I want to take a moment and say, security is unbelievably, like, the beauty of security in moving to microservices is because now your attack vector is so much smaller, because you're moving into microservices, you can start leveraging tooling that you normally wouldn't be able to do, and focus on those smaller targets, especially with let's just take a bad example, just coming off the top of my head. We have a monolithic app. I make jokes about Java all the time. I'll continue making that joke. And it's running on CentOS 8 box, right? Well, you've got to keep that CentOS 8 box up to date all the time to make sure that you don't have all the different possible attack vectors there with bash or whatever, right? Well, the beauty of going to containerization and the beauty of leveraging microservices is you don't need bash in those containers anymore. So you've already scoped down the attack vectors of having it. Leveraging containerization and in turn building this microservices, and in turn moving to cloud native, your attack vectors get smaller and smaller and smaller, and you can actually focus in on where possible issues are. There's a lot of different answers around there, but you no longer have this massive vector that you have to worry about, because everything starts getting smaller, and there's a lot of great software around it too. So hopefully I answered your question. So let's go back to the economics. Again, you've got to keep track of it, and you've got to, you will start spending a little bit more money, most likely, but it'll be money that you're actually leveraging. And you're not going to have that random EC2 instance you'll have just sits there and does nothing anymore. So you do need to spend in time for auditing. So what do you mean our support is now on Stack Overflow? Oh, got another question here. Can you tell us something about communication patterns and microservices? Yes. So when you start going down this path, the best way to think about it, and the most successful way this is done, it's all done with a message queue, either a pub sub of some sort. There's multiple message queues out there. I'm not going to name them all. Or simple REST communication back and forth between services. Back to the collaboration I was talking about earlier, you will need to create shared contracts, shared APIs between the different microservices to make sure that things are stable. And it goes back to the collaboration, right? Where you're going to need to talk to your friend over in that other portion of your application. But the beauty of it is if you build up these microservices and this mentality, and you start actually sharing knowledge around it, you'll be amazed on what you can come out from it. But the majority of it is through HTTP and or message queues for pub subs right now. It's the same way that we've always done it. It's just outside of the application. Now it's done through either the cluster that is there or whatever. Obviously, it really depends on your situation of your actual application, and you need to spend and do your homework to figure out what it is. But there is a story there, and there is an opportunity. You just need to figure it out. So another question I have is the top 3 best practices to move from monolithic to microservices. Do your homework, do your homework, and do your homework. I cannot stress that enough. If you're moving down that path, you need to realize that you are going to have issues, and it's not just an end-all be-all way of going. You're going to have to sit down and really do real engineering work to understand what's going on. You're going to need to have people who are specialized in those ecosystems, like Kubernetes or OpenShift, to be able to take the leverage and bring them into the conversation earlier to move down that. You're going to have to look at that strangler pattern and experiment. You get to go back to being a tinkerer, an engineer, to be able to do this. No longer are you just writing code, because you have to think outside the box. But before you know it, you'll have amazing things coming. And I'm so sorry. I just have less than a minute left. I do want to finish with this quote from another great friend of mine, Thomas Kate. And this is hopefully will hit home what I try to get across. Between collaboration and using the correct tool for the correct job, you wouldn't use a saw when you needed a hammer, or you wouldn't hammer when you needed a saw, right? Think about that for a moment. You can use a hammer as a saw. Like, I mean, you can just keep hitting a piece of plank of wood. Eventually it'll break, right? That's what a saw does. It breaks a piece of wood in half. And you can use a saw to hammer in a nail if you need to. I mean, it's going to take you a while. It's going to go wah, 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 or whatever. But you can do it. So you've got to really take a moment and make sure that as you move down this path into the cloud native ecosystem, you use the correct tool for the correct job. So thank you. Thank you so much for having me. I hope I didn't go too far over your time. Again, on Twitter at JJ Asghar, or no joke, really, please, truly email me at awesome@ibm.com. I am always willing to have a longer conversation about this.
Thank you, JJ, for walking us through the wonderful insights. So one last question, if you can take, like, is there any significant, like you have mentioned, a significant benefits, on walking us through microservices? So is there any targeted applications, or is it good for all applications, these kind of services?
Oh, great question. So is it just one specific, like is it only business logic behind the firewall, like just for my business, or is it like everybody? Honestly, yes. It depends, right? Like, it really does depend. And you have to take a moment and really look at your business requirements and to see if it's valuable. And that's what I was hoping to mention at the very beginning of this talk, is that if you're just going to do it because your executives told you to do it, you are going to have a bad time. You need to ask, is there a real value problem? If your application is already making you money, well, you're probably going to be writing another application pretty soon. Write that one as a microservice and don't touch the one that's already making you money. Right? Does it make sense?
Yes. Yeah. Thank you.
Sure. Well, thank you. Everybody.
Thank you. Thank you again. So with that, we'll move to our next speaker. Our next speaker would be Suman Chakraborty. He is a senior DevOps engineer at SAP Labs, Bangalore. He is managing and supporting DevOps for SAP ABAP on Cloud Foundry and Kubernetes platform. Suman loves to speak and engage with community on various open source and cloud native topics ranging from Cloud Foundry, Kubernetes, Serverless, and DevOps. He has been a distinguished speaker in different tech conferences that includes Linux Foundation event, HashiCorp, and CNCF sponsored events, DevOps Summit, Collabnix, and CNCF Data Management User Group. And the topic he'll be walking us today is from build to release. Let's codify all the things. So with that, a warm welcome to Suman.
Thank you, Savita.
Thank you.
My voice is clear and it's audible.
Yeah, you're audible.
Yeah. Okay. Thanks a lot. And hello to everyone. Good morning, good afternoon, good evening from wherever you're joining this Collabnix event. I'm really excited to be part of this event. And so today I'll be basically going through one of the key tool which basically helps in giving a very good experience from the developer perspective. So let me share my screen. Okay, I hope my screen is visible. Okay, so yeah, so the topic that I'm going to discuss about today is basically from build to release. Let's codify all the things. So this is just to give you an idea about how we can simplify our DevOps lifecycle in managing, in basically building, managing, and deploying our software application on any platform. So a bit about myself. Well, I'll just quickly go through since Savita has already introduced me. So I'm currently working as a senior DevOps engineer with SAP Labs India, and I'm a speaker in the open source community in the Linux Foundation event and in different other CNCF sponsored events such as Camp Cloud Native and the Collaborates, Docker Bangalore, and DevOps India Summit. I do write articles on different tech that includes platform as a service technologies with cloud native, serverless, Kubernetes, and monitoring on different social media platforms. And when I'm not talking or writing articles, I'll be traveling, and I'm a great foodie. So coming into the agenda, so what we are going to see today is first we need to understand the developer lifecycle, the current that is in existence, and the challenges that is included with this current scenario, and how Waypoint as one of the tools provided by HashiCorp simplifies this development pipeline. And then we are going to understand the advantages and use case of Waypoint from the developer perspective, and then a quick demo around this solution. So let us try to understand the current developer life cycle. So if we see the current life cycle can be comprises of 7 different phases, which starts extreme left with coding, and then it moves into the testing, to the build phase, deploy, and then to the release, and then you start operating the applications on any platform, and then measuring, and measuring that includes monitoring, observability, logging, and all those features. Now, it has been seen in the on a wider aspect from the organization perspective or from the community's perspective. We have a defined set of tools which are basically defined for 2 different phases that are defined for coding as well as testing, and on the right hand side for operating and the measuring. So if we see on the coding side, people tend to use the Visual Studio for writing their code, while GitHub is naturally used as one of the tool where basically you can store your source code, and that can be used across different platforms. Once the application is coded, there has to be certain test cases which has to run and validate that code, which can be run through some tools, open source tools, Circle CI or Selenium tools that would basically do certain in testing on this on your application code. While leaving the middle, coming into the operate side, again, we have a well-defined standard set of tools that is taking care of the application that you are planning to deploy. So whether your application is a VM-based application, then you basically manage that using Terraform, or you have Moment that can actually take care of it. Or if your application is more on the is more deployed as a container, you would basically choose something like Docker Swarm or Kubernetes to deploy it on the platform. And then once the application is live, you basically set it to be monitored through certain observability tools such as Datadog or Grafana or Prometheus to get the statistics of the utilization of the resources within the application, and if there are any bottlenecks that is experienced by the end users. Now, the problem lies here in the middle phases, which is like build, deploy, and release. What we see that there is no proper standard that is defined in these 3 different phases. So there are quite a number of tools that are available in the community as well as in the enterprise segment, and it all depends on the type of requirements where we need to choose a specific tool and implement the logic on that. And what also we observe is that this basically provides a very fragmented and uneven mix of deployment strategies. So you have different set of integrations that is coming in the deployment phase. Let's say, for example, if you are going to deploy on a VM-based server, then you choose a set of tools for that. If it is on a container-based environment, then you choose a certain set of tools. If it is a serverless-based deployment, then you might choose, say, Lambda or Cloud Run for that. And then release is also where where it has been seen that there are certain domain-specific skills which are currently lacking, and that actually doesn't translate to multiple platforms for which the software build happens. So the concerns that are being raised by the developer is that it doesn't matter that where the application would be deployed, but to basically concise the approach or to make the approach more homogeneous in basically taking an application from the build to deploy is what is requested or is needed by from the end developer perspective. And as a developer, you don't care about how your code gets deployed, but you need to basically have a seamless approach in delivering the application. The third thing is that the developer obviously doesn't want to basically have more headache in managing the infrastructure, because he wants it to be actually seamlessly managed by the tools that he is using. And developer wants a better interface, a good UI interface that can basically help in building the cloud native CI/CD pipelines. So how these challenges can be solved? Well, HashiCorp has basically developed one of the very finest tool, which I would say that I have seen till date, and which is called as Waypoint, that actually tries to solve this problem. So Waypoint is basically provides a modern day workflow to build, deploy, and release your software across any platform, and the entire configuration and the entire deployment configuration is driven through a single file, which is called as a waypoint.html. is completely written in HashiCorp language. And what you do, basically, you have the source code and you have the manifest, and together you just use the command called waypoint up. So it's like quite intention, or maybe it is always expected that HashiCorp always brings up some of the commands which always try to do the entire deployment, whether it's a vagrant up or something like that. It will do your deployment right from taking the scratch, taking your source code and to the deployment. And then it basically takes it together, and using Waypoint up, you deploy it on your target platform. That can be an EC2 instance, that can be a whole Kubernetes engine, that can be a serverless platform such as Lambda or Cloud1, or even or in the Kubernetes cluster also. So let us understand about the tool Waypoint. Waypoint basically provides a single configuration file that is written in a common language as a code, which is again HashiCorp language, and it provides an end-to-end build, deploy, and release strategy for your application, and provides a quick workflow how you are going to deploy your application. So if you see, we basically create a file where we define something called as a project. And in the build phase, what happens? The build is basically where all your application dependencies and configurations are compiled, validated, and configured into an artifact. Sometimes this artifact can be pushed into the local repository or can be sent into a remote registry, from where that artifact would be used in the second phase, which is the deploy phase, where the application is staged, but it is not actually released to end users, but it is staged to be deployed. So, and in the release phase, what happens? This stage application is then basically made, is exposed to the end user by configuring the appropriate DNS configuration in the infrastructure side, as well as the load balancer configuration, whatever it is required. And this is how HashiCorp achieves a seamless, HashiCorp's Waypoint tool achieves the simplest workflow of creating the complete build, deploy, and release work lifecycle for the developer. And this is the output when we run on Waypoint command. So it basically streams all the events that is happening in your terminal. And what are the coolest feature of using this particular tool in achieving this complete lifecycle is that it gives you certain developer-friendly features. So as a developer, I want that when I deploy an application, I should get some idea about whether the deployment has been done successfully, or if there are any issues I can debug. So that is what Waypoint logs give. It basically helps you to provide a simplified debugging experience on that particular application, helps you to gather logs that is coming from multiple target platforms and environment, and that is what it gives. So it is not a replacement of a persistent storage where you can actually send the logs, but it is more on the runtime where you can see what are the events that is happening during deployment of the application. The other coolest feature that it provides is giving a Waypoint exec. Waypoint exec is more about telling that you can actually log into the deployment by giving through a shell access, and you can execute certain remote commands. Let's say you have to debug certain deployment. You don't want to actually debug right from the source code, but you want to debug in your deployed application. Then you can use this tool to do that, and you can basically debug the code and everything that is available directly from the deployment site. Well, one of the key aspects of using Waypoint is to basically achieve a complete CI/CD based solution. So it basically helps to drive the CI/CD implementation. It basically has a developer agnostic pipeline driven strategy that basically helps in achieving that. It allows to do different post deploy validation. It allows for workflow portability, and most importantly, it allows to give you the metrics that is happening across the different stage of the DevOps lifecycle. And how does it achieve all these things? Because of the extensible interface. So if we see across different phases, whether it's a build, deploy, and release, the tool actually integrates with almost all the with all the available frameworks or the tools that is available. Let's say during the build, it can actually work with any of the development language, whether your code is built on Java, whether it's built on Python, Node.js, React. It can actually take the code and deploy it in the platform that might be running a Kubernetes cluster, might be running AWS Lambda function. Even if you're planning to run as a GitOps model, it can actually do that. And in the release phase, you can release it across any target platform. That can be any cloud provider platform, an on-prem solution, or maybe as a ChatOps model via Slack. That is possible actually. So enough of talk. So let us quickly go into the demo to see how we can basically see these things in action. So I have my Kubernetes cluster running in the GK environment, which I have already set up. And what I'm going to do, I'm going to first set up the Waypoint server. So first, what is needed is a Waypoint client, and I have already set up that just to reduce time for doing the demo. And if we see here, basically the Waypoint version it is giving is 0.3.3, and this is the Waypoint version which was actually released yesterday with some very important features like providing the GitHub tools, GitHub action that you can actually do with this, and also the GitOps integration that was possible has been enabled through this feature, and some other cool features. So what we are going to do now is first we are going to set up the Waypoint server. For that, I use Kubernetes since I'll be using a target platform as Kubernetes since I'm already running in my cluster. So what I do, I choose Waypoint install and platform Kubernetes, and then I have to accept the terms of service. So what is TOS here is basically when Waypoint basically uses or basically does the deployment of your artifact. It basically publishes that into an internal URL, which is actually not routable outside the cluster, but as a Waypoint user, you can basically validate the URL to see whether your application is running perfectly or not before being released onto a public IP, which is actually being given by a load balancer. So once you accept this terms of service, then you will be allowed to use that Waypoint URL functionality that is being provided internally from the server side. So what this command does, this is basically checking whether there is, it is basically deploying certain Kubernetes resources because Waypoint uses the Kubernetes platform to deploy the resources, a few bunch deployment of certain set of pods, services, and stateful service to run this server. And you can have this server running on any platform. So here I have chosen Kubernetes, but you can install it on Docker, you can install it on your EC2 platform. You can choose any platform to deploy this server. So we'll wait for a few minutes for the server to set up. So once this is set up, it will basically provide me with a public URL, which would be the Waypoint URL that will help me to connect to a dashboard kind of thing. So here is the web UI that it has created, and since it is on HTTP, I have to basically ignore this. And what I have to give is the waypoint token because it actually authenticates from the server side. So I just create a new token for this using the waypoint token command, and here I place this token and I authenticate it. So as I can see, this is the UI of the waypoint, and currently there are no projects running because I haven't registered any projects here. One good thing about this waypoint is that you can actually switch between multiple contexts. So if I do a waypoint context list, so I can see that I have a different set of deployments that are actually running here. So here is basically where you can set up your, let's say, dev environment, or you are trying to run on a staging environment or production environment, and you can use the same server to switch your context and run or basically do the complete release management for your application. So you don't have to install the server onto every other node to basically do the deployment. So it basically helps you to switch the context from a single server. So once I have done it and set it up the waypoint server, the next thing is that I need to clone my repository. So I have a simple one, and I'm going to basically clone my repository here. And this is a simple Golang application that will just print a hello world command. And the main thing that has to be seen here is how we define the waypoint itself. And so as you see, as I have already told you earlier, that waypoint basically, it is driven completely by a configuration that we write using the HashiCorp language. So here you have the project where you are defining that what is the app you are going to deploy. And that app basically comprises of 3 different phases: the build phase, the deploy phase, and release phase. So in the build phase, I have the option to go with either Docker, or even I can go without Docker file strategy, that is using something called as cloud native, using something called as a cloud native build packs. Pack is the CLI that is basically using this cloud native build packs. In my case, I'll be using the Google cloud native cloud native build packs to basically help me build the OCI complaint image directly from the application source. And then in this case, I'll be using the Docker registry where I'll be pushing my application. From where in the deployment phase, I'll be taking the application and do a deployment. So this is we called as a stage deployment, where the application is not actually released to the end users, but we create an internal endpoint URL so that it can actually we can actually use and test whether the application is running fine or not. And then in the release is where we basically publish this URL to be exposed on a production IP that is basically provided by a load balancer. So once I have the code available, and I will also show, so this is simple Golang script that basically will print hello world and nothing else, not much fancy deployments here. So the next thing that I'll be doing is I have to initialize waypoints, so that waypoint knows that which particular project it has to manage. So it will do certain checks. It will see whether your waypoint itself file is correct or not from the configuration side. If there are any configuration issues, it will immediately detect and print out here. It will also authenticate your project to be used from the waypoint server, and then it will load the necessary plugins and runtimes that it is needed. So now if I go to my UI screen, I can see that it has already detected my project, and there is my application hello world, the directory. But if I see there is no deployment or no release as created, because I haven't basically used waypoint to create the workflow. So now what I would be doing is create the complete workflow that is done using the waypoint run. But before that, I'll also show you that if you don't want to do the complete build, deploy, release in one step together, you can actually have 3 different steps using the build, deploy, and release, where you can simply build the artifact for your source image, and later you can use that artifact to be deployed separately or you can just run the deploy to deploy the push artifact on the staging side and then releasing the deployment. So you can independently choose which particular step you need to achieve or you need to do. For our case, I'll just deploy the whole thing together. So I'll just click waypoint up. And this will basically take my source code, and using the fact CLI, it will try to create the OCI image directly using the builder that is available from the Google Cloud build packs. So it takes some time first to detect what is the available runtime that would be needed for your application, creating the life cycle for the build packs, the usual build pack phases that it would go detect, analyzing, and building that particular artifact. So once this is done, basically it will then move into the deployment, into pushing the artifact into the registry, which in my case, it will push into the Docker registry. And here you can see that it has generated the image for me, tagging the image with the latest, and then it's pushing to my registry. So once the artifact has been pushed, now in the second phase, in the deployment, it would basically connect to the Kubernetes server, and then basically it will create the deployment. It will wait for the deployment to be available, basically ensuring that the pods are ready before it can actually publish this deployment for the end users on a load balancer. And here in this releasing phase, it is basically publishing, basically creating the service, the load balance, so the load balancer service in this case. So it should be up in some time now. Yeah, and the service is ready. So once the deployment is done, it will basically provide me with two different URL. One is the release URL and one is the deployment URL. The deployment URL, as I was telling, it is basically provided as an internal routable URL, which is provided by the waypoint itself, and this is not basically published to the end users. And the release URL is the one which is published to the end users. So if I just click on this, I should see my application running. And so this is how you can see the application is being printed as hello world. Now, basically, I can also see here the resources that it has basically deployed in my case. And I should see here a certain bunch of resources that is deployed in the default namespaces with hello world as the pod running, and the deployment with hello world and the services that it has basically point here in the hello world as a load balancer IP, which I'm basically connecting, and a replica set here. So pretty simple, right? So now as I get the URL here, I should also get the details similar in the UI dashboard as well. So here you can see that basically it has deployed all the three different phases. One with the build phase, and where I can see the various builds that happen. So the pack CLI has basically created the artifact, so I can get the ID here. And then in the deployments, I can see what is the stage deployment URL that it has published. And in the releases is that basically it provides load balancer IP to set the URL for my application. Now, as I was mentioning that as a developer, I also want to see what are the logs that are being shown for my deployment that I've done, and then I can get it here. These are not, not all the logs, but yeah, just the runtime logs. So I can maybe in a separate terminal tail the logs using waypoint logs -f and get the streaming out logs there. Similarly, I can also connect to the deployment using the exec command. I will just providing a shell access, and I'll be connected to the deployment, which is V1 in this case. So whenever Waypoint does a deployment, it always make a, I mean, it basically creates a version for itself. So the first deployment is always named as V1. The next deployment, what we'll be doing, is named as V2, something like that. Okay. And this is where I get the access of my application. And inside, I am this directory, and here you can go and change the configuration as required or modify certain image layer certain configuration related properties that is required for your end application, for the deployed application. So this is about how you can go and do a deployment. Now, if I have to do the change again on my application, I can simply do the change and run a waypoint up, which will basically create a newer deployment with V2 that will basically be published same here. So in the from the UI also you can get the logs that is coming. Some of the functionality is still not accessible. So I would say from the like from the debugging purpose, if you have to do, you can basically rely on CLI to do those things, while your UI can be basically used to get an overview of your app deployment. So one more thing is that here you can basically get to invite this particular server among your colleagues or peers who are working in the team, so that they can get a share access of the server and they can also view the deployment. So no need to run servers separately for different users as it is needed. So now, once you do the deployment and you feel that you are done with it, you don't need to go and clean up your individual Kubernetes resources. What you can simply do is waypoint destroy. And waypoint destroy basically will give you to, okay, so what basically the current version of waypoint has done that only the authenticated or the admin users can actually run this, and since this will destroy all the resources that are created, it asks you to basically run this with the auto approve command. So this would basically will delete all the resources that are created during this deployment phase, and will basically clean up your entire all the Kubernetes deployments that is there, and so you will have nothing in running in your Kubernetes cluster except the waypoint server and all the details. So you can see this is already terminating and should be terminated in some time. Actually, the service, they should also be in some time. So coming into the requirement then. So how Waypoint basically helps the developer. So basically Waypoint instills confidence for a developer to carry out the complete build, deployment and release mechanism of a development of a DevOps lifecycle together from a single a single place, and basically it minimizes the different workflow fragmentation of arranging the build, deploy and release and the tools that are involved with it. It is more or less extensible using different plugins that are available, and you can basically use whatever tools that is required for your application to build. And also we saw that one of the cool feature of using Waypoint is that you get certain development tools in respect to debugging your application using Waypoint logs and logging into your deployment using Waypoint exec. Also, it's currently it is supporting different container runtimes, such as if you want to deploy your code as using a Docker file, that also you can do, or you can simply use the build packs to deploy your application.
Hi, Sangam. Can we just pause for a minute and take few questions?
Yeah, sure. So yeah, I'm just ending with my talk and
okay,
some of the resources.
Sure. Yeah. So I think you can see the questions. Otherwise, I can read that for you. Is Waypoint another tool for pipeline, or how is it different from Jenkins pipeline or GitLab CI?
Yeah, so Waypoint, I would say, is basically, you can tell it's a tool that is developed not only for a pipeline, but
to help the developers to complete the build, deploy, and release phase of the
Hello. Okay, so let's move on to our next speaker. We have our next speaker, Rajdeep, and the talk of the day for by him would be on driving zero trust policies in Kubernetes. Well, Rajdeep is currently working as a senior technical lead DevOps at Lenskart. He would like to learn, talk, participate in most of the DevOps activities, and he's enthusiastic about driving all the automations. In his spare time, he likes to listen to music, play TT, and practice new technology by creating demos. And he's getting a really great found, on developing these cloud platforms, containers, Kubernetes, Terraforms, and many other such cloud native architectures as well. With that, I would like to give a warm welcome to Rajdeep Bhattacharya.
Thanks, Savita. Hi, good morning, all. Yeah, first I'd like to confirm my audio is clear.
Yes, you're audible.
Great, and my screen is visible.
Yes, you're going to put up your screen, right? Yes, I think you're back now.
Great, my screen is visible to all.
Yes, you're visible. Yeah.
Great. Hi. Yeah, Savita, you're saying something?
Yeah, I'm asking, did you share your slides up? Not yet, right?
Yeah, I did share it. Oh, just a minute. Let me share it again.
They are coming up. Yes, now we can see your screen.
Cool.
Yeah, we're good to start now. Yes.
Great. Hi, good morning, everyone. Thank you for joining in for the talk. Really happy to be here, and really happy to talk on policy management. First of all, let me introduce myself. I am Rajdeep Battacharya, as Savita already mentioned. Leading the DevOps effort at Lenskart, and feel free to connect with me on LinkedIn and Twitter. I always like to discuss about DevOps, automation, cloud native technologies. To feel free to reach me there. So, discussing about the topic, for today, which is zero trust policy, and this is something which comes and the first thing that's asked that don't we have to trust our internal employees, right? And this is something which comes as a trust issue or a culture issue, right? But as the technologies are evolving, we are moving to the world of continuous integration, continuous delivery, deployment, right? And we are moving to the likes of Kubernetes, which is very fast picking up pace, and we are moving to the world of cloud technologies, cloud platforms. Slowly it's becoming very important that we set up some standards, right? Standards, operating procedure, or the policies, right? So if you have to explain what is a zero trust policy, I mean this is something where less or no human interventions are allowed in the way we operate our day-to-day business, right? Or our day-to-day tech stack. So people join in to the team, they leave the team, or there are internal employees who get access. Nowadays most of the companies are going towards shared responsibility models, right? Where we trust our team, and teams are driven by KRAs, OKRs, where they all are driving towards a common goal. And it's very important that we give ample amount of accesses, right, to the team, so that they can basically run, right. We don't want, it's not like an old culture or a place where we are restricting the teams. It's about giving them free hand, right. And you will be seeing that most of the technology stacks are targeted towards that, like giving them access, ample amount of access. But here we are talking about a controlled access, right. So why? Because see, humans are biased, right. They can have some inclination of bypassing the system or the processes, right. And if you go ahead and you keep on replicating the same thing again and again, there is a possibility that humans do make mistakes, right. And a single mistake or a bunch of cascading effects, they can lead to a system compromise. And that is one of the reasons why with Kubernetes becoming so popular, it is also one of the most targeted platforms for any external hackers to go ahead and compromise the whole system, right. So basically, there has to be bunch of policies driven by the security DevSecOps team or the DevOps team, whatever the composition of the team is, to basically drive in some sort of compliance into the system. Why it becomes very important? Because recently, the CNCF body, they decided to deprecate the PSP or the pod security policies, keeping this as like an external extendable component, where you will have the freedom to basically put this as a wrapper rather than Kubernetes taking care of it. And this will be deprecated from 1.21, which is already a beta, and 1.25 it will be phased off. So it's a high time that we start thinking about policy driven approach in Kubernetes. And this is something I would say it's not specific to Kubernetes, although this talk is targeted towards Kubernetes. But this is something which is a general practice, be it if you are not even on Kubernetes, even let's suppose that you are on a data center environment or you are on a cloud environment, it doesn't matter. I think these are the basic hygienes that you need to follow. So as I mentioned, why zero trust policy in Kubernetes, right? So already 1.21 it's getting deprecated. So as I mentioned already, that as the size, the best thing about Kubernetes is that once you get that piece of software up and running, it's a real velocity tool, right? And you just need to put the things in correct place, and it can really kick off. The velocity of the teams can really kick off from there, right? But as soon as things start to reach at a point where there is too many deployments going on, or many people joining in the organization, it slowly can become a point where things are slowly starting to fall apart in terms of the compliance, right? Developers might create their own manifest where they are not following some standards, or they are creating a Docker image, or they're pulling a Docker image from some non-standard registry, right? So this is something where the security team or the compliance team come into the picture to basically implement some sort of gatekeeper, giving them ample amount of access, but it's maintaining some hygiene, right? And that is where policy management becomes super critical for any company. If you can start it from the early stages, that's really awesome. Even if you are an enterprise company, I mean, like, you can start small, right? You can start targeting and slowly maturing it, piece by piece, or compliance by compliance. And by the way, I mean, like, if you are an enterprise, you need to take care of the audits, right? Be it your GDPR or SOX 2 or whatnot. I mean, like, these things get factored into these compliance reports, right? As auditor, they need these checks and bounds. It cannot be an open access, right? And to tell you, I mean, like, the risk is more internal than external, right, in the modern age. So I mean, like, give your teams the ample amount of freedom they need, but drive it with all the checks and bounds. Same, I think I already mentioned this, that driving shared responsibility model, give them the access with compliance, right? Another thing that's super important is that as most of the companies are going for the velocity, right? And releasing these changes, you might have, let's say, when you are growing as a company, right, you might have X number of clusters, not just one, right? And you might be having X number of environments. You might be having some your site office network. You might be having your corporate network. You might be having some of your cloud infrastructure network. There might be multi-tenant architecture, and on top of that, you might be having Kubernetes, right? So it's good to bring in practices where your policies are reproducible as much as possible, right? And it's always good to drive policy as code, right, rather than using some GUI screen and to click, right? I mean, like, there I mean, it works, but the operational cost is too high there, right? And there, as I already mentioned, I mean, like, the manual efforts are, they tend to cause issue in the system, right? So keep it more and more automation driven. Drive it with the policy as code, and if it's on a GitOps model, that's super, right? And that is something what we drive at LensGuard, where we do this policy management. We are yet not completely there, but we have started implementing policy management as code into our system, right? So some of the as this talk is centric to Kubernetes, I'll be keeping my focus over there. So some of the things that you can target into Kubernetes, where you can set up the policies, are like pod resources, right? Pod security, network security, storage, tagging, role-based access control. These are some of the cases where basically you can put some checks and bounds, put some hygiene, right? I'll give you an example. In most of the companies, I've seen that tagging is something which lacks, very much. And tagging, although does seem like a very, very small thing, but trust me, it has a lot of impact. You can drive a lot of stats. You can drive a lot of cost assessment. You can take a lot of business decisions just on the basis of tags, right? And that's where you need to be putting up some standards or policies where nothing goes into your Kubernetes cluster without having a proper tag. Just make sure of that. Apart from that, as in a multi-tenant or even a single managed service, or even a hosted or a self-managed Kubernetes cluster, right? Network security is something which is super critical. Even not even just in Kubernetes, even in the cloud cloud environments, right? Because one missing out one ingress rule can be an easy target for any sniffer to basically create a hole in your to enter in your network, right? Pod security, right? And some pod security, as in Kubernetes we are talking in terms of pod, we are talking in terms of the containers inside the pod. It becomes super critical to basically protect, or what is baked inside your pod. Any leaked or vulnerable version of software running inside it, or somebody basically injecting their backdoor inside your container, and they getting access to all the data. This is something where a policy management tool or policy management engine can really block the things from actually going into your Kubernetes system, right? And this is something which has to be driven in your pipeline, or at least you can start with the having this implemented on the overall cluster across namespaces, and then slowly driving it in your pipeline, so that things are controlled even before rolling out to the infrastructure. So the different levels of it, but you can start with small, right? Just implement it. Just start with some basic restricting on tagging your pod resources, right? That every resource should have a valid name, every resource should have their health checks defined, and all these kind of things, right? Depends on what service you are, or container you are deploying, right? But go ahead with implementing these small and slowly increasing the granularity of your policies to increase the coverage day on day, right? To make it a really robust system, right? These are some of the tools. When I was researching about this topic, these are some of the tools that I found, and some of them I have personally used as well. One of them is Kyberno, right? And it's a policy management framework, and it is focused on Kubernetes, and really solid tool. And there are a set of templates, and it's completely declarative, and you can basically implement it easily as a code. And in your pipeline they also have a CLI to help you embed this into your CI/CD pipeline, right? Next tool is your open policy agent. Now this tool is very interesting, actually. I would say that I have just explored it, and this kind of an you can say like an open framework for policy management, right? And it's not specific to Kubernetes, and it can be extended to other tools as well, like Terraform, or your cloud infrastructures like AWS, or Google Cloud, and whatnot, right? Same is the case with Calico. Calico is more focused on your network side policy management, and it here you can basically restrict all the ingress and egress traffic, right? and control the access, of what's moving in and out of your network, and make and bound it to service to service communication, right? HashiCorp Console is another fantastic tool which is really getting a lot of traction among the cloud native architectures, where this is simply used as again a network policy management tool, where you can restrict your service to service communication, and also have a control over the traffic movement in the mesh, right? So another fantastic set of tools. For this talk, I am focusing on Kyverno, right? And which we are also using at Lenskart to bring in policy management into our system. So let's first see what Kyverno looks like internally. So here is the architecture diagram of Kyverno. I use this from their site as a reference here. So Kyverno basically helps you validate, mutate, and also generate your Kubernetes objects. So it also has an extended support for actually creation of the objects. So that's a very advantageous, because usually what we see, most of the frameworks, they act till the mutate point. They will give you the feedback, and that's it, you are done, right? I mean, like, it also helps you to whatever gets passed through it, it will help you provision that object as well, right? And here basically you can also the major advantage with any policy management framework is that you can also do you can read their events, and you can generate a lot of alerts, and you can also integrate this with some webhook as well, to push it to your Slack or your Google Chat, whatever, to basically see what the violation was, right? And there is a proper review process where the first level of review is happening via Kyber, right? So it also saves you from a repetitive compliance checking. So the Kyverno framework is already doing that for you, right? And it also helps to whatever violation is there, it will straight away check that manifest ingestion and report it back to you with a valid error message, right? Or things you need to correct to reach that particular level of standard, right? And then roll out the object. So here, this whole thing I would be showing you as a demo to make you understand how you can do this, right? And by the way, Kyverno also supports CRDs, or custom resource definitions. So you can create your own policies. You can extend whatever has been exposed, or the standard definitions which Kyverno has given at their site, and you can basically create your own, right? You can create something specific to application, or something something which you want to add which is already not there. So that's the great thing about it, right? So let's pray to the demo gods everything goes well. So let me go to my VS Code, right? So for this demo purposes, I'm using Kubernetes 1.18. So I am running this on my local Minikube cluster. So let's go ahead and first set up a Kyverno on my Minikube cluster. I'm using Helm chart to basically do that. Let me update the repo. Cool. I want to deploy it in the Kubernetes namespace so that I don't conflict it with other objects. And here I'm installing my Helm chart. Oh, I think I might have already set this up. So I think my resource already exists. So sorry about that. I think, yeah. Yeah, so it already exists in my namespace. Cool. So I'm going to skip this as I already set this up, guys. But you can use this to basically install your Kubernetes Helm chart. Let's see if my oh, let me just maybe I think my chart is already there. Yeah, let me just go through it. Probably if there are any questions I can take in the middle. Or probably if there are issue with the Helm charts, I can probably go and use my.
I think we have one question. Does policy as code in Kubernetes make sense for any kind of business?
Absolutely, and that's a very fair question actually. So in business, basically, right? If you are, let's say, how can this impact your business, right? If suppose let's go with the example of resource management, right? If suppose let's say that you don't define a resource for for your service, right? It can go ahead and consume X number of memory or X amount of CPU, right? Before it actually maybe bring down your complete cluster. So right. So here you are basically enforcing any user to put your resource restrictions in place so that you are keeping checks and bounds on what gets consumed, right? So if you don't do it, what can happen is that it can result your service actually choking your complete cluster, or it can be a cost saving exercise where actually you are enforcing this policy so that they don't go ahead and let's suppose that you release a code, right, and you had some memory leak issues in that service. So if you don't restrict it, right, it can go ahead and hog your system with ample amount of memory, right? And that you don't want, and that is something either you can you can have you can do keep a track of things manually, which is not feasible as you go ahead, but if you have some policy management framework, then probably you can just go ahead and your policy management framework will be taking care of all those things. That's just one use case, right? There can be many other use cases, because if talking about in terms of the business security, let's suppose that your service is compromised because somebody used a non-standard image, right? Now that's a business impact for you, right? If somebody data is so important nowadays, right? If somebody went ahead and basically created a hole in your network and he's actually slipping all your data outside, that's a business impact, right? You don't want non-standard repositories so basically creating some malicious code into a network, and they basically doing some Bitcoin mining or something else, right? So I think these are some of the cases. There can be many other cases that I can think of. I hope that answered. Any other question? Okay, let me see if we are good. Okay, sorry guys, my role binding was already there. So so there are two ways you can do it: by Helm chart, or you can use the manifest to basically set this up. I use the manifest, and it has created my service account config map, service and deployment, right? So let me just show it to you all as well. Okay, so let me give it a more granular view. Yeah, so this something which it looks like, although one of the pods is crashing. Let's give it some more time to basically come up. Let me delete it and see if that helps. That is why it is very mandatory to pray to the demo gods, but sometimes it doesn't work. So we'll take it, no problem. I think it is giving some initialization error. Still restarting. Sweta, time check, please.
I guess you can use 5 more minutes.
Okay, I can take up if there are any more questions.
Yeah, if you can highlight more on policy as a code versus your GUI, as you mentioned, right? So what are the key aspects which a user can look forward on that?
Yeah, sure. I mean, like if my demo doesn't go through, I'll probably show it as a code. Yeah, sorry about that. I think there is some something, some overlapping things that are there, as my Helm chart didn't install properly. So I can probably show it here, right? What I was trying to highlight. It would have been better if I had shown the complete demo, but I mean, it's okay. So here, in the Kyberno engine, I mean, like it's based. So what I meant by policy as a code. So here you will have a manifest file, right? Here I'm interacting with the Kube API, API server, where this CRD is installed of Kubernetes. And this is a cluster policy definition. So whatever I have set up, this is applied to all the namespaces, right? So it's a standard definition. And what I have mentioned here is that every container that's created inside the pod will have a name. It has to have a memory and CPU limit, right? For limits and request. Right. So somebody, when trying to create any pod, something like this, right? So here I have used a pod manifest file where I didn't declare anything, right? And that's the majorly the mistake that developers or whoever is creating the pod definition would do, that they will not go ahead and basically create the definitions of the resources, right? And that's when if this is not taken into picture, and this example is very apt. So what I'm doing here, I'm just stressing out the system, right? I'm someone who is not happy with the system, right? And I'll just go ahead and run this container. What it might do, right? It might bring down my whole system, right? And wherever it will run based on the replica set, it might bring down the whole complete cluster. That is the potential it has. So this is a clear business impact that you might have. Now what can I do about it? I can restrict it using Kubernetes, right? I can basically not allow this manifest to get rolled out and straight away be declined to that point. And what next can happen? The developer or whoever's writing the manifest will come out with these numbers, right? He will have to declare this memory and the CPU limit. And even if he tries to DOS me or stress me out, I mean, like you can't, right? You can't, because this already defined. The worst it can happen is this: it will take the maximum of this and basically crash. So this is the power that you have. You can have a control on all the resources from a central location, and that's what policy helps you drive in, right? So I think that's what I had. These are some of the references I've used for my talk, and I've also published my demo. So sorry about that, guys. The demo didn't go as planned. Sometime it happens, right? So you can use my this GitHub link to basically run your this complete demo on your laptop. You can just use Minikube or any other cluster, whichever you have spinware, right? Some other references to the other projects, right? And by the way, a shameless promotion that we are also hiring at Lenskart at different roles. So feel free to apply or just connect with me. I'll be happy to help you. So any other final questions that I can take in just 1 or 2 minutes, Savita?
Well, I think you answered most of the question. We don't see any new questions.
Okay, cool. Thank you guys for your time. Thanks a lot.
Thank you for walking us, for such a wonderful session. And we'll move on to our next speaker, Mitesh Sharma. So welcome Mitesh Sharma for OSCONF 2021 live. So Mitesh Sharma has more than 10 years experience in the software industry. And during his time, he has been worked in startups and built a lot of end-to-end products. Currently, he's working in Rudder Stack, which provides open source data pipeline software as an engineering manager and managing DevOps with their multi-tenant offering. A warm welcome. And the topic for the day would be managing multi-tenancy at Rudder Stack using Kubernetes. Mitesh, we are not able to hear you. Are you muted?
Yeah, sorry, I need to restart Chrome quickly. Actually, I'm not able to share without that. Oh, but 1 second, I'll join back.
Yes, sure.
Okay.
Meanwhile, I would like to I would like to say the audience to, feel free to post your questions on YouTube channel.
Can you see my screen?
Yes, we can see your screen.
Okay, nice. Should I start? Yeah. Hi guys. This is Mitesh from Rudderstack. I am basically like managing the multi-tenant stack there. So I'll be talking about how we built the complete multi-tenant system and why we needed it in Rudderstack. So let me start with just giving a basic intro about what Rudderstack is, and then go deep into the tech stack. So the first question is why there is a need of such a product like Rudderstack. One of the thing is consumer data volume is continuously growing. If you see every month around 60 to 65% of data get like increased for a company for consumption, and it's not only growing, it is growing at multiple sources. For at a very early stage startup, how it starts is basically you start generating data from your app, then you start showing ads, and then you need to collect data from different ad platforms. And as company grow and you reaches to more of an enterprise state, the data get distributed across multiple sources, and collecting them, getting and value out of it become very critical. Even at this point of time in 2021, like around like more than 80% like executive believes that they are not able to get the complete value out of it. Now, as data is distributed across multiple sources, collecting them, putting them into their warehouses, putting AI model, doing some analytics on top of it, and sending it at different places becomes really hard. And this is a real problem which needs to be solved. So Rudderstack comes into picture here and is a like smart consumer data pipeline. What we do is we simplify the process of collecting data from multiple sources, processing it, getting a governance on top of the data. At the same time, don't persist the data like on our side. We are completely open source. The complete code is available on GitHub/Rudder Labs. And currently we process more than 35 billion events per month. This is just a rough number which I know of. As we are open source, a lot of people are using it and we are not even aware of that number. So that must be like pretty high. What is our aim? Our aim is to like help companies solve their data problem. They don't need to build code for every source and write the complete data pipeline again. So we are exactly coming and solving this problem. So if you can see, a very basic example is you can start integrating the Rudderstack SDK into your mobile app, and the data will, and you can define any destination. It can be one destination or can be n destination, and data will start flowing to that destination. Along with that, you can add data transformation or do data governance on top of it. Now, how we started as an open source company. Then we moved to more of an enterprise model, and eventually we move, and as a lot of customers asked us that they don't want to deploy it on their infrastructure, we had to start deploying it and provide a hosted solution. And as we started from a single tenant model, going to a multi-tenant model becomes really tricky. So let's first see what is multi-tenancy. Multi-tenancy means deploying the software in a shared environment so that the same infrastructure can be shared by multiple people. But at the same time, we don't want tenants' data to be exposed to any other tenant. It needs to be isolated, and basically the complete environment of tenants should be isolated from other tenants so that they can get security. They have confidence while running their passing the data through our stack. So we need to understand why there is a need of multi-tenancy. We can even provide everyone their own individual environment and they are good with it, right? From a customer point of view. But we wanted to, for a developer don't want to talk to a salesperson. He just want to try an open source software, and maybe he want to go with a hosted solution. So in those cases, we want to make this process completely simplified. And to simplify the process, we are providing a self-serve model. And building a self-serve model without multi-tenant system is really hard. What multi-tenancy enable us? It enable us to reduce the hardware cost, because now we are able to share databases. We are able to share underlying resources. It gives us a long-term like cost saving. It helps us in maintenance because now we don't need to go and do an isolated maintenance for each and every tenant. And for ops team, it provides velocity. Like in the current environment, getting velocity from the ops like DevOps side or SRE side becomes really hard if there is a 1,000 separate deployment. It also improved the quality of software because as there are a lot of customers sharing the data, whenever one fix goes to one customer, it automatically goes to all the users sharing the same infrastructure and sharing the same software. And specifically for Rudder Stack, where the spike for one customer is not at the same time when the spike is for all other customers. So let's say there are 10 customers who got spike at 12 a.m. and 10 customer who got spike at 12 p.m. With the same amount of infrastructure, we can easily provide them service without increasing and reducing resources every time whenever we get a spike. So let's now go back deep into how the setup is done, the complete from ground zero. Now, what we did is for our multi-tenant environment, we are using AWS EKS. The benefit of using cloud provided solution is we don't need to manage master nodes. That is automatically managed by AWS for us. Using Terraform, we first run the complete code using Terraform. We provide a network layer. Once the network layer is done, we set up AWS EKS on top of it so that the Kubernetes environment is ready. Once that is done, we set up some basic pods which are needed for setting up the complete infrastructure, the complete application management layer. Once that is done, then next comes into picture the deployment of our application. And also manage. So we also use a custom operator which helps us do the deployment for each and every tenant. I'll go deep into how operator works and what it does in future slide because that plays a critical role in our infrastructure. So we use Argo CD for the complete deployment of all the application. So it provides us benefit of going with a complete JTOPS model. So everything is pushed through JTOP and it will automatically get synced to our Kubernetes cluster. And eventually Argo CD also manages itself so that whenever we need to update it, we just again push a code into JTOP. So everything becomes auditable. And during the complete setup, security is at core because consumers' data is flowing through our pipeline. And we can't let anything happen to that. We can't let anyone spoof on the data. So that way, security is at the core. Security is one of the core principle for us. Now let's go deep into how the Kubernetes cluster looks like when it is going to provision. So what we do, first we need to provision some controllers which can help us create the resources create the needed service setup. So if you see it is divided. The first one is to manage the external dependency. So one controller which we use is external DNS. It helps us manage Route 53 directly through code. So we don't need to, we create a custom resource and we tell Kubernetes, let's set up this custom resource. In the custom resource, we already tell Kubernetes using annotations that let's set up a DNS route for a given customer. And external DNS controller keep a watch on those annotations and it set it up for us on Route 53. How it is done is we use IRSA. So with the help of OIDC, every pod, so that is basically to give every pod AWS role at runtime. So that way we don't need to provide the complete role to set up Route 53 at instance level. So with that, whenever some requirement comes, the external DNS controller is always listening. It get to know, I need to create a new subdomain. It has required role and it directly make a API call to AWS and set up the Route 53. Similar second thing which we use is ALB ingress controller. So we are using 2.0. The benefit of using the latest ingress controller is basically it helps us share the ALB across multiple customers. And with the group, we can separate out customer and we can define who all customers are going to use what ingress. It basically reduces our cost because if you are providing separate ALB for every customer, it's definitely going to increase the cost. But at the same time, it gives us flexibility that we are able to, like, we are anyway paying for the traffic, so that way we don't need to pay extra cost for like a basic ELB. Then third is we need to set up a EBS CSI driver. So previously we were using the default EBS driver which comes with Kubernetes EKS, but the problem is sometimes we were seeing like disk were getting like PVC's issue with PVC. So now we moved to EBS CSI driver and it is going good for us. Once this basic setup is done, the next thing is about scaling the cluster. We don't want to go manually add instances to the cluster whenever a new customer comes in, or a pod we are increasing the number of pods. So for that we used custom autoscaler. It helps us automatically scale the infrastructure, underlying infrastructure, so we don't need to worry about it. But at the same time we use cluster over provisioner. What it does, it creates some dummy pods so that we have some extra space already available. So this is some extra resources which is consumed, but we are like not as it is used. So what happens whenever a new tenant come, we can consume this extra spaces which are consumed by pod with a given amount of resources. These pods are at very low priority, like they are at -10 priority. So whenever a new tenant come and we need to provision resources for that, these are the pods which will evict immediately, and they trigger auto scaling of cluster. But at the same time, we are able to create required pods for the customer. Then we have our own custom rudder stack operator. This is the key element for the complete infrastructure. And we need to set up a lot of application services. When I say application services, it is more like application, like the user application, the billing service, tenant service, and all those kind of services. And the complete monitoring is done through like tick stack, where for graphing library, we are using Grafana. And if you see the complete deployment, everything is managed through Argo CD. So we have like Google Auth, and we have required permission set up for every user. So that way, like anyone can go see, and the complete deployment, like whenever someone need to do push, they can just like push it to GitHub and it will be auto-saved. Now let's see how the tenant onboarding works. What happens when a user comes to the Rudder Stack website and he log in as a cloud user? So now from a user point of view, whenever user is going to come to our website and he's going to register, but underlying we are doing lot of heavy lifting for a user to set up the complete multi-tenant environment. So when user comes, we first register the user. We create a tenant for the user. So every user will have a workspace. Now for that workspace, we have one tenant that define that workspace. And for every tenant, we define billing as well as deployment. So we make a request to billing service, which basically automatically assign a zero amount billing with Stripe, which helps us simplify our complete billing management. At the same time, we make a request to deployment service, which defines what all needs to be done for this user. So for a free tier user, like we already have a hosted environment. So in that case, we don't need to go and create the multi-tenant environment. But once user pay, we definitely need to interact with Kubernetes APIs and set up the complete infrastructure. So from if you see, when everything is done, like user make a request, we send the request to deployment service. The complete multi-tenant environment looks something like this. In this case, we have some of the pods which are dedicated to user, because we don't want to provide any kind of degraded experience to any user, even if some user is on heavy load. So that way, like everyone get some pods which are like dedicated to them. But at the same time, we have some shared resources, like databases. In case of database, we have every user will have their own username and password and their own database, and no one else have access to that database. Only this particular user can access. Also, there are some shared services which we run, which is independent of this, which are like automatically horizontally scalable. So that way, like whenever more request comes, those services automatically scale, but they are shared across all the users. Now let's go deep into how the deployment works in terms of like deployment service, because that is going to be core for us. Request comes to deployment service. We create a user and a database. We make a request to our Kubernetes operator to create custom resource. The operator make a call to Kubernetes API, and then we have a dedicated namespace for a user, and all the pods are getting created. So let me go deep into operator, because this is the heart of our multi-tenant environment. So just to see what is an operator. So operator is a software extension for Kubernetes. We can write how to package, how to deploy, and how to manage our application. So basically what it does for us, it hides the complete complexity. The complete logic of deployment, scaling, managing the application is inside operator. We just make a request with a custom resource to our operator that we want a user with these resources, and the complete heavy lifting is done through operator. How operator works? Basically, operator watches on a custom resource object. It, with the help of Kubernetes API, it sees what is the actual state and what is the desired state. If there is a mismatch, it basically act on the change and it try to reach Kubernetes, like the pods or the resources, to a desired state. So in our case, what we do is we make a request from deployment service to Kubernetes API. Operator is watching on the custom resource, it gets the request, and eventually it creates all the needed pods. So why we need operator? Like basically, like for a stateless service, there is no need of operator. So one of the reason is we are using lot of stateful services, but at the same time, we have the complete logic of scaling up and scaling down inside operator. Now, if you see for a simple application, like it is a very simple logic. You can just increase the number of pod. But in our case, one of the critical thing which we provide is ordering guarantee. Now, in case of ordering guarantee, if you just add more number of pods, there is a chance that ordering guarantee will mismatch, that some of the request for a given user will go to some other pod. So to do that, we need to create a completely new deployment and put it in what we internally call degraded state. So in this particular state, the new deployment start receiving the request, but it doesn't process unless the old data is already flushed. So if I go step by step, we first create a new, whenever we need to scale up or scale down, we create a new deployment. We change the ingress to the new deployment. So all new events will go to the new deployment. We wait for whatever data is flushed, it is fine. Whatever the remaining data, we migrate it to the new deployment, and we finally delete the old deployment. So let's go deep into it, because this is something which is pretty interesting. So in this, if you see in this case, we already have 2 RudderStack pods running, and they are managing specific fixed number of users. Like user 1 is going to a particular RudderStack 1, user 3 is going to RudderStack 1, but at the same time, user 2 is going to RudderStack 2. Now, when we scale, we create a completely parallel deployment. We assign every user to a pod, and we migrate the complete incoming ingestion of data to the new pods. Now, this data is not getting processed, but only received. We migrate the complete data from the old cluster deployment to the new deployment, and then we delete the new deployment and migrate our new cluster to more of a normal mode. And same thing we do with the downscaling of resources. So what advantage this gives us? One is the migration can happen from one cluster to another cluster. It can even be done from one region to another region. So it gives us a lot of firepower. Like we can do anything with the cluster without providing even a single amount of downtime, because even there can be some amount of delay because during the migration, but that is very minimal because everything happens through code. So if on a holistic view, if I see how our operator looks like, we are using Helm charts to deploy specific resources for a user that is embedded inside the operator. Operator run those charts, set up the complete environment, monitor it, watches on top of it. It also deploy shared monitoring for users so that we can provide a specific dashboard for a particular tenant. They can watch the resources, how they are behaving. At the same time, it also deploy all the needed, like it set up databases. If we need to run Postgres as a pod, it create that and those kind of things. So once everything is done, how it is going to look. So eventually the complete setup looks like this. The request will go to Route 53. It checks, it gets the domain, like it resolves it to the ALB ingress. Then eventually request will go to ALB ingress. The data will go to specific pod where it needs to be go. Like it interact with some of the shared resources. Eventually it goes to the warehouse, either warehouse or this defined destination for a user. So this is a basic intro about how our multi-tenant stacks look like. Yeah, I think I can take questions. Hello.
Yes, we can take some questions now. So the first question is, can we deploy multiple tenants at the same time and with tagging, and is there an issue with the production environment?
No, we haven't faced the issue like this. Like basically, we just make a call to the operator, and operator makes sure that all the tenant is getting created. But in our use case, it is not like a normal B2C use case where thousands of users are coming at the same time. Basically, there are less number of users, right? And they are paying user. So whenever they make a request, even if the requests are concurrent, we make a call to Kubernetes API and they are done parallelly.
Okay, in that case, you don't have any, is it the deployment in batches, or how do you execute that?
We haven't implemented in like batches because till now we haven't seen like any issue by making multiple API requests for deployment at the same time. So it is not like we are doing 100 deployment at the same time. It is more like 2 or 3. So in those cases, like request, we just make a request to API and operator manages it internally. So operator itself has a queue where it takes, like it watches and it takes the resource, it manages it.
Okay, and is there any licensing impact if we have multiple tenants, or and the last question is there any limitation for all this? No limitations, if any.
So we are using Postgres, and there is no licensing limitation in terms of Postgres. Like, and other than that, we have our own custom resources. So that way, the complete like everything is like there is no licensing impact as such. Yes.
Okay. So yeah, I think we answered. We have taken up all the questions. So thank you, Mitesh, for the great session and for walking us how we can manage multi-tenant along with all the security aspects for same. Thank you again.
Yeah, thanks.
With that, we'll move to our next speaker. We have our next speaker coming up, Preksha, Jain, and Prashanto, Priyanshu. Okay. So the topic they'll be walking us today is on chaos engineering. Prashanto works currently as a senior technical DevOps lead at Lenskart. Same as with Preksha. She is a DevOps engineering working at Lenskart. I would like to give them a warm welcome, and over to you guys.
Yeah, thanks for the intro, Savita. So, good morning, one and all who are present over here. So, today our topic would be, just a second, let me share my screen. Yes, so is my screen visible?
No. Yeah.
Okay. So today we would be presenting on Chaos Engineering 101. So this is Preksha Jain. So I have been working at Lenskart as a DevOps engineer from last 4 months. Earlier, I worked as a developer. So I always wanted to explore my potential in different things. So maybe that is why the reason from that I took a shift from developer to DevOps engineer. So here I am exploring my potential as a DevOps and Chaos engineer at Lenskart. And this is my co-presenter, Prashanto. Prashanto, can you give a brief intro about yourself?
Yeah, sure. Hi all, very warm welcome. Myself, Prashanto Priyanshu. I'm currently working at DevOps engineer at Lenskart. I have been in this industry since last 1.5 years, and I love to contribute in open source project and explore that. So now the flow of this presentation is like Preksha will make us understand what the chaos engineering and how it works, then followed by a demo by me. So over to you, Preksha.
Yeah, thanks, Prashanto. So basically, chaos engineering. Nowadays, chaos engineering is very much booming. And one must wonder what is chaos engineering, what is the importance of chaos engineering, and how to start chaos engineering at your infrastructure or at your company. So, starting with chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. This is the standard definition given by principles of chaos.org. So basically, what happens sometimes a developer fails to build a system which can tolerate failures due to some deadlines or a lack of expertise or any other reason. So here is the point where a engineer comes into an action. So basically, challenging your own infrastructure so that it could withstand the conditions of failures in production is chaos engineering. Chaos engineering was introduced by Netflix when Netflix took their system in live. So they found some glitches and they found out a way to solve that glitches in staging environment or in pre-prod environment. So they introduced chaos engineering. After that, many big companies like Google, Microsoft, Amazon started using chaos engineering in their own way. What is the importance of chaos engineering? We all know that sometime or the another our system will fail. Instead, all the efforts that we put, but sometimes our system fails. So rather than waiting for our system to fail, it's good to reproduce that system failure so that we could get better output when in production. Finding the weakness in the architecture and services. So, by performing chaos experiment, one can find how their architecture or their service would fail in the production. So it's good to like find out the what are the weakness in our architecture or in our service beforehand, so that we can work on that weakness and improve our system. Then next is measuring the resiliency of the service and scoring them using a resiliency score. So what do we mean by resiliency over here? Resiliency is basically the system's ability to tolerate failures while still ensuring adequate quality of service. So basically, we want to ensure that our system has this quality, like we provide this quality to our customers. So when we do chaos engineering, we find out that glitches that we are lacking over here. So we can measure the resiliency of a service, and we can score them using the resiliency score. Orchestrating system slowness and failures using a series of experiments and make them a part of continuous improvement. Like if we know what is the failure in our system, or what things cause the slowness in our system, so we can continuously improve that and make our system more interactive or more good to the customer. So these are the basics importance of chaos engineering. Now, how can we get start with chaos engineering at our own infrastructure? So, in that, the very first point is define SLI or SLO for that particular service. So, what is SLI and SLO? SLI means service level indicators, and SLO means service level objectives. So, SLO is basically the expectations, like what do we expect from a system. So we write our expectations that we expect this to meet our goal. And SLI is basically the real number that our system is giving us, the actual measurement of what a service or a system is providing us. So it is very necessary to define SLI or SLO for that particular service. And the next is pick a service which is very trivial to business impact. This we can relate in our real life too. Like whenever we start something new, we always started with small amount or with a very small objective. Then we move to big scales. So here also we follow same thing. We start with a service which has the minimal impact on our business. So like if we perform a chaos experiment, so it if that experiment went completely wrong or something big happens, so it won't impact our business to that extent. So it is very necessary to find out that service which has the minimal impact on our business. Next is define the scope of chaos experiment. Scope of chaos experiment means the services, the service on which we want to perform a chaos experiment. So, what are the other features related to it? What factors are affected by that service? Like network latency, CPU utilization, memory, disk, many other factors. So we can define that scope. This service would have this scope. Then next is write the hypothesis for the chaos experiment. To write the hypothesis is very important because hypothesis is basically like you are defining your steady state of the system. We want that we want a service to perform like this. And another thing is like we can in hypothesis we also cover the dependencies on that particular service, like which other services or which like what database is linked to the service, which other services are linked to that particular service on which we want to perform the chaos experiment, and how would they be affected, like if we do something on this service, how those other services would be impacted or how our database would be impacted. So it is very necessary to write all those hypotheses. Then the next point is execute the experiment on the service or infrastructures. Once we have defined our scope and wrote all our hypotheses, then we can safely execute a particular experiment that we want to execute on that service or on the infrastructure. Next is measure the impact of the experiment. Then we measure the impact of the experiment, like we executed this service. So what impact we get from after executing that experiment? Like our system failed or it passed that experiment. Next is passing the feedback to the relevant team. Once we have done all this, we have executed our chaos experiment. We pass the feedback to the relevant team, like what impact did this chaos experiment gave us. So this is basically how we can start with our chaos engineering. Then next is what are the different tools that we can use. So these are like I have over here covered a little tools only, but there are many tools in the market. So the first one is AWS Fault Injection Stimulator. AWS Fault Injection Stimulator is like fully managed service for running fault injection experiment on AWS, so that one can improve application performance, observability, and resiliency. Next is Kiosk Toolkit. Kiosk Toolkit is basically a free and open source toolkit, and it is basically a API to all the various kiosk experiments. Like we can find the APIs to all the various kiosk experiments in Kiosk Toolkit. Next is Litmus. Litmus is basically framework for Kubernetes environment that enables user to run their test suites, capture logs, generate report, and execute kiosk test. Basically, it is used as a stateful set workloads for Kubernetes. Next is Pumbaa. Pumbaa is kiosk testing and network emulsion for Docker containers and clusters. Chaos Monkey. In the starting, when I was explaining what is chaos engineering, I said Netflix was the first one to start chaos engineering. So Chaos Monkey is a tool developed by them only. So basically, it is a resiliency tool that helps application tolerate random instance failures. Then next is Gremlin. Gremlin is a chaos engineering platform that supports testing on Kubernetes cluster. It is also another tool used for Kubernetes cluster. For this conference, for this session, we would be focusing on Litmus tool. We are using Litmus tool. In fact, in our company too, we use Litmus only. So this is the architecture of Litmus. So this SRE is the one. SRE over here, I would say that it is me, the person who wants to execute the chaos experiment. On the left side, you can see over here, we have downstream applications and application. This is basically, you can define it as our infrastructure or the service on which we want to execute the chaos experiment. And on the right side, we have app community and chaos hub. This is basically from where we will get our chaos experiment, like what chaos experiment that we need to execute. We will get it from Chaos Hub. App community is basically it is a community of members who come and place their experiments over here and consume those experiments. And experiments are placed at Chaos Hub. As the name already suggests, Chaos Hub, it is the hub where all the chaos experiments are placed. So what happens? The main part over, I'll explain firstly chaos operator and chaos monitor. Chaos operator is the middle layer between chaos runner and chaos engine. So basically, it watches chaos engine CR and launches chaos runner. This is the work of chaos operator. Chaos monitor is completely optional. Like if you want to monitor your chaos experiment in the form of graph or in form of something, so then you can use chaos monitor. It is completely optional. Chaos engine. Chaos engine is basically it contains main two parts. First is where your experiment needs to be executed, in the sense your service, and what experiments need to be executed. That is the experiment that comes from the chaos hub. As soon as we define these two requirements in chaos engine, a YAML file, it is defined in a YAML file. So a chaos engine.yaml file is created, in which all this information is contained, like where the experiment needs to be run and what experiments need to be run. As soon as we run this YAML file, chaos operator comes into action, and it launches chaos runner. And as soon as our chaos runner gets launched, it will create experiments job. Like if you have defined like if you want to perform just one experiment, then only one job will be created. And if you want to define multiple experiment, if you want to run multiple experiments, then multiple jobs gets created. This experiment job is the actual chaos experiment, like the actual job that is run. So this experiment jobs is run on your application. It communicates with your application and do the needful, like whatever experiment you want to conduct. So it will communicate with the application and run that experiment. So when we run that, we will show in demo too. Like as soon as we run our chaos engine.yaml file, you will see a chaos runner pod will get created for that particular experiment. So as soon as our experiment gets completed, a chaos result is generated, and that result, we can pass on this result and check whether our system failed or passed when we perform that chaos experiment. And apart from that, we can, if our system gets failed, we can even check the detailed information too, like where our system failed and what is the reason that our system got failed. So this is the basic architecture of Litmus. Now I would like to hand over to Prashanto for demo.
Thank you, Preksha, for this great presentation. Now, let me share my screen. It's visible, right?
No, not yet. Yes.
Okay. Let me start with the what we need to start the chaos operation. So basically, we have to first install the Litmus chaos operator in our Kubernetes cluster, and then followed by we have to pull the experiment from the chaos hub and set a service account and construct a chaos engine manifest file, and then we can apply the chaos engine to start the experiment. So so here I am applying the chaos operator manifest file to our Kubernetes cluster. So you can verify with the this command. In the litmus namespace, there is a pod created chaos operator. Okay, and we have some more custom resources with the name of chaos, so we can verify this as well, like chaos engine, chaos experiment, and chaos result. So basically chaos engine is a one which manages the complete experiment and schedule it. An experiment where we run a manifest file, and chaos result is where we generate a result after the chaos experiment is done. So now we can install sorry, we can install some of the chaos experiment from the chaos hub. So here you can see that I have installed pod network loss experiment, node restart, and container auto scale, and like pod delete and pod CPU hog experiment. So here we can basically focus on the pod delete experiment, where we delete our pod. You can check that we have some 5 pods of Elasticsearch container. Okay, so we delete one by one or extensively delete the pods and check what are the impact in this cluster. So we can verify this whether your whether your experiment is installed or not. So you can verify with the command called kubectl chaos experiment, and whatever the namespace is there, you can choose. So here we can see that many experiment are installed there. We can focus on the pod delete experiment. So for this, we have to create a first service account so that we can run our experiment. So here we can say any we can write any name like pod delete essay, and whatever the namespace is, you have to mention there. Like I have entered the ES namespace, and I am using the role binding here. There are two types of like a litmus service account. We can use the admin mode as well as namespace mode. Here I am using the namespace mode, so I am using the role binding with the same namespace. So basically now I am applying this service account to the ES namespace. We can verify the there are two service account is created. One is default and one is pod delete essay. Okay, after that we have to like we can verify our stateful set, like quick start ES default. It is our stateful set which is running 5 pod container. So we can annotate this stateful set to minimize the blast radius. If we don't annotate this and we have other cluster with the name of quick start, so it also get impacted. So here we can annotate our stateful set with the name litmus chaos.io. Chaos is equal to true. So in that case, only which is true, chaos is true. We perform, and like chaos engine perform only there. Now let me show the demo. What is pod delete experiment? So I'm forwarding my port to local. And watches the node as well as. So here you can see that our 5 node is working, and a quick start is default 2 is the master node right now. So what we can see that here we can see that the right now I have 5 pods. So now I am applying my pod delete a manifest file. So first view the what is inside the pod delete manifest file. So here you can see that the API version is chaos-litmus.io and the kind is chaos engine. Okay, you can name whatever you want, like metadata name, and you have to mention the namespace there. So in which namespace you want to install this chaos engine. After that, the main thing is here, like app namespace, app labels, and app kind. So here my app namespace is ES, and my app labels is the stateful set app labels. I put it here, and the app kind is my stateful set. Okay, and I yeah, annotate is a true. I then the annotate is true, and here is the main thing, like which service account is used by this chaos engine. So I mentioned the pod delete as a which we created earlier. And here is the main thing, like what duration you want to perform this chaos operation. Like I mentioned there, we want to perform the chaos operation till 30 seconds. And what is the interval? So here I mentioned that interval of 3, but let me increase it. So by the interval of 10, we can say that the 3 chaos operation is performed, like 10, 10, and 10 in the interval of 30 seconds. Now I am saved this operation, and so here you can see that a chaos engine runner is created. After that, the pod delete experiment is created. Now you can see that the one Elasticsearch container is terminating, and after 10 seconds, another pod is terminated. Now the second pod is terminated. You can check the cluster health with this command. Like our cluster health is yellow, it means it is not as per the standard. Your cluster health should be green, and we have only right now three pods. Now it's 4. So here we can see that if we increase our blast radius, and let me like if we put it at 5, interval of 5, so where what happened we can see here. So we can see that another chaos runner is created, and pod delete container is created. Right now our cluster health is green, but after few seconds a pod is terminated, a second pod is terminated, now our third pod is terminated. So here you can see that our quick start default 2 is the master node. After this is terminated, like here you can see that this is terminated, our connection is lost. Our connection is lost here. We can't access the nodes as well as indices of the Elasticsearch container, and cluster health is red. So here we can say that if our master node is terminated, so our connection is lost in Elasticsearch container. So we have to replicate our master node to 2 or 3, and we can plan in this way as well. So let me again start the port forward. And now you can see here. Now the third pod is promoted as a master node right now. So master switch is automatically done, but if the master node is terminated, our connection is lost. So we have to plan in this way, like if we, and how we overcome the disaster recovery if our master node goes down. So we have to HA the master node as well as maximize our slave node, so that we have minimal impact of if any pod goes down. So basically chaos engine experiment actually show us what happens if something goes wrong, so we can prepare with this. Yeah, I'm done with my presentation. Any question?
Yes, so we'll take up the questions.
Definitely.
Okay, hi. We have few questions. What are some of the experiments that Lenskart predominantly runs?
Like we in this infrastructure, we use the CPU hog as well as pod delete experiment and network latency experiment, so that we can leverage our infrastructure and increase the infrastructure availability, like 7.9 and 8.9. So we are maximize our pod delete and CPU hog network latency experiment we are focusing on. Any other question? Yeah, exactly. It is a preventive check.
How chaos engineering is different from load testing?
Actually, load testing is you have check the increase the load and what your infrastructure is behaving in if the load is increased. But in that case, if your pod goes down, suddenly your pod goes down, or your network is not available there. So what happens in your infrastructure? You can actually replicate the same thing with the help of chaos engineering.
Does it also suggest corrective actions? Yes, as we just saw now in this pod delete experiment, like our master node went down. So from that we can conclude that we need to take some actions, like as soon as the master goes down, instead of like taking the downtime in production, we should do something in order ki as soon as the master goes down, some other node act as the master node, so that our system doesn't go down.
Yes, we can leverage the pipeline with the chaos engineering as well. DevOps can integrate this as well. So you can leverage the chaos engineering benefits in your pipeline, in your complete pipeline flow. So you can do this as well. Yes. Let me share my screen again.
The results
You can
of chaos
see
experiment
the
logged by other analysis.
you can see the chaos experiment result as well. Here, if I so here you can see that in the same namespace, result is created with the name of chaos engine and the pod delete. So You can describe this. So here you can see that the what are the results of your chaos experiment you have done in your infrastructure. Like 46 minutes ago, we have wait and passed the experiment, and pod delete is result is passed, then awaited. You can see the result with the name of chaos result litmus.io. You can check with this. Any other question?
Yes, yes, it would really help, like if we execute, if we take chaos engineering into our companies or into our infrastructure. Like as I already explained, we can, if we run these experiments before our system went live, we can detect all the glitches or the abnormality, like on all the things that we need to work on to provide more better infrastructure. Any other questions?
Yeah, monitoring tool helps you if your system goes down in production, and chaos engineering work help you to actually simulate the same in same like say, you can simulate the same if your production environment goes down, what happens then, when what you can do. So it is a simulation, and monitoring tool helps you if your production goes down. So it is a preventive measure.
So
Well,
I guess that's it.
yeah. Thank you, Preksha and Prashanto, for the wonderful session.
Thank you.
So before we move to our next discussion, I have a small announcement. Like FG Forge wanted to share some free SWAMP UP 2021 conference passes with our community, as well as free technical deep dive tutorial day pass for June 2nd and 3rd in EMEA and APAC. If you want to grab the passes, join Collabnix Slack channel for more information. Thank you. With that, we will just, before we head on to our next speaker, we have panel discussion by Vinay Agarwal, Aditya Soni, and Apurva Bhandari. So feel free to post your question as it will be a free side chat session. Thank you.
Hey, thanks, Savita, for introduction. So good day to all. Very good day from wherever we are saying like right now live. I'm wishing you stay healthy and safe 2021. I wish everyone is doing good right now. Hi, so this side is Vinay, currently working with IBM ISL as a cloud developer. With me today, Aditya, he's working with a Red Hat, and Apurva, which is he's working with ThoughtWorks. Sorry for that. We're as a DevOps engineer. So very thankful to the OSCONF team. So for conducting this 2021, I would say that first OSCONF. So what I liked about this particular OSCONF is the worldwide speakers which share their experience, and it is very useful for us, right? So they share their experience at different domains under the one platform, and this really excites me. So every time we do come up with a panel discussion, okay. So this time also we came with a very hot topic, I would say that, which is going toward right now towards the industry, and that's all about right now GitHub. Okay, so I think many of yeah. So I think, yeah. So many of aware of that about GitOps or may not be. So I'm very native or new to that. So I want Aditya and Apurva with me right now to answer those questions, and I would like to share their experience on that so that other audience can also leverage that. So to start with the very layman question I would ask to the team right now, what is GitOps? How you can explain very layman or native language to everyone so that they can understand if they want to go ahead with the GitOps in coming time. So Apurva, you can start with about very layman way you can explain what do you mean by GitOps, And then Aditya, you can explain that.
Aditya, you gonna go on first?
No, you go first.
So GitOps. So first of all, if you look at the terms, you are able to know that it is related to some Git and operations. You will think like already DevOps is there. There are a bunch of tools in the market already. There are a lot of tools for CI/CD. Then why GitOps came in picture, and why do I need to go and learn some new tools that I can help the ecosystem? That is the first question in each and every one's in mind. That why should I go for the GitOps? So basically, GitOps is in layman terms operation with the Git. Developer will commit the code, and rest of the things will happen through the Git. I don't want to go with the tools like Jenkins, but obviously I'm using the Jenkins for CI/CD. But sometimes if I want to separate out those stuff like CI different and CD different, how I can go or how I can do with the minimum number of set of tools and minimum number of operations on the Git. Aditya, you want to go and explain much more about that?
Yeah, sure. Yeah, so this is a great pitch by you, Apurva. So basically, as you said, like Git is nothing but GitOps is nothing but we use Git as a source control tool. Yeah, that's all right about the GitOps. So in GitOps, what we do is like we use the Git as a major, I can say, single source of truth. Okay, so the Git will be your single source of truth. And let's suppose you have a team, and in your team there are working lots of engineers. Like there can be software development, there can be QA engineers, there can be DevOps. But as you said, like you are using Jenkins for CI/CD, then why to move to GitOps? Yeah, this is the main question is arising in every IT guy, or I can say any ops person now. So basically, when you use Jenkins or anything, then you have to do a push-based pipeline. Okay, so that will be triggered by an event. But when you move to the GitOps purpose, so there will be push-based and pull-based also. So GitOps actually works on the, I can say, operators. Okay, so that operator will monitor your current stage and it will check the desired state. Okay, so let's suppose you have something, you have changed the image tag. Let's suppose you've changed the image tag, and that should be replicated in your environment, so that you can do easily with that particular operator that is automated actually. Yeah, that's pretty much about GitOps.
Okay, so I could say it is more around like it is supporting to cloud native applications that I'm deploying in my microservices.
Yeah, so basically GitOps is made for the applications that are written like the declarative configurations actually. Okay, so if there's a infra that is written by the code, so that is much preferred to be GitOps. Use GitOps there.
Yeah, but I have a certain set of tools like Jenkins or GitLab CI or Travis CI in place where I have hosted a type of services and that I can use easily. Why should I go for the GitOps one? If all the sets and all the stables tools are there in my current environment, why should I go for GitOps?
Yeah, that's a great question. So basically, when you say like I have already my DevOps in place, why should I go for GitOps? Yeah, because see, GitOps is nothing. We are not replacing the DevOps. Your DevOps will be there, but what we're doing is we are just what I can say, the DevOps will be there. We are just creating a more layer on top of it, and that will be for your CD purposes. So GitOps mainly used for the continuous delivery purposes. Okay, so your as you said, like my Jenkins and everything that will be there, but we will just replace the tool name. Like as you are using Jenkins now, so in GitOps you have to use the Jenkins X. So as you are using their Helm, so there is a Helm GitOps tool, another there. So there's a Argo CD, there's a Flux CD. Yeah, you can use another tools instead of previous one. So it's like your DevOps will be there. It's not like we are just replacing the DevOps. That is not possible.
Okay.
Yeah.
So one more thing, like if I'm integrating with my current CI, is there any more challenges or learning curves, or there any who has huge knowledge to integrate GitOps in my current day-to-day flow for CI/CD, or is it easier one?
Yeah, it is easier one actually. That's no like there is no more effects, or I can say there is no more hands-on you have to do to replicate your current infra that is ongoing. So previously, what you were doing, you are using Jenkins for the CI tool. So So it basically create an image for you. Let's suppose a current environment, so it will create an image for you. Just build it and just give you the image. Okay, so now you are deploying it by Jenkins itself, but there when you're deploying it for the continuous delivery, so there can be some downtime there, so it gets some time. You have to just always replicate it or something like that. But when you will just use the GitOps approach there, so the Jenkins will be there, but at the code level, so your configurations will be on the Git, on the particular Git, and from the Git you will just sync the particular operator and to the Git, Kubernetes, so that will be deployed there.
Okay, we have Gaurav. Gaurav do not have DevOps background, but he's a developer. He's a CloudNet application developer. From developer perspective, I need to understand like why again GitOps.
Yeah, yeah, that's again, yeah, good question.
What is the questions are in your mind, Gaurav?
So I do have experience with Git. So I do have experience with Git. So the addition that I see, that I may not have to learn something new that is coming out of my plate. That is one thing. So I still live and survive in the same ecosystem that I have been used to, Git. But at the same time, even I have this question. So let's say if I'm trying to set up a CI pipeline that uses our GitHub tools and everything that you have in your plate, how do you manage your secrets? We had secrets configuration in Jenkins at least. I don't know how do you manage it in GitOps.
Yeah, so basically in GitOps, what you have to do, like as you said, like you are from the developer background. So let me first answer the Apurva question. That is for how it's be benefit to the developer person, and then I will come to your answer. Okay. Then so basically, as Apurva said, like how it will beneficial for the developer perspective. So in IT we have like in terms, if I can say, then there's a software development team, there's a DevOps, and now the new terms coming in the SRE. So there's a site reliability engineering. So basically what they do, they just handle the application code itself, and they also handle the ops team. Like they handle the ops work also. So on that perspective, why we are moving from DevOps to SRE, that also includes the GitOps. So basically now that developer also like as he do commit on the application code. Okay, so the application code start the Jenkins pipeline yours. Okay. So as the same thing, he can just upload the configurations or the, I can say, Kubernetes manifest file over the Git itself. Okay, so that will be updated there, and from that it will just go to routed in your particular environment. Okay, so that's how your developer also can I can say simulate there or can contribute there. Okay, so the next question about the Gaurav. So basically, as you said, like how we can manage the secrets over the GitOps. Okay, so in GitOps, as there are lots of tools available. So there's a Argo CD, there's a Flux CD, there's a Helm operator. So when you will do deployments by that tools, okay. So as we do now in because in GitOps, what you have to do, you have to just gonna deploy the deployments file from that particular Git repo to the environment, whatever environment you have. Okay. So as previously you was using because it will be synced with your Kubernetes cluster. So you can use the Kubernetes secrets over there. Okay, so you can manage your secrets over the Kubernetes secrets. Okay, so what we do, let me give you an example for it. Let's suppose your Jenkins is in place and you want to deploy after like any commits coming to your particular branch, and then your manager will pull accept it, and that will be merged to your main branch, and then the trigger will be start. Okay, so now let's get this flow. Okay, so now there are secrets available in your YAML files, as you said. Okay, so you will just point that secret to the Kubernetes cluster. So when it will trigger that to the particular Kubernetes cluster, so we have tools like Argo CD and all. So Argo CD is basically for the continuous delivery tool. Okay, that I will explain in my next session. Okay, so in that tool, that is synced with your cluster. So when it will check like there's a secret available inside your Kubernetes cluster particular. So it will just check it with by the cluster itself. Okay, so you can just write the YAML files there to create a secret there or to just manage it. Or instead of you don't want to do it's a deployment side, then you can do at the Jenkins level also. You can store the secrets in particular what I can say. There's a secrets store also there, so you can store there, and yeah, you can just replace at the deployment time.
Okay. In order to give more insight about the Gaurav's question from the developer perspective, how I can manage config map and secrets. So most probably when the word comes in picture GitOps, I have everything is there in my root directory of the code. So in my root directory, I will have my Helm charts to deploy the code. I have Docker files in place. I have code in the place. and those are means whatever starting from the development to deploy, all the things will be there in my root folder or the code directory of the Git repo itself, and from there this action will get thrown. So if I want to manage the config map or secret kind of stuff, I may have to use the wall type of concept, or I can keep my secrets and config map in my Helm charts, or I can directly access those config map and secret which are already deployed in my cluster, Kubernetes cluster. So again, if I go back to the term GitOps, why GitOps in place? So what I will do, I can use the CI for building of my image, and what GitOps will do, whether it is a Flux CD, whether it is Argo CD, or whatever tools, whether it is Jenkins CD, Jenkins X, what it will do, it will sense your code. Whatever we are doing with the help of hooks, same kind of like Jenkins hooks, where if I raise the PR, it will and PR is approved, then it will start doing your CI cycle. Same stuff GitOps is working. Like GitOps is sensing the changes in your deployment file, not in your code. Okay, so once my Jenkins has been done with my build, what Jenkins will do, Jenkins only promote or push my image name to my Helm charts. So again, at the same time, my GitOps operator or GitOps is pointing to my deployment YAMLs, and it will sense my, oh, the new image is in picture, so I need to deploy this application in my cluster. So there are like a couple of things where how I can restrict or control those deployments in my cluster. I can control whether I want to deploy that image in my cluster or not, that I can control. Or if I want to promote my image, what does mean by promotion of the image? I have built my image. Now I am deploying that image into dev cluster. Now I want to deploy same image in my UAT. And once the UAT is done, maybe I want to promote it to the pre-prod and prod. So here you are saving the build time, right? You are only building the image at once, and you are promoting that image into multiple environment. These issues, these scenarios, I cannot go with the traditional way of CI/CD like Jenkins or Travis or GitLab runners. That I cannot go. Okay, so this type of issues that I can handle with the help of GitOps, and I think Soni Aditya will show those some kind of scenarios in his session.
Yeah,
I think Gaurav has some clear idea about how GitOps works.
I know some bits and pieces only. I'm just kind of learning as a noob, I would say.
Yeah.
So in the experts, I'm the noob that will going to ask dumb questions for sure. So let's take an example about. So I was looking into Azure ARM templates recently, and what I saw that what they're doing is they have some certain. So let's say they have an example repository where anyone can submit sample Azure templates. And what they do is they run some CI pipeline, and then they try and deploy it on an Azure instance. So what I'm trying to understand is connecting to that Azure instance will definitely require you to have some kind of authentication. How does GitOps takes care of such authentication? We have talked about configurations and secrets, but authentication is a totally different mess.
Yeah, so I should answer on Apurva, you're going?
No, yeah, Aditya, you can go.
Yeah, sure. So basically, for the authentication part, so as you are saying, like you are using Azure and there's a template available, and by the template, you just the template actually deploy a code in particular instance, Azure instance, right?
Correct.
That I understand. Correct. Yeah. Okay. So we are on the same page. So basically, when you do the authentication part, so there must be in Azure something kind of rules like we use in AWS. So because I'm not too much aware of the Azure, but there can kind of something rules or something like that. So you can create a rule particular, and you are just deploying that particular template to the particular instance. In the same way, if I compare with the GitOps approach, then what it's happening, like as I said, like it's country deployment too, and it will let me tell you an example of the Argo CD because I'm much aware of it. So how it handles with the authentication part. So basically, there must be your Kubernetes cluster. So your code will be there, but to communicate to that particular code by the what I can say through the cluster. Okay, so because we want to deploy that code to the cluster, or the cluster as same, we can see the node is the instance. Okay, so if you want to do that, so you have to just create the configurations there, and for that you have to just because I will more show you on the demo next session. But there is something like that. We have to give the Kubernetes SVC. Okay, so there you have to connect your particular cluster, which cluster you want to deploy this particular thing. Okay, and you can deploy your Argo CD on the top of same cluster. You can just create a namespace there, and you can just deploy the Argo CD there. Then there is no need to use the authentication part there. But let's suppose if your cluster is somewhere else, then you have to use the configs there. So that by that config map, you have to add that to the GitOps, and by that it will get the permission to deploying stuff on Kubernetes on that particular default another cluster.
So I think we have a good question coming in from one of our attendees. Can we use GitHub Actions in GitOps?
Yes, it's just a creation of the image. If you use like CI tools, and that CI is creating a GitHub action again, your GitHub action is again replacing your Jenkins or CI pipeline, and you can add GitHub action as your CI cycle, and after that it will push your image tag to your deployment files.
And we also actually have a good question coming in. How can I use GitOps if if I'm doing deployments on nodes directly without having Kubernetes? Let's say if they are running maybe VMs or maybe just using Docker as such.
Okay, yeah, on the time also.
I'm not sure, but because I mostly work with Flux CD and Argo CD GitHub type of solution, where it is supporting to Helm charts or deployment YAML, KSONet or JSONet type of deployment stuff, and it is directly deploying into Node. I really need to look into whether it is supporting to my monolithic or standalone application which is deployed in my VMs.
Cool. Nice question, Aman. You gave us some food for thought.
Yeah. So I think, hi guys. So I think how it started, I asked very simple question, and that's what I loved about like how we went ahead in the discussion, right? So we all jumped in all the questions from here, and that is all about time, right? Like so everyone shared their experience in a short time, and we have covered all the topics what we want to do it actually in a single question. So I just asked you what is GitHub. I think we have covered right now all the questions, how it works, what all tools we are using for the GitHub, how it is different from Jenkins, and all those things, right? So I think that basically cover all the questions which you. So Aditya, do you know, like I just want to understand one thing here. What is the flow for the GitHub? If I say like in a one-liner, how we can implement in our current environment? Anyone who want to do that, so what steps he has to follow that? In a very short way, you can explain that. Okay, what precautions? Also, I would say like what all he needs to do that.
Yeah, sure. So basically, when you say like you want to adopt in your particular environment now, so there must be something I can say. There must be a DevOps team there, and they have there are certain tools there available. Okay. So now, if you want to come with a GitOps, so there is no more things you have to change. It needs only two things. That is two repos. Okay. So two Git repos. So one repo you must have because you have the application code on your Git. Okay. So that repo you have, and the second repo you need for that particular configurations. So configurations about the YAML that you want to actually deploy on the Kubernetes, okay, on the top of Kubernetes. So you need that particular repo there, and you have to put all the YAMLs there. And you can put that by the Jenkins itself, or you can put whatever approach you are using now, okay, because you don't want to change the available approach now, okay. So you can just git push, and you can just push the YAMLs, updated YAMLs here, or you can resync it by the Jenkins itself. There is a command resync, and it will just resync your available infrastructure, okay. So now whenever the code will deploy or code will change, the GitOps operator will sync with your particular Git YAMLs or Git files, I can say, from the commit, okay. So as the commit, you can check everything on the panel. There's a web UI on the RSVP panel, so you can check everything there, like whatever the commits last have done and how it's going, how it's syncing. Okay, so that you can check, and that's how this is the most easy way actually. If you want to just commit a new solution, and yeah.
Okay, great. So I'm hearing a lot about Argo CD. I think that is the most used tool in GitOps. I would say that, and I think the next talk is around Argo CD, which I think Aditya is going to cover on that thing. And that sounds great. Actually, we already has covered a base platform right now to set up what all GitOps to the public right now, so that they can connect more on the Argo CD. And yeah, so that is the main motto of this panel, right? So I just want to make sure everybody on the same page about GitHub, so that they can connect better in the next talk that we have. So I think I'll take one last question. I think there is a one question. Let me check on that. Can GitOps handle multi-cloud or hybrid cloud? Because I'm hearing lots about this is as we discussed, right? This is more about cloud centric, right? So is it about multi-cloud or hybrid cloud, or I think it is for both?
Yeah,
Yeah.
that can be.
So only what you need to do, you need to configure your cluster with GitOps. GitOps or Argo CD. That's it. Nothing
Okay.
else.
So it can be used on any cloud platform.
Yeah,
I think that is not bound to be.
endpoints I need to configure at my GitOps, and once cluster is accessible to my GitOps tools, it is easily it can easily deploy your stuff into that particular cluster. So it is not related only with I can use with the particular cloud. You can use with the hybrid cloud or on premises cluster or anything. It should be accessible.
Okay.
That's it. Same kind of like other CI/CD tools.
Yeah. Okay. I think that sounds. So I think other questions are around Argo CD, so which I'll delay for the next talk. I think you will be get answered, and we can take it in further. So I would say I'm just this panel discussion we are wrapping around. So I think that was very healthy and very useful discussion over the basically around the GitOps. And I would really thanks to Apurva here, Gaurav, Aditya. To join this discussion and share their experience around GitOps. So so we are dropping out from the panel discussion, and I am going to hand over to Aditya to continue over basically over the Argo CD, and he can explain more on that thing. So thanks to the team for having the discussion about GitOps. Yeah, thanks.
Thank you.
Yeah. Thanks. Just one last question. What are the other options to the Argo CD, and why do you want to promote Argo CD?
There is nothing like I want to promote it. There is lots of tools available there. There is nothing like paid promotions.
But I cannot say the promotion. But why do you want to choose? Because while looking at the Argo CD, what I find like multiple advantages over other tools like Flux CD or Jenkins. Argo CD can give
I
that
answer.
or something like that. You can explain and you can start your talk.
Yeah, the only answer I have for this, like I have time limit of 30 minutes, and in 30 minutes I can show only one tool. Yeah, that's perfect, I think.
Yeah, that's a sharp answer, Aditya. You have taken very good way actually. So I think you can continue on that, Apurva. I think it answered your question, or else we can take it in next talk. That will be better. So yeah, thanks, Gaurav, Apurva.
Thanks everyone.
Yeah, great, thanks, man.
So we have our next talk by Aditya Soni on GitHub's automated continuous delivery approach on Kubernetes. So I think by now we all know about Aditya, but let me introduce him. He's a developer who fails for automation and can think out of the box, a very curious person who wants to know every bit of backend and love to troubleshoot work at Red Hat, OpenShift containers platform, open source. Aditya is so much keen for DevOps methodologies and cloud, and always look forward to integrate his work with the best fit to his organization. With that, a warm welcome to Aditya.
Yeah, thanks a lot for the welcome. So let me share my screen. So hope you all can see my screen now. Okay, so welcome you all to the Open Source Community Conference OSCONF 2021. As previously we have already discussed in panel discussion, but let me start with the very basic. So this is the topic I'm going to show you today, like Argo CD, GitHub's automated continuous delivery approach on Kubernetes. So how you can actually automate your continuous delivery approach on Kubernetes using GitHub, using Argo CD actually, and that is the tool by the GitHub approach. Okay, as we already discussed about lots of tools there, but I'm just explaining you about the Argo CD terms and how it can be beneficial for you. Okay, so the first thing I want to, as I already introduced, but let me start with the Git. So who am I? Because you are listening me, so you must be know like why you should listen to me and why I am the right person to give this talk to you. Okay, so I am Aditya Soni. I am working at Red Hat at TTSE, and I am a cloud and DevOps enthusiast. I'm open source community contributor and AWS community builder, and lots of information you can find on my LinkedIn. And you can connect me over Medium also if you have to check any blogs or something like that. Yeah. So the agenda for today's talk is like yeah. So when I learn anything, then I ask three questions to my like what is the term and why should I learn it and how it can be beneficial to me. The same question I think the all the learners or all the listeners must have, because if you are listening, then you should know like why I should listen this and how can integrate with my running approach. Okay, so I will brief about the today's topic, how it's evaluating the previous tools available there, and the GitOps, what it is, why we are moving toward this, what are the objectives behind the to moving towards the GitOps, and why is the next big things about after the DevOps and automation. So I will include this, and I will give you a brief about the GitOps tools, what are the tools are available in the market now, and I will explain like what is Argo CD, the workflow of it, like how the workflow is going from the test to build to deploy. So that should be there, and the architecture and features. And later on, I can show you installation overview if time allows. Else, I have a particular environment setup. I can show you that also. And yeah, there's a, if you want to do something in Argo City, then there's a two ways, CLI and GUI. That's a basic way in any of tool. So that's there also available. So I will show you the both way, and then hands-on demo and the queries. So be ready for it. Yeah, so the brief about today's topic. So the topic is Argo City, GitOps automated continuous delivery approach on Kubernetes. So let me create a base for you. So when we say about GitOps is a new approach, so what are the approaches previous from it, and why we are moving to it, or what are the evolution that comes to in our mind. So let me go to the before the decades when we was on the waterfall model. There was nothing like CI/CD terms and the continuous or automation. Nothing was there. Then we come to Agile, then DevOps, and now we are coming to GitOps. So previously, what we was doing, we were so there's an evolution of approaches. Okay, so previously we was doing everything by the manual processes. Then we come to the automation. We was doing the package manager of Bash. We was using package managers and we was using Bash scripting to do our automation task. We will do this, and now we are coming to containers because we all we bind the image, all the tasks we want to do, and we will just create the containers image and we just deploy it again and again. So that's how this is evolving. And previously we was using the spreadsheets, over we actually note whatever the configuration changes I have done. So the again next developer would do with this. So from this we comes to the configuration as a code, like Ansible or anything that you can use, and you can just deploy anything on anywhere, and that will be managed by your tool itself. So yeah, previously we was having the all the teams like Dev, QA, security team, and the ops team. So by combining all them, we just come to DevOps. Okay. Okay, so now the next thing is previously I was focused on the CI, like how we can integrate lots of tool in our particular manner. But now our main approach is focus on the CD, because you will integrate anything that is not there, because that is not a particular thing you can just integrate an API and you can just create a calls. But how you will deploy your particular thing, and there should be no downtime because your app is live. Okay, so on that particular perspective, you have to check on the CD part. So we are now focusing on the CD part. And if I say about like evolution of the ops and CD approaches, so that's how it's replacing the DevOps, because in DevOps we have not much about the CD approaches that can be handled. So we are coming to that from the GitOps. So at the right side of the slides, you can check like GitOps from you coming to DevOps from we are coming to GitOps, and the left side you can check the lots of the automation process that how the industry are evolving. Okay, so the next is yeah. So what is GitOps? Yeah, that's the new normal, and we all are talking about it. So let's have a look on it. Okay, so in the particular the diagram you can check on my screen at the top. There's a development team at the left side, and that's a production team at the right side. And what actually done is like development team only manage previously like only the application code. They don't do manage your production or how to deploy it. They don't know it, and they don't want to do know it also. So they what to do, they so company has the DevOps engineers and they do stuff for them. But now everything is changing. We are coming from DevOps to SRE. SRE is like site reliability engineering. So the software development team will itself do the production work. or it will handle the ops team or the ops work. Okay, not everything, but yeah, most of they can handle. Okay, because in the big organization like Amazon, or we can say there is no DevOps rule or DevOps team. The development team also itself handle everything as a SRE. Okay, so that's how the development team can handle everything by the production itself. Okay, so there is, you can see at the mid at the Git. So in GitOps, the Git is like everything is a source control. Okay, so we use the Git as a single source of truth. So everything is coming to Git. We will get to the production. So that handles your company's manager or something like that. So let's suppose if a developer just creating a pull request and that pull request got merged, then only that will go to the production. And in this case, I'm not saying about the application code, because application code anyway is going to build. I'm saying about the configurations. Configuration in the sense, as if you know about the Kubernetes, so there we have the YAML files manifests. Okay, so we deploy them. So now you don't have to just only focus on the application code. Instead of, you can just focus on your particular YAML files or your Kubernetes deployments also from that particular Git. Okay, so you can use the, as you are using already Git, and you can use that for the deploying also, or delivery also. Okay, so GitOps is nothing but it's a builds on a DevOps and use as a Git as a single source of truth. Okay, you can use GitOps in like declarative configurations, so that everything is declarative. You don't have to it's not like you can just change by the declaration. Like you can just edit whatever you want to change, and that will be changed at your environment. Okay, robots do all the work. So what the statement states, so robots do all the work means in GitOps we have the operators, and that's why it's said like robots. So let me go inside it. Like in GitOps, like we have two approaches, or I can say previously if you're using CI/CD, then you must have the two approaches. The first is push-based pipeline, and second is pull-based pipeline. So push-based pipeline, what it does, like you must have the tools like Jenkins, Circle CI, as the previous talk also we discussed. So that uses the push-based approaches. In that, what happens, like your Jenkins will create an event, or your particular code will create an event, and then it will happen. But in GitOps, there are the operators are available, or they use the pull-based pipeline. So pull-based pipeline, what they do, the operators always check your particular running environment and your existing environment. Okay, existing, or I can say your Git repos, and they will sync and both at the same time, and they will check the desired state and the required state, and accordingly they will just do the I can say the deployments. So in GitOps, you can say the synchronization. So they will sync according to your Git and to your production state or any of the environment. Okay. The third, fourth thing is like continuously coverage and healed. So let's suppose if something goes down, any pod got crashed or something like that. So according the operator, that is a robot, or I can say, yeah, that's a robot that will just monitor your present environment, and it will check accordingly to the Git. If something has happened wrong, then it will automatically do the changes for you. And there are lots of strategies you can use that we will discuss later. So I think it resolved. So next thing is why we are moving towards GitOps. So in this diagram, you can check the first picture is like traditional approach. So there is a developer. He is just deploying his resources on the Kubernetes by using some kubectl command or something like that. So in Jenkins, let's suppose if you're using Jenkins and you want to deploy something on that particular Kubernetes. So you will just deploy Kubernetes YAMLs by the Kubernetes plugin, or you will the developer will do it for you by the YAMLs manually deploying. But this is a lot of there is a lot of like rework there. Okay, so let's suppose if someone change and again another developer is coming, he will, because people left the company and again new person are come. So how he will know like what are the configurations previously was there and how they done it, or how they change it, or why they change it. So accordingly they can approach it. So previously it was traditional approach. The second, so why we are using GitOps? This is the main reason. You can use configuration repository. Okay, so there can be two repo. The one is the application code that is always there in any environment, we can say, because everyone uses VCS, version control tools. So that is there, and you have to use one repo, that is a configuration repository. And if any developer or any DevOps guy just want to change anything in your Kubernetes, they have to just deploy, they have to just commit their configuration over the Git. Okay, so by the Git it will be deployed to your environment. So how it happens like this. So you can check, like there's a developer, he is just deploying, he's just connecting to Git, and the Git it's deploying to the Kubernetes, and there is a at the mid there is a sync operation is doing. So it actually monitor the state of your Git and state of your cluster, and accordingly it will just deploy the resources. Let's suppose you have just changed the particular image tag on your Git repo, and that is not synced your Kubernetes. So this particular operator will just monitor and it will just deploy it over the Kubernetes. So that's how this GitOps work and why we are moving toward this. So how it works? Yeah. So GitOps, like how it works. So at the left side you can check that there's a desired state. There's a Git repository in your all YAMLs, JSON, TS, whatever files you can just put over there, because that should be an infrastructure or the declarative things. Okay. And at the another side you can check the running infrastructure. So you can just run it. So there's a GitOps operator that already explained you in the previous slides. Okay, so and the observability tools. Observability tools can be anything. You can just integrate any tools like Prometheus, Grafana, or you have any third-party tool or open source tool. You can just integrate with it to monitor it or to get the insights like how my cluster is doing, things like that. Okay, so that's how the GitOps work. So it always sync with the operator and it will just deploy to the state. So next thing is GitOps tools. So what are the tools available in the market now, or if you are using the GitOps approach, then you should aware of like I'm using Jenkins now, but I want to use GitOps. So how I will move to it to there? Okay, so that should be clear in your mind, because it's not easy to move anything or to replace anything in your running infra. So if you're using Jenkins, then there's a tool called Jenkins X. So that's the CI/CD platform for Kubernetes. Actually, that provides the more GitOps approach. What I can say, continuous integrations. Okay, there's a Argo CD that I will explain you. That's the declarative continuous delivery for Kubernetes. So it handles your deliveries, or I can say any code is coming, so it will deliver to your particular Kubernetes cluster or any environment. Okay. The next thing is alternatives. So it is a pull request automation. So let's suppose any developers are working on Terraform. Lots of developers are working on Terraform, and they want to sync with each other. So what we do, we just save the states over the S3 buckets or any other platform in Terraform. Okay, so we just save that. But by the alternatives, you can just create your Git repo, and accordingly, it will just create the by the pull request, it will just automate your things. And there's a Flug CD. It's also a GitOps operator. There's a Helm. So there's lots of list of tools available there, and yeah, you can check them, you can use them. Everything is like most of them are open source as I gone through them. Yeah. So the next point is, what is Argo CD? So this is the main topic for the talk, or this is the main thing I will explain you in this particular talk after the GitOps, because I can't jump directly to GitOps Argo CD, like how it's going and we can do these things. Okay, so what is Argo CD? So Argo CD is nothing but declarative GitOps delivery tool for Kubernetes. Or if I will say you in a layman term, then you can just deploy your things from Git, a particular Git configuration repository that we already created previous slides. You can just sync your particular repo to the particular cluster or particular infra. So that will be synced with the particular tool called Argo CD. So it will handle everything for you. You don't have to worry about to maintain something or something like that. Yeah, you can just create triggers if something goes down, so you get alerts accordingly. Yeah, that you can do there. Okay, so some features of Argo CD are like templating. So you can create help templates, customize and more. So you can create these kind of templates, and you can just put this template over your Git repo, and your YAMLs also, manifest also you can put over there, and that will be deployed or that will be run over your Kubernetes. There's the configurations. So it always monitors your live state against the desired state, as I previously also said. Like it always maintain or it always monitor your Kubernetes particular state, that where you are, and what is the state written by your particular ops team or the developer in your configuration file. So that should be there, else it will just sync it and it will just replace that. Accordingly, you can just create a manual thing, or you can just create a automatic approach there. Okay, the third thing is enterprise ready. If you want to integrate the same with SSOs, multi-cluster or audit trails, so you can do these things. Integrations are available there. And if there's extensionability, I will say, so there's a, if you want to interact with Argo CD, then there's a CLI also available, and there's a GUI also available. So this is the most basic way actually available for any tool. So you can use the both in the particular Argo CD. Yeah, so the next is the workflow. Like how's the workflow can be of the Argo CD? Like how can be my pipeline if I use the Argo CD? Okay, so what you have to do, at the left side you can check there's a guy who's a developer. So he has two particular repos, as I said previously also. There's the application repo and there is a configuration repo or the config charts. Okay, so now the developer will commit their code, the application code, to the particular application repo, and that application repo will go to the CI pipeline. That is the third thing to the upper. And in the CI pipeline, you can check there are available tools like Jenkins X, Argo CD, and yeah, you can check these tools. And after that, the CI tool will do its work. It will just build the image. It will just push the image, and image repo will have your image registry or a particular image. And now let's suppose you want to deploy that image. So now what you will do in your what I can say. Your previous approach or the traditional approach, you will just use any Kubernetes plugin or something like that in Jenkins, and you will just deploy it over to Kubernetes or something like something another. But in the case of GitOps, what you can do, you have just created the image repo there. So you will just resync your particular image tag, and you can just get the particular tag from the Git itself. Like you can just create a Git tag like your commit ID, and that commit ID should be replaced by the configuration repo also, and that CD pipeline will be triggered, and the CD pipeline will trigger to the Argo sync. Argo sync is nothing but an operator in Argo CD, so that will check your desired state and this state, and it will deploy your things on the dev, test, or plot, whatever environments you have. And you can use there lots of things like strategies, deployment strategies like blue, green, canary, so that all things are available in the Argo CD. You can use them and you can test them. I will show you in my like demo. There I have deployed one thing, the blue, green, and canary. Yeah, so this is the Argo CD architecture, like how its architecture look like, or what are the components are in it, and how they actually talk with each other, and how they do the configuration changes. So see, there's a user. So user are like we all are the users of it. So user can interact with the Argo CD by the Argo CD web UI or Argo CD CLI. Okay, so these are the two guys. Like these are the two who can interact, two ways by the interact user can interact with the particular cluster, and that integrated by the Argo CD server. So Argo CD server is nothing that handles your all the requests. So first request is coming, so that will come to your Argo CD server. So it depends. You want to just create a load balancer. You want to create a cluster IP thing there. So you can do just like these things on the Argo CD server itself. Okay, so this kind of this thing. And the second thing is like GitHub repo. So you have a GitHub repo and you want to check like my Argo CD is thing failing. So what thing I have to check? So in the particular Kubernetes cluster, you have to check your repo server. So repo server, there's a container. So that will be there, and you have to check like everything is all okay there. It's failing, or what is happening there? Why it's not syncing? So you have to check the Git repo server that is already synced with your GitHub repo. The third thing is your app controller. App controller, what it will do, app controller actually sync with your desired state and the particular available state on your GitHub repo. So this thing the app controller is monitor, and it will just change accordingly whenever it got something wrong or something like that. And Redis or Dex server, so Redis and Dex server are nothing but they just maintain your databases, or what are the cluster you are already logged in, or what are the users. So the small database they just logged in. If you just lost it, then there can be something issue for you. So in this particular diagram there are the three clusters like 1 2 3. So you can integrate lots of clusters there, and you can just authenticate them also. Yeah, so Argo CD app setup. So you have to set up a particular application over Argo CD to maintain it on the Argo CD. Okay. So basically the first thing is you can do it by CLI, you can do it by the GUI. So in the right side you can check the GUI thing. I will show you the demo also, but in GUI you can create a new app. Just click on the new app and you have to fill all the information, and it will do the later things for you. But let's suppose if you want to do from CLI, then you have to create a YAML file like this. And in YAML file, if you can check, so I have, so I have this particular thing like repo URL. In repo URL, you have to pass your repo URL. It can be private or can be public. So now I'm using the public URL, but yeah, you can use private URL and you can just pass your token, or yeah, you can get a tokens to this particular URL. So it will just sync with it. Okay. So now I'm using this particular URL. It's available on my GitHub. You can check it, and I will sync it with the next demo. Yeah, so it's a quick demo time. Okay, yeah, so we have time also. Yeah, it's a quick demo time. Let's start the demo. Okay, so yeah, this is something is ready. Okay, connect it. Okay, so let me explain you things like So I'm not going to explain here like how to install it. For installing it, I will give you a preferred link that from that you can install it easily. So what happens, like you have to just create a namespace and you have to just use the particular apply or Argo CD. So it's a new project and they have already their YAMLs and how to install it. They have already, everything is ready at their place. So you have to just use this particular YAML and it will do all the things for you. So I have already run these commands to save the time. Okay, so when you will run now, this will be easily deployed, and then you have to install a particular thing, that's Argo CD CLI. So by that Argo CD CLI, it will be just installed for you. Okay, yeah. So let me show you now the particular thing. It's up. Yeah. So in this particular namespace, I have deployed everything. Okay, so I have created a namespace called Argo CD, and in this particular Argo CD, there's everything is deployed. Okay, it's time. Okay, it's got lost this access, I think. Yeah, it's worked. Okay, yeah. See, so you can check. When I go done by the kubectl get all -n. So this is namespace, and I am just checking what are the things are deployed there. So you can check like there are Argo CD deck server, there's a Matrix, there's a Redis server, and there's Argo CD server that we talked about, like what component talks to which. So that's the all the server. There's a Redis thing that always store your all the database thing, like whatever the things are there. There's a deck server also, and there must be a repo server. Yeah, this repo server sync with your particular Git repos. So if you have any repos, then it will be synced with your repos. Okay, and now there's a deployment. So let's start it. So after installing it, you can so now I have just done the load balancer kind of thing here. So you can just use it by your load balancer, or you can just create by the port forwarding itself. So now I'm using this particular IP. So this IP is belong to here. So when you install it, so you will get a screen like this. The first screen you will get like this. Okay, so you have to log in with your username and the password. So username, the initial username the GitOps provide you is admin, and the password you can check via some commands that's available there. Okay, so I'm just using my password. Yeah, so it's logged in. So there's already an app. I just actually started it. Okay, so I can show you this also, but I am not preferring this. I will create a new for you. Okay, so you can just create a new app by just click on this particular thing. As I show you in the PPT, like you can create by GUI. So this is that GUI thing. You can create a new app, and when you click the new app, you have to show these things. You have to click on this thing, application name. So what the application name you want to prefer. So now I'm typing is OSCONF 2021. Okay, and the project. So project, I'm choosing the default. This is nothing but you can create another project also, but I am using the default project where my Kubernetes cluster, because I have the Kubernetes cluster and the application will be on the same cluster. Okay, sync policy, you can type manual or you can type automatic. So what's the mean of it? So as I said, like there's an operator kind of thing. So this is that. If you will do the manual, then you have to, after doing any push on GitHub, then you have to come here and you have to check this particular manual, the sync button. So you have to sync apps there here. Okay, if you will do the automatic, then all the stuff it will do for you. But now I'm first approaching the manual approach, then we will go to the what I can say, the automatic approach. Yeah, so the source. So source is a repository URL. So whatever repo you have, you can just put your repository URL here. So I have already my repo running over here. I can show you. Yeah, this one. So I have this particular repo in my GitHub account. You can check this out. Okay, in this particular repo, I'm using the same repo and I have some YAML file already placed in place there. Okay, and yeah, so let me put the URL of the repo. I just copy here. Not getting much time. Okay, so this is the particular URL. So after it will check the head, whatever branches you want to just conclude, you can just check it, because there is no branches available in this particular repo. So it's not getting with, but you can just sync with your branches. Okay, then there's the path option available. So path option is like, as I said, like I have my repo available, but in repo, I have just created a folder Argo CD. So the same thing, the same way you can create multiple folders, multiple hierarchy. You can create whatever things you need first to be gone and then the next to be started. So like this, you can just create it, or you can just give the path according to your applications. Okay, so that's how I have given the Argo CD, and just I am passing the path here, like Argo CD and slash. So it will just go to the Argo CD and it will just check whatever the files are available there. as a destination. Destination is the cluster thing. So where you want to just provision your everything. So now I'm using the default cluster, that is where my app is deployed. And for the namespace, I'm using Argo CD namespace there. Okay, so there is nothing we have to do now much. We can just we are good to go to create a particular app. Okay, so we have created an app called OSCONF 2021. And so now you can see this particular app has warnings, and yeah, it's deployed, I think. Okay, so let me do it minus minus. So you can see this is the whole structure of it. Because how why this is working like that? Because in my particular repo, what I have written some deployments like what I can say, canary and blue green deployments over there. So it's deployed everything, whatever available there. So there was a MySQL container. So let me zoom it out so you can check it easily. Yeah, so there was a MySQL container that is deployed, and it's saying out of sync. So I will explain it later. So there is a rollout blue green, active blue green, and you can check canary also. And accordingly, it will just deploy other steps, whatever written by you on the manifest. Like let's suppose you have written there one, you need this kind of pod, you need file system should be there, you need should be integrated with that. So it's saying out of sync because as we have tested and we have checked, like we want a manual sync there. So let me sync it. So it will be, we will click on synchronize and it will sync. And after synchronize, it will say like everything is synced with the particular repo. So you can check like sync is okay. So because we have choose the particular manual sync there, so that's why this thing is coming here. Okay. So this is the particular GUI thing. If you want to do the same thing from the GUI, from the CLI, that you can follow this approach. Okay. So in this, what it is doing, you have to just do the same thing that you done on the app create app thing. Okay, so we have created here jenkins.git. So we have given your repo URL, we have given our path, whatever the path is there, and it will just deploy the things for you the same way. Okay, now I will show you a use case like how it the operator actually work of it. Like let's suppose I am doing something changes on my particular YAML and how it's deployed. So I have application as I showed you, like this example app also. Okay, so it's saying it's not synced because we have to sync it again. So when we sync it again, it will just sync okay. Okay, so yeah, so now its sync is okay. But let me show you one thing, that is you can check this particular link. So this particular URL is coming from yeah, from here itself. See, so there is the service called rollout blue green preview, and there is a load balancer, and there is the same IP that I have created here. Okay, so now I will do changes in my GitHub repo that is in the blue green. Okay, so in blue green I will just change the name. So now you can check there are the red balls incoming in the particular Argo City, because I have given the container name should be red, as you can check here. Okay, so the container should be red, or it will just provision the red ball only. So now I'm doing here green balls. Like now let's suppose this is the same way your developer will come and change the tag of application. So I am just doing the green, and I'm just doing the commit changes. Yeah, so this is the done by the commit changes. So now I have committed it, and now it will say like you are not out of sync, you're out of sync, it will say. See, so now there is no green balls coming, you can check it. Okay, so there are only red balls that are coming in. But when I will sync it, because we have already selected the menu sync, when I will sync it, so it will just come with the green balls, because in blue green deployments, what it does, like it will just create another deployments for you. It will just start one by one. Like it will not just down the previous deployment, it will just start the again next one. So it will do sync your environment by one. So that's how it started. So previously all balls was red. So when we just sync it, so it started to deploying your new container. Okay, so it's deployed the green deployment like whole over like 100%, then it's just replaced by the red one. So now your all the balls are coming from the green. So this is a simple application, or I can say simple overview of it. The same way you can do anything you want for the continuous delivery for it. Yeah, I think that's enough for this talk, and time is also there, so you can ask me if anything you have. Okay, so we have done the quick demo also. So thanks for joining me and watching this whole demo and listening me. So if you have any question, you can ask me, or you can just mail or connect on LinkedIn. There is no issues. Yeah, that's all.
Thanks, Aditya. Thanks for the wonderful session. And I guess all of your question is answered live by Apurva. He was handling the YouTube. One question, can GitHub handle multi-clouds or hybrid cloud?
As we
If you can
checked,
highlight on this.
yeah, my screen is shared or not? I want to just confirm.
No, your screen, you're logged out of the screen, but you can just
Yeah, no
talk
issues.
and answer the question.
Yeah. So basically, you can cloud can be any. You have to just a Kubernetes cluster. So that cluster you have to just put in your GitOps. Okay, so in GitOps, as we just authenticate with our cluster, so as the same way you have to just config map, and you have to just give the cluster you want to use. So it's not a hybrid cloud of architecture, but yeah, you can deploy on any cloud. It's kind of this. You can't handle the multiple clouds at the same way or like this, but yeah, you can deploy on multiple clouds at the same time. That's what I want to say.
Okay, thank you. Thank you for a wonderful session. We have our upcoming next session by Gaurav Gahlot. Let me introduce Gaurav to you. So Gaurav is going to walk us through how we can run GitHub Actions locally with DIND and nektos or ACT. Gaurav is working with infra cloud technology as a product engineer. He is a core contributor to the Tinkerbell project and is primarily focused on developing solutions around bare metal provisioning. Gaurav is Docker community leader at Pune and also co-organizer for Kubernetes Pune and Docker Pune. With that, a warm welcome to Gaurav. Over to you, Gaurav.
Thank you, Savita. Thank you, everyone, for having me. I hope I'm audible, and I'll just pop in my screen. So I hope the screen is still visible. Awesome. Cool. So my name is Gaurav, and thank you everyone for having me on this OSCONF. I've been really excited. I've been contributing any way possible to this. Thank you for all the great talks, and thank you everybody for joining in. Let's get started. Who am I? I am Gaurav Gahlot. I'm a software engineer working with InfraCloud. I am a Tinkerbell maintainer, and I also contribute to gRPC Go and some other tooling. I was active in Docker getting involved. That is now available, which I think Ajeet has already shared with everyone. I'm a Docker community leader for Pune, and if you'd like to get connected with me, follow me on Twitter or connect with me on LinkedIn. I'll be more than happy to talk to you about anything that is there. So about the talk today, what I'm going to do is I'm going to introduce you to nektos ACT. I'm not a contributor to nektos ACT, but a problem that I was facing recently in Tinkerbell led me to try out running GitHub Actions locally. And that's how this whole thing started. And I really like the product. It has some limitations, but I think it's a great starting point for anyone who is interested to run GitHub Actions locally, and it should be good to go. So we'll be looking at why anyone would like to try it out, what nektos ACT is. We'll have a quick demo, and then we'll give some limitations or word of caution about using nektos ACT. So let's start with the why. One of the reasons why, so we have been listening a lot about GitOps. We also talked about Argo CD, and at the end of the day, we have to design CI pipelines that do what it needs to take while compiling your applications, cross-compile it, run it, and make it available in form of be it binaries or Docker images, and deploy it somewhere. So if for any project that is basically moving from traditional way of deployments to CI/CD, what you have to do is you have to design a GitHub Actions pipeline, and which is under .github.workflows. And this is nothing but a step of workflows that are going to be executed as your CI pipeline progresses. Now, when you're doing it, what you have to do is you have to keep changing your CI pipeline, commit it to the master branch so that GitHub Actions or workflows could kick in and make sure that, okay, this pipeline is good and is in a working state. This increases a life cycle of trial and error, because you may do some mistakes while you are modifying your CI pipeline. So what nektos ACT enables you to do is you modify your CI pipeline, test it locally, and once you're sure that, okay, now this is ready and could go on, onto the live state. You just push it to the master or merge it to the master, and then it's there. The other thing is no more make. All right, so I'm not an expert on make. I do have some basic idea of use it now and then, but let's be very honest. Make looks dirty on a, you write a shell script, which some of them write their own way and some will have some other ways of doing it. So I don't know, it can be very confusing for any beginner to look at make and be lost what's happening around it. So what you can do is replace your make files with CI pipelines that are running locally, and yeah, you're good to go. Understanding a YAML is much better than any bash file, I would say. Embarrassments. Oh yeah. So it happened to me a lot of times that I made mistakes. I made a lot of spelling mistakes, and that was not intentional. Obviously, that was like, it just happened while you're typing fast and you're trying to be, at the best of your time. So you don't definitely want to go ahead and, fix things, git rebase, force push. You can avoid this whole mess and just use your GitHub Actions so that you have those spell checks implemented in your CI pipeline, and you save all the embarrassments in front of your team. Okay, so what is nektos Act? nektos Act is an open source project that is available on GitHub, and it basically, what it does, it runs your actions, your workflows as a Docker containers. So it's all you need to know about writing using nektos Act is a bit of Docker, maybe not essentially, but yeah, it will help at least for the debugging part. Then the other thing that you might know is writing your GitHub workflow pipelines, and that's it. The other thing that you want to be aware of is runners. Basically, a runner is a GitHub action runner, which is going to take your code, your block of pipeline that is to be executed as a workflow, and it then what it does, it looks for that Docker image if there is one available for that particular action. If it's not, then you can actually define your action steps through which that it can develop an action image. It will take a runner, and on that runner, it will deploy all those actions as certain jobs, basically. Now, nektos Act comes with different flavors of runners. You can have a slimmed version of a runner. You can have a medium-sized runner that could be ranging around somewhere 500 to 600 MB. And then you can have a full-blown runner, which will have absolutely most of the things that you have on GitHub Actions pre-ready for you. But remember, the size of the runner is going to be somewhere around 2 gigs. So be careful about that. And I think medium size of runners is more than happy. I mean, you'll be pretty happy with that. So I'll give you a walkthrough of how you can, where you can find those runners and how you can pick one. Configurations. So Act is being developed as a command line tool as well. And what it does is it accepts certain parameters and options that you can use while you're running your GitHub Actions locally. At the same time, while this could be very confusing, you also have a provision of using configuration that is known as Act RC. So basically what you do is you define an Act RC file, put your configurations inside that file, and which will be like sourced automatically. And then the options will be read, and Act will do the jobs according to the configurations that you have given. Let's do some action. So for this demo, I'll be using nektos Act, obviously, and I'll be using a very simple CI pipeline for the demo. Because I'm running on a Mac Air, it could be like blown away, which actually happened a few minutes ago, that I was using a different runner and I accidentally happened to crash my system, and I had to cancel or postpone my talk. So I'll be using Docker in Docker, which makes it a lot easier for me to write a simple thing. So let's jump on to the demo. I'm hoping everything is still visible on the screen. So in this directory, I have CI, GitHub Actions demo, and a Tink directory. Tink is basically a Tinkable. I'll be starting with GitHub Actions demo, which is a simple one. Let's open this in code and see what we have. Alrighty. So to build a CI pipeline, I've used this Docker file, which is pretty straightforward to follow. I'm using Docker in Docker as the base image. I'm adding curl to the Alpine. So the DNA is actually based upon Alpine. So I'm adding curl, and then I'm using curl to install Act from the script. After that, we can ignore this act RC for the time being so that I can show you an issue that you might probably run into. Then what I'm doing is I'm creating a work project directory. And then at the end, what I want to do is run act and write the logs to these logs, run.log and dry run.log. That's basically it. Act RC, we will look in a minute. So let's jump in. Let's build our Docker image. Oh, I have Docker stopped. Why can't demos go in a single way? Why do they always have to have some hiccups? I don't know. It's like with most of the engineers, I believe. I'm not the only exception. So let's give it a second. Should be good in any second now. Come on. Oh, it's taking longer than I thought. Okay, so Docker is ready. Just build the image again. Okay, our build is ready. So clean this up. So what I've done is I'm going to export my project directly as GitHub Actions demo. And what it basically has, it has a CI pipeline that you find under GitHub Workflows at main.yaml. So this is the CI pipeline that I'll be using to demonstrate. So it basically what it does is takes Ubuntu latest and this. So nektos act will what will do, it will find a runner, appropriate runner for this Ubuntu latest runner kind, and then it will just do this action, execute this action. So let's jump in back. Let's take our Docker run. So let me walk you through what I'm doing here. In the meantime, I'll run this. So I'm mounting my Docker socket as a volume inside the container. Then I'm using this exported variable, which is like my directory inside project. And then I'm creating a directory as logs to see all the logs. Let's tail the log. So as you can see, there's a message that is actually asking me to choose which kind of runner I want to use, whether I want to use a large runner or I want to use a medium one or I want to go with a micro. And this is happening because I have not provided nektos act with the configuration that it really needs to know that which kind of runner or which Docker images should be pulling based on your configuration. So that is why it's kind of in a fail state. And you could run into this as an obvious thing. So let's fix it real quick. Gonna uncomment. Oops. Let's save this. Let's take a look at what's under act ARC. So -p is a flag that through which you can specify which runner you want to use. And I'm saying for Ubuntu, any workflow that is that wants to run on Ubuntu latest, use this runner, and which is basically a Docker image, and then run the whole workflow on that. So let's build our CI pipeline again. We are good. I'll remove any containers that I have in running state. And we are good to go again. So it should be Docker run. Again, using the same project. Let's run it. Let's tail on. Interesting. Should be truncated any minute. Okay. So we have a CI running in. So it went ahead. So a Docker run, it did the image as this. You can see the entry point is that's specified in the runner itself. And going forward, we have some debug logs. It clones the repo and then mounts our basically it should see an explicit message that the action was successful. Yeah. So we were finally able to run our GitHub Actions. So our CI pipeline is working absolutely fine and we are good to go ahead. So this was a very basic example. Now let's take a look at some more complicated one. So I'll change my repository to Tink. Let me quickly show you what Tink CI looks like. Okay, So we have different jobs, and I have commented out most of it because this will be like a few more than 15 minutes or so to run this whole thing. So at the first, what I wanted to do is do a vet on the Go project that we have. We want to verify for Go imports. We want to run some tests. At Tinkerbell, what we do is we not just have unit tests, we actually have some integration tests that behind the scenes use test containers project, which is basically like when you spin up your unit test, it's going to spin up on a different container behind the scenes. And let's say you have 5 tests, then you will be running in 5 Docker containers, and that integration test will take place. So that's why I have commented this out. We don't want to cross compile at this point, and we definitely don't want to build any Docker images, which is like overkill for this demo. So if you want to experiment, you are more than welcome to try this thing. Let's remove our logs. And in fact, I will close this. And as soon as we have the logs directly created here, I'll open the logs in there. So I'll export Tink, Docker run XCI. We have the logs. So we have the dry run running. Okay, seems to be good. And here's the run actually happening. So if we have any questions in between, I'll be more than happy to take them at this point. So I think this will definitely take some time because it's going to mount the whole directory from project to GitHub/workspace, and it basically going to do all this magic things behind the scenes. It's quite a massive CL pipeline, and as an example or as a use case. So I'm not sure if you guys know about the Fission project. It's a way of running your code as functions in Kubernetes cluster, functions on the fly. So what I'm doing as a contribution to Fission, and that I'm writing their CI pipeline, restructuring it so that it looks much clean. And if I jump to Fission / so at this point, they have this workflows, which is a single job that is going to do integration test, and it has blah, 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 blah. And it has quite a lot that is happening. And I think it would absolutely make sense to split it in different actions or different jobs, as you say. And yeah, that makes more sense. So I'm working on that part. Plus Fission is missing Go linting, so I'll be adding that as well. So we have our action kick in. It was able to check out the code. We have some debug logs, and this is running our action at this point. I'll do control toggle word wrap. Maybe I'll just close this. Let's give it a few minutes, or maybe what we can do is jump back to slides and we'll just come back at this running action once it's complete. So we are looking at the demo that's happening behind the scenes. To save time, let's go ahead. Now, a word of caution about the whole runners and thing. There are 3 flavors for different versions of Ubuntu. Let's say if you want to use Ubuntu latest, then you have a micro version, or the lightest, slimmest version that you can use as a runner. You have a latest one. I'm using a middle one, a medium-sized runner, and then you can have a full runner. The challenge here is that few things that will work in your medium runner will not run in your slim-sized runner. And I think that's basically because they wanted to give you ways, like let's say if you want to just have some like as small as the first initial GitHub action that we saw that didn't require too much on its plate, we could use a slim version. But for something that is complicated as running Go linting, running tests, we might want to consider a medium one. And then we want to have, if let's say support for Nix OS, or maybe like building Docker images, something that is more heavy duty than instead of running a medium-sized runner, you may want to switch to a full-blown runner. And that's actually could be challenging because any beginner or anyone could be like kind of lost. So I believe on the nektos Acts part, it will be nice if they can document it, or what functionalities or features they have for each runner. If it's not already in place, I'm not sure if it is already in place. So I myself have to explore it a bit. Now, coming to actions, not all actions that you see in GitHub Actions are by default supported, and Nix OS is the great example. So for Tinkerbell, what we do is we have spell checks running in your CI pipeline, and there are certain things that you want to do and use Nix OS as the base, which is not supported at this point in Actosec. So you may run into some issues, and I think if you do run because of a runner or because of certain actions not being executed as you expect them, or if they are running on GitHub Actions but these are not running on your local, I would highly recommend you open up an issue or Nektos Act, or just check their documentation if that action is actually supported or not. I think that's pretty much it that I wanted to share. I'm not an expert on Nektos Act. I'm just someone who bumped into it, and I kind of like the project. It really helps. And yeah, let's see if we have our action completed. Okay, it got Go. It's kind of installing Go, extracting Go. Then we have some Go environment variables printed out, and then our Go imports failed, which is absolutely fine. So it's not like the demo has failed or successful. The demo was to show you that, okay, we can run Go imports or our Go pipeline with Nektos Act, and that's what's happening. So I think I'm pretty good. So if we have any questions, I'll be more than happy to take them now. And yep, thank you for your time. Thank you very much. I'll be more than happy if you'd like to have questions even after this talk. We can connect always on Twitter, LinkedIn, and I'm there on Collabinix. I'm pretty active there, I believe. So yeah, thank you very much.
So we have few questions like, how do you manage day 1, day 2 with GitOps? First question.
I just realized my speaker was off, so I don't know if I had any questions. I just lost them.
Okay. There was a question like, how do you manage day 1, day 2?
Anyone? Give me a second. Can you try again?
Okay. I'm audible now?
Okay. Yeah, I'm sorry.
How do you manage day 1, day 2 with GitOps?
I'm not a GitOps expert. I would rather leave the GitOps people to answer this. I have absolutely no idea what GitOps is. In the panel itself, I was more of a noob who's trying to understand GitOps. I do know Git, but I just trying my way out with Git Actions. So I leave Apurv and others to answer this question.
Okay, so what are the limitations of Docker in Docker?
Okay, so Docker in Docker is a very nice way to get started with certain things. I think it has most of the support. I don't have exact answer to this. So there's a ton of people who are exploring. Okay, Sangam is here if he has some answers. Sangam, you're on mute.
Okay, so Docker in Docker. So I can give an answer here.
Yeah.
So the limitation of Docker into Docker is like you have a container inside a container. So is that we are accessing the socket of the container. So it's going to communicate through that socket. Without socket, we can't able to do that. And if you put too much workload, it's going to crash, or there is some kind of CPU memory limit, because Docker into Docker is something like it's isolated inside an isolated box. So there are a lot of limitations. Yeah,
and like Sangam said, it's going to be CPU heavy. So I have my fans going crazy at this point because I'm running Docker and Docker, and you might face certain issues because ultimately it's a kind of a hack that is available.
Actually, it's good if you are like creating kind of sandbox and just to have a environment to run some kind of application, not too much heavy, because it's gonna take too much memory and the power. I believe that is a correct answer.
Yep.
Okay. So can I run Docker in Docker in Docker? That's something like nested Docker.
You can run Docker into Docker, but you need a huge CPU
System, yeah.
or GPU
Right.
kind of thing. But you can do that. Maybe on cloud you can host and do.
I would say if you can run Kubernetes inside Docker, then why you can probably run anything inside Docker.
But
mostly
accessing is very difficult.
Right.
Okay. Okay, so I think we pretty much covered all the questions. So thanks, Gaurav, for the wonderful session.
Thank you.
And I think we can move to our next speaker now, which is by Sangam Biradar. So he's going to walk us through DevSecOps, what, why, and how. So Sangam is Docker community leader and Oketo Bangalore community lead. He is working as a community manager, and Accurist is also a terrific ambassador. He has published K3S courses under title Lightweight Kubernetes with Pact publication. He's a blogger where he writes mostly about CNCF open source project, Golang, Docker, IoT, Kubernetes, and Linux kernel. He provides training and consultancy around Golang, Docker, Kubernetes. So you can check some of the free contents created by him on Gopher Labs. With that, I'll hand over to Sangam.
Hey, hello everyone. Hope my is it audible to you. So today my name is. Thank you for the introduction first of all, and my name is Sangam Biradar. I'm a developer advocate at Accurix, and I run a community called Kube Delhi. You can connect me with on the Discord channel at Kube Delhi. For joining the Discord, discord.kubedelhi.live, you can ping me anytime. Or you want to present anything around Octato, feel free to ping me anytime. So let me start with okay. So today, if you see around the world, we have a lot of vulnerabilities. If you see from the 1996 to today, we are getting a lot of vulnerabilities in the security place. And this is one of the report from the National Vulnerability Survey. So you can see currently in 2021 around more than 3,000 already vulnerabilities available there. And in the past year data, if you see 2020 data, we have around 18,000 around vulnerabilities. So moving to the next slide. So let's say if you want to do this check the vulnerability or work, if your security team is working on that. So if you say the per year is 18,000 and per day how much you are gonna resolve or understand is more than 40, is very difficult to understand the vulnerability. First of all, this is very difficult to think. So there are different aspects also in the terms of the security to check which OS, which package you are using, which programming language you are using, what libraries are using, which system. And this is very important in terms of no matter you are using a containerization or anything around that. So basically you need to think about all the things. You need to think about all the things. So just moving forward. So why DevSecOps? So we come to the evaluation like agile methodology, and then DevOps. Then today we are talking about the DevSecOps or the security in CI/CD pipeline. So next, so DevOps help deliver value and adopt the market need faster and scale. But really, what is the DevOps means actually? There are multiple definitions on the internet. You will find a lot of resources there, but I will go with this thing. See, three things, very important things, which is DevOps technologies. Today we see the different stacks, different people are. It's a kind of a culture. It's a methodology, and it's a DevOps is a shared ownership. And this is my understanding on the DevOps, but you can prefer any kind of definition there. But taking that point from that particular definition, so what is the DevSecOps means exactly? is securing the DevOps technology, security in the DevOps methodology, include security in the, we want to include the security in the DevOps pipeline. So moving that forward, so if you see this diagram, there are like security, operation, and developer. So these three teams need to work together in collaborative way, and we need to create a kind of a culture. No matter he's operation or security or developer, he need to think about security in the early stage of development. So and is very important to integrate the security tools in your pipeline and create a security as a code culture in the company or your organization or whatever you are trying to implement. So this is today DevOps, how we like see the today's problem. So we have developer write a code, the application, and commit a code on GitHub, then run that thing, build that thing on maybe GitHub or anywhere on the infrastructure, and then deploy on the cloud, and then we like do a monitoring and whatever the SRE people like maintain all the operation over the cloud. So why we need to like really move into this DevSecOps? So we do like developer. So this is a kind of a flow, not a standard flow, but this is a DevOps pipeline. We develop a like source code repository, then we build, then CI/CD pipeline, then staging, then production, then we think about monitoring. After this pipeline, we think about security. Why don't we think about the early stage, in the developer stage, security? That is a question that lead to us to the DevSecOps or the security thing. So let's see, developer is developing something, and in the build phase, it's something got crash or the SQL injection or any kind of error. So again, developer need to work on that security. That is a good approach, I will say, rather than the deploying and into production and then thinking about the security. So I will say the developer first security approach will be always helpful to create a better pipeline and secure pipeline. So I'll be explaining, this is a DevOps pipeline. We have planning, code, build, test, release, deploy, and operation and monitor thing in DevOps pipeline. How we can add the security into our DevOps pipeline, and there are some of the terminology. So I have the minimum time of 30 minutes, but I'm not going to like explain each and every or the kind of demo, but I try to cover a lot of as much as possible. So let me first topic will be the plan, and that will be thread modeling. So there is one of a good book called Thread Modeling, Designing and Security. It totally talks about how you can add the thread modeling into DevOps, and then in what is mean the thread modeling is what we are building for the early, from the planning stage. We need to know what we are building, what can go wrong, and what are we going to do about that. And this three question is very important in terms of thread modeling. So then misuse or abuse cases, we need to think about in the early planning stage about the security. And then come into coding, we have SAST or CSA, which is CSA means software composition analysis, and CIST means static application security testing. Adding this kind of testing, this kind of things in the early stage can give you the vulnerability detection, or maybe if you are using kind of open source or the kind of you can say not open source, is enterprise, we need access to some of the source code, and it's easy to create a remediation for that, and it's good to have integrated with our software development lifecycle, and we will analyze, we can get a lot of things what configuration is changing and lot. So moving forward, there is another concept called DAST, which is dynamic analysis and security test. And the pros and cons of the DAST will be the technology implementation. Sorry. Uh, So you can add this kind of methodology, maybe DAST or dynamic or static testing in your early stage of the DevOps pipeline. And moving forward, there is IAST, which is a combination of CAST and DAST, which is probably adding a kind of some kind of identify what happening inside, adding some kind of real time get a result from the running application or whatever the happening in the pipeline, not adding the CI/CD pipelines. We can have a web browser or dashboards, or customized reports. So we can get we can understand the traffic flow, and the vulnerabilities. So moving forward, configuration drift. So we do change the production environment without recording those changes which we made in the sometime, and configuration drift is very important. We can detect a lot of changes when we change something, and we can have a good kind of we can understand what we are really changing. And another thing is, I will say RASP, which is a technology kind of designed to like attack in application in runtime. So we need to have this kind of secret management, or the compliance and test cases, and how we are like saving the secrets. Maybe you are using a Kubernetes, or you are using environments. So how we are securing the things is very important in terms of maybe you are using infrastructure as a code or anything. So moving forward, so this is my learning. This is a personal chat I have created for kind of a best practices. I will not say this will be like suitable for some kind of, this is a kind of practice I do. So we can have this kind of things. We need to think about the customer involvement from the starting phase of the planning to the operation. We need to see this all the things which gonna help us in the identifying and scanning things or securing our DevOps pipeline. This is this kind of a DevSecOps stack. We have planning and development. Maybe you are using Git, Jira, or GitLab. Then building, MS Build, CMake for the testing, JUnit. You can do any kind of unit testing, performance testing, any kind of testing. And there is a lot of security tools. You can add SonarQube or Aqua or Accurix. You can add any kind of security tools into your pipeline. Then you can get that for the artifacts, storing artifact. You can use JFrog or Maven, or there is a lot of tools you can use for deploying and operating. We can use like Helm or Terraform. I will think this will be good. No, like it's depend on the what kind of tool or how your infrastructure build top of that. And definitely we need for observing or understanding what happening. So we need some kind of monitoring tool. We can use Negos or Elasticsearch or any kind of tool. And I think this, after integrating this all the thing into the, maybe you're using containers or container management orchestration or Kubernetes, or maybe a CI/CD pipeline, you need some kind of scalability. So you can scale this kind of infrastructure on any kind of cloud provider, Google, Azure, or Amazon, or any kind of provider. So it's good to have this kind of tool set into your pipeline. So this is about DevSecOps. So any question you have, I'm happy to answer. Yeah, any question before I'm getting into demo? Yeah, I see there is no questions. I will move forward. So So this is about like why DevSecOps. So I work at Accurix, and we have a kind of open source offering tool called TerraScan. TerraScan detect the security vulnerabilities and compliances across the infrastructure as a code before provisioning your infrastructure. Maybe, and we support 500 plus policies and best practices. You can scan the TerraScan or the Kubernetes or customize or Helm charts, and we support a lot of AWS or Azure GCP like policies. You can scan that. And you can run a git action. And if you want to join a community, so I'll be giving a swag giveaway. You can join a Discord channel, and I'll be announcing a kind of swag giveaway. So moving forward, TerraScan, which is started in back, we have now support for serverless. We added AWS serverless services support policies. We added a CI/CD, like you can use. We have a TerraScan server. You can use that server. You can scan Helm chat and customize. And we are launching new admission controller for the TerraScan, so you can add that into your Kubernetes cluster. So if you are a Docker fan and you want to use a TerraScan, you can use this command called docker run -rm -name, and you can run on 9010 port, and then take any kind of file from your local path, and you can scan that Terraform repo. You can using a Docker, or maybe you want to build own kind of stuff. There is a code, so you can take that Docker file and you can add. So this is a simple example, which is for the S3 bucket across S3 bucket access across the account. So if I scan, I'll get this kind of vulnerability. So this is the violation of the policies, and describe what kind of policies and what based on that I can do. I can change the particular my code, or maybe the any security policies violation. So I can change, and this tool can tell you that on which line that particular error or the violation is there. So you can go and you can change. So you can install this TerraScan, and you can just scan the directory or your folder. It will automatically detect the whatever your Kubernetes YML or TerraScan. I think get to next slide. There is my. So let me show you the demo. So let me get my terminal. Yeah, let me get my terminal. Give me 2 seconds. Okay. To stop sharing screen. Okay, let me share the screen again. Visible this time. Share the screen. Hope this is visible. So whatever I have explained currently. So currently I have this kind of, you can go and check this kind of example, which is like in this example, S3 bucket in AWS account give access to the bucket to the another user from the AWS account. So if I scan this kind of, you can see my code here. So I have this Terraform file. So if I scan this particular file, you can use the TerraScan -t. You can use TerraScan scan -t, and then yes, if it's a AWS resource, so you can just type AWS, or maybe whatever the this thing, and then you can just have TerraScan command. There is a bunch of you can add this server command into API server command into your pipeline, or you can scan compliances, and there is a bunch of things you can play with it. Or maybe you have a kind of a Kubernetes file. Like, let me see if I have any kind of Kubernetes. So I can say Terra scan dash t. I will say k8s. Okay. Scan the validation. I see there is some kind of error of my Kubernetes cluster is not running, I think. But you can scan Kubernetes files. You can scan Helm chats. You can scan your like cloud resources. If there is any question, let me know. Happy to answer. If there is any question?
We have one question, yes. Does TerraScan works for all sort of Linux and Windows distros?
Yeah, it's work for all Linux and all this. You can install on Linux, you can install Windows, or on Mac also you can install. I can show that if you go to the Git repo, we have added the steps, so you can just show that. Share the clicks, share the screen again.
Another question: can TerraScan scan Docker images?
Yeah, it don't scan a Docker image. It scan a Docker file, and you can add policies like doc. It's actually, we basically use OPA, which is like Rego, written in Rego language. So we write policies in Rego language. So you can scan your Docker file, your Kubernetes, Docker Compose, or customize Helm charts, and you can do a lot of things. Yeah, any other questions?
No, I don't see a new question set.
Yeah. Okay. That's it from my side. Thank you.
Thank you for the session, and with that, we can move to our next speaker, that is Nicolas Frankel. He'll be walking us through zero downtime deployment on Kubernetes with Hazelcast. He is developer advocate with 15 plus years experience in consulting for many different customers in a wide range of contexts. Say example, telecoms, banking, insurance, large retail and public sectors. Usually working on Java and Java EE and Spring technologies, but his focused interest lies rich in internet application testing, CI or CD, and DevOps, currently working for Hazelnet. So with that, I would like to welcome Nicolas, a warm welcome. Over to you, Nicolas.
Thanks a lot, Savita. Hi, folks. Thanks for having me one more time. I'm very happy because I think this is my 5th OSCONF. Actually, I will share my screen. I forgot to share my screen. I think that's the stuff I already did last time. So I forgot. Now I'm sharing my screen.
Yeah.
Can you see my screen?
No, not yet.
It is shared. It is shared. So probably you need to do something to show my slides on your side. Would it be possible?
Let me check on that.
Yeah. please. I cannot do more because the button is already clicked. Anyway, screen share slides up. What does it mean? Yeah, perfect. Woohoo! It works. Thanks. As I mentioned, it's my 5th OSCONF, and that's very good because I think my first OSCONF was also about zero downtime, but it was in another way. And actually, I thought a lot about it, and there were some downsides. So today I'm very happy. I call this Zero Downtime Rebooted because, yeah, it's another way to do that. So yeah, I'm Nicolas Frankel. I've been a developer for a long, long time. I still think I'm a developer, even though my official title is Developer Advocate. And I'm very curious about a lot of different things, including CI/CD and DevOps. I work for a company called Hazelcast, and Hazelcast has 2 products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So if your node, if your JVM is limited by size, and probably it is, you can shard your data across several nodes. If your data is very important to you, then you can replicate your data over several nodes. And the other one is Hazelcast Jets, and it's an in-memory stream processing engine. I will be using both during the demo. You will see for different reasons. So let's go further. Perhaps you didn't attend my session from last year, so I need to say it again. Why do you want zero downtime? I mean, I'm old enough to have known the time when you wanted to deploy a new version of your application. Well, you put a static page on your reverse proxy, and then everybody who would access your site would be shown the static page. Meanwhile, you were deploying, and the static page said, "Hey, please wait a bit. We are deploying a new version. We will be coming back in 30 minutes." And of course, all the time, after 30 minutes, it was not the case. I don't know if you are using a tool called Feedly. I'm using it. It's for all people like me. It actually lets you access RSS files, so you can have a stream of interesting news. And last week, they just did that. They said, "Hey, so sorry, we are down. We will be going down for 30 minutes. I think it was 40 minutes. And after 40 minutes, they were not up. It took more than 3 hours or something like that. So that's the old way to do things. Right now, we have a couple of things. The first is that the business wants it. The downtime of your application has a direct cost on the business. So either it's direct cost. For example, you are an e-commerce shop, and every time you bring your site down for deployment, well, at this time, you are not selling anything. So it has a direct impact on your revenue, and business hates that. It might also be more subtle if your shop is down. That means that the people who are your customers, they get to use another shop, and they might like this other shop more. So it also has an indirect impact on your revenue, like you lose image. So it's not very business friendly right now. And the second more sneaky reason is that people who are not in IT, they have been using Google, they have been using Facebook, they have been using Amazon. And actually those sites, those big sites, they never go down. So that people got used to those sites never going down. And if you present them with a page saying, "Hey, we are down for a few minutes," they don't understand the reason. People got accustomed, and they expect it for everybody. And so if we are talking about zero downtime, the oldest trick in the book is the blue-green deployment. And the blue-green deployment is quite easy. You've got a blue environment. The blue environment represents your production environment right now. And then in front of this, you've got this big proxy which directs every one of your users to this blue environment. This blue environment is just web server, application server, database. I mean, it's not AWS Lambda. It's just traditional legacy application, you can replace it with anything, but it does the trick. And meanwhile, you want to deploy a new version. So what you're actually doing is there is a new environment, and let's call it like green, and you deploy the new version of the web server, of the application server, and the database files. So the idea is that the server themselves, they are exactly the same. They are the exact mirror. What differs is the content. So different static files, different business logic, different data. You don't care. And at one point, everything is fine. So the green environment has been tested a lot, and people say, hey, let's go. And then you click magically a button, and magically all your users, they are directed to the green environments. It works like super well. There is a variant. The variant is, because of what I will explain a bit later, you keep one single version of the database. So the database is neither blue nor green. It's always in the same production environment. And the problem of this is zero downtime is state. And in general, there are two kinds of states. The first state is in memory, because we would like our application to be stateless. But for example, the cart of an e-commerce shop is not stateless. You must keep the state somewhere, so you can keep it in the database. But every time you need to go to the database and get back to the database and get back to the database, and it takes a huge load on performance. So what you do is generally you keep the store in memory, in user sessions. And then what happens if a node fails? What happens if you need to switch from like an application server to another application server? You lose the state. It's not great. And the other is the state in the database. So that's really two huge problems. And of course, Kubernetes comes, and Kubernetes solves all your problems. Everybody knows it. And so it comes with its rolling update principle saying, hey, no worries, folks. We'll just like update the nodes one by one. So like here, we will roll the first nodes to version 2.0, then the second one, then the third one, and everybody is happy. But the problem is it doesn't tackle the issue of state. Kubernetes is really, really great for work, for stateless workloads, but for stateful workloads, it doesn't help us at all. So we need to come up with another solution. So the idea where a state is in the session, I believe this is a solved problem. We've been doing session replication for years. The idea is that you store your session in memory, and behind the scenes, there is a replication process that goes when there is a state change in the session, then it's replicated over several nodes. There are several solutions for that. I won't talk about it any further. Just know that in the demo, I will be using Spring Session with Hazelcast, and it works. But it's not the hardest problem. The hardest problem is the database. And as I mentioned, I've been trying to like nail this problem down for a few years, and I come up with the solution. And the solution, my previous solution, was, hey, we will keep the same database. And then that's nice, because then at this point, we don't need to migrate the data. And it makes a lot of sense. If there is an issue with migrating data, well, let's not migrate data. Then we don't have any issue. But we have other problems, because now at this point, we might have to cope with two versions of the schema, of your database schema. So some upgrades, they don't require a change in the schema, which is good. But every now and then, you will need to tackle that. So it's a requirement. We must find a way to cope with that. And that's the problem with Kubernetes, for example. Here, I have the same rolling upgrade stuff. And what I'm doing when I'm doing the rolling upgrade is first I upgrade the nodes to version 2.0, then I upgrade the database, and the database, well, guess what? The old nodes that are still running 1.0, they cannot cope with the version 2.0. They don't know what the schema is. And if it's an incompatible change, they won't work anymore. It's not really good. Okay, so let's say we will be smarter this time. First, we will upgrade all our application pods, and it works. And when everything is fine, then we will upgrade our database. And yes, lo and behold, it works perfectly well until there is an issue with your deployment and you need to roll back. And how do you roll back now? You cannot anymore, because as soon as you roll back one of your application pods, it cannot work with version 2.0 of the schema. So here the requirement is your deployment must never ever fail. And I'm sorry, but it's not real life. Of course, we are super great engineers, we are professional, but I believe that every now and then we must handle failure gracefully. And saying, hey, failure will never happen is not realistic. So here I have this e-commerce use case because I've been working in e-commerce some time ago. And here, let's say, imagine that my initial schema is this one. So I have like a customer with ID and name. Then I have a cart line, which a customer has multiple cart line, obviously. And then for each cart line, I have a product and like a cart line as one single product. So there is relationship of 1 star and 1 1. Great, that makes a lot of sense. Now comes the business. And as you know, the business are really, really bad people. They always ask stuff from engineers that engineers don't want to do. But in that case, this is a requirement that makes a lot of sense. The business comes and say, hey, I want to keep a timestamp. Well, they won't tell it like that. They would say, hey, I would like to know when was the cart last touched, so that after a specific amount of time, if the order has not been made, if the person didn't pay, when we just would like to send them an email and telling them, hey, you have been forgetting perhaps about this order, and then you will tell them the items that they put in their cart, and we would like to offer you 10% or 20% discount. So please come back and just buy, give us your money. And it's not possible in the schema, and it's hard to push back again the business, because in that case it makes a lot of sense. So engineers, they think a lot and they say, oh, what we forgot is we forgot to create a cart abstraction. And yeah, so they introduced this cart table between the customer and the cart line. So now the cart has one customer, so there is a 1-1 relationship. And now there is this cart, that 1 star between the cart and the cart line, and this isn't changed. And you see here that there is this cart less modified, which is of type timestamp, and that's exactly what we want. And now we need a way to deploy this new schema with the old schema, and they still need to work together. So the idea with my previous approach, option 1, is, hey, we need to handle this breaking change by splitting this change into a succession, like in several steps that are compatible side by side. So if I upgrade to one baby step, I can always roll back baby step, because again, we need to plan for rollback. And here, how does it work? Well, here is how I would decompose the steps. The first is, hey, I create the cart table, which is normal because I need the cart table, and the app will still use the old data model. And now every time I do a change to the cart line, I will create this cart or update this cart. And when I say trigger, I don't only mean database trigger. It can be your application, it can be anything you want. It's agnostic. The idea is that every time you do this cart line insertion, you need to update the cart. So on the first cart line insertion, you need to create a cart record, and on the other ones, then you need to just copy the stuff. And what happens if I need to roll back at this time? Well, the application still uses the old data model. So what we just have is additional data, and the application still works fine. And that works. Then the second step is now the card becomes the source of truth. So the application used new data model, but still every time we do a change, we replicate it with on the card line. So if we need to roll back, we still have our old data model that is up to date. And again, the trigger can be done by real triggers, by the application, whatever. Still works. But now there is the biggest problem. We need to think that at some point, there are cards that have not been touched during the deployments. And those cards, they have not been migrated to the new data model. They have not been replicated. And it can be, so perhaps in the e-commerce shop, there might not be that many, but actually, depending on your use case, there might be millions of records. And how do you handle that stuff? You need to migrate it anyway. You need to migrate this data anyway, even in a single database. And finally, you clean up everything and everything has been done. Otherwise, you just roll back, but just one baby step by one baby step. You cannot like roll back 2 baby steps. So this works, but it has a lot of constraints. The first thing is always we need to think about this database change and to decompose it into like steps that are non-breaking side by side. And if you have one deployment with one database change, it might work sort of. But if you have 2 or 3 in parallel, it's going to be a mess, really, really a mess. The second thing is, as I mentioned, you can only roll back a single baby step. You cannot roll back 2 baby steps. So once you start a deployment, you need to finish it anyway. It might take days, it might take more, it might take less, but you need to finish it. I think the biggest problem is it requires the whole organization to plan for it. Of course, the developers need to be aware of that. Because, for example, if the replication of the data is handled by the application, they need to cope with that. If it's the DBAs, they need to cope with that. The ops need to cope with that. And as I mentioned, you will need to migrate the data anyway. And it's not really super great. So the second option is, since we will be needing to migrate data anyway, let's keep 2 different databases. Let's remove all those constraints and embrace it. And how can we cope with this data migration? Because as I mentioned, it can be millions of records. It's not great. Well, there are two like pillars that can help us. The first is change data capture. And change data capture allows you to, exactly what it does is to capture the changes and make events out of it, so it can be afterwards be used in a streaming pipeline. I will get back to it a bit later. Then developers are not concerned by any ops problems. They can just like create the application and then it's completely separated from the ops. You can have several deployments going at the same time. And of course, it's not like constrained by blue-green. You can do it with canary lilies. You can do it with any deployment model you've chosen. So change data capture. This is the definition by Wikipedia. I won't paraphrase it. You can read it. But the idea behind change data capture is that it's the complete opposite of event sourcing. Where perhaps you are aware of event sourcing. So event sourcing is the idea that instead of storing states, we will be storing events. And when we need to actually get the states, we will replay every event in order and we will get the state. And of course, because the number of events might be very, very big and the computation might take a long time, every now and then we take snapshots of the state at this stage. And so it's feasible. The problem is event sourcing. You need to completely change the way you look at things. And more importantly, if you have legacy applications, you need to completely change your application because the data model will be completely different because, again, you don't store state, you store the events, and then you recompute the state. Change data capture is the complete opposite. What you do is you continue working as you do now. You like store the state, but then you can like get the events out of the states when there is a state change. So if there is an insert, if there is an update, if there is a delete, you get this event and you can act upon it. So let's imagine now this is my starting state. I have like 3 pods of the V1 application, and I have a single pod for the database because it's much easier for me right now. And this is the blue environment. So this works pretty well, and I need to deploy a new version which is not compatible. What I will be doing is I will create this new pod with the V2 database, which in the green environment. Well, I can take as long as I want. It's not an issue. The second step is, it's the most important one. I will have this data pipeline. And this data pipeline, this stream processing pipeline, will read changes from the database. So every time there is an insert, a delete, or whatever, or an update to the blue database, I will replicate the change to the green database. And because here, I know the old schema and I know the new schema, I can do whatever transforms I need so that the data that comes here can be like transformed and then inserted into the new schema however I want. Now imagine at this point, if we need to stop the deployment for whatever reason, well, the application had no problem. You can still work as it is. Fine. Now we start the rolling updates. And what happens is at some point, your pods here will be replaced by a V2, which will use the green database. And guess what? It's not an issue because now this pod can access the same data because every time there is a change here, it has been replicated here. So you can still continue to work as necessary. There will be no downtime. At some point, all the pods will have migrated and no new changes in the blue database will happen. And so this pipeline, well, won't do nothing anymore because now the data is changed in this database. And of course, here I'm super lazy, but you also need to prepare a backward pipeline to stream the changes from the green database to the blue database in case you want to roll back. But here I stopped here because, again, I'm lazy, but it's the same. And now you can remove the pipeline and you can do whatever you want with the blue database. So how do we implement that? Here I'm working for Hazelcast, so sorry, I will be using Hazelcast implementations, but if you have other technologies that suit you, you can do the same. States for the session, you can use session replication via Spring Session because I'm using a Spring Boot application. You can use any kind other of session replication mechanism. Hazelcast integrates with Tomcat directly, with Jetty directly, or if you use another application server, you can already use like just a simple servlet filter. And we have something called Hazelcast for change data capture. And so there is something called Debezium, which will basically read the bin log from MySQL and can like stream, we can use Debezium to stream the changes. As I mentioned, Hazelcast IMDG is for session replication, and Hazelcast Jet allows you to do stream processing. So here on the left part, there are sources of data. On the right part, you have targets for data. And here in the middle, you've got the Hazelcast Jet cluster. It's a distributed in-memory stream processing. You can do enrichment. So if you don't need every time to go from in-memory to the database, what you can do is you preload data here in the IMDG, and then you can access it directly in memory. Here, we don't need it. We'll just be doing, hey, read from the database, read the change from the database, transform the data, and just write it to the new database. So it's very straightforward. The architecture of the Jet job in that case would be here. We have this like blue MySQL database. We will have our custom job. So here you need to write the codes because there is no other way to know which transformation you would like to apply to the change. The custom job itself uses a jar from Jet, which is just a simple library. And underneath, we use Debezium, which itself uses the Debezium MySQL.jar. So here what you can think is it's a driver, and you have driver for Postgres. Now I think Oracle is also available for DB2, for MongoDB. Well, and here you just manage a simple abstraction layer. So we don't care the real database that's in underneath. And here you can put it into MySQL Green. The good thing is here you can have MySQL and here you can have Postgres, or the other way around. Basically, we don't care. It's just an abstraction layer. And then there are like the nitty-gritty details are here. And I believe I still have time for a demo. So perhaps now it's always a bit hard, the demo, because you don't know how it will work. So here I have already created my application. It runs on Kubernetes. It's exactly as I shown before. I have 3 pods that are running. I have the blue database. And here I didn't want to use any security stuff. So what I will be doing for a session is just here. It lets me choose a user. So here I will be having Joe. Once I'm like logged in, here I can add stuff to my cart. So let's say Joe wants to have a Yeti mug, and here it can tell me, hey, I have one stuff in my article, in my cart, one article in my cart, and Jack perhaps wants to add like 2 t-shirts, and perhaps William wants to have 3 hoodies, and perhaps Avril wants to have 4 stickers. And let's check that Joe still has like 1 mug. Perfect. Now, what I will be doing now is I will be doing exactly what I've told you. I will be deploying my green database. So here I have IntelliJ, and here I can get all the pods. Now it takes time, of course. Here I have my 3 pods, and it's a deployment. And here I have my blue database. So I want to apply my cube green database. Okay, get pods W, and it's already starting. So it's very, very fast. Let's see that it has started correctly. I don't care. People can still use my application right now. It's F, yes. Oh, it has started correctly. Perfect. Now what I will be doing is I will be deploying my forward stuff. So K, apply F infrastructure cube forward. So this is the pipeline that I've shown you. And here, meanwhile, I will get pods W. And here it's already started. So I will just read the logs to check that everything works correctly. F. Yes. And here you can see it has already started, and it has already like copied the data from the blue to the green. And here you can see product ID 1, quantity 1, product ID 2, quantity 2, product ID 3, quantity 3, product ID 4, quantity 4. Just have a small look. I know this is not like a Java developer conference, but it might be interesting. This is what you write. Here I create a pipeline. I read from the blue environment. I map it to, so the record is the abstraction that I get. I split it to a map. And then I will use these call parameters. And what this call parameter do is I'm just actually creating an object called call parameters, which has customer ID, product ID, and quantity. And finally, I write to the green environment. Sorry, oops. I write to the green environment. And what I'm doing is just like here, it's only configuration. Here, the important bit is this one, insert cart line. And what I'm doing is not big deal. There is nothing complicated. I'm just calling a stored procedure with the parameters that I've created. So the customer ID, the product ID, and the quantity. And if you can check here, the blue stuff is also, it's only about configuration. So the actual amount of code that you need to write is the pipeline, so 5 lines of code, and finally the insert cart line, which actually, if you have been doing Java like 15 years ago, you can do, because it's, hey, I get a connection from the data source, so the green data source, and I call this stored procedure. Nothing mind-blowing. I mean, it's pretty straightforward, I believe. Anyway, here I have deployed it, and it has caught on with the changes that were done before it started. So it's able to have a cursor. And now, if I add one more, so here I will add more, you can see that, hey, it keeps tracking what I'm doing. Okay, fine. Now the hardest part is actually to do the deployment itself. So I have the new schema, and what I'm doing, I will change to the new process. So I will deploy the new version of the application, cube application 2.yaml. A get pods w. And meanwhile, I will be continuing to use the application just to show you that, well, everything works as expected. So I'm adding stuff, and normally at no point in time, there should be a downtime. Of course, it's a bit boring. And here, probably, it has changed the pods, and there should be 12 here. Nope. So then it's my front-end skills that suck. Probably sometimes, I mean, I'm a back-end engineer, so it's hard for me to do JavaScript, right? Oh. So here I'm checking that this one, it's terminating, but it's still working. So probably it has already switched to another pod. Yes, and you saw nothing. So that here I'm using the new database schema. I still have everything in my cart, and the other ones that actually didn't update the cart while I was deploying, they all add their stuff. So remember, it was 3, 2, 4, 3, 4, and Joe, of course, has everything it needs. So users were like doing stuff with their cart, and the cart here is not in memory. The cart here is in the database. Well, they have their data, and users that didn't touch their cart, they also have their data. So I have everything I need. I hope you like the demo, because every time I do a demo, it's a bit of a risk. So takeaways from this talk, which is very different from last year. Last year I told you, hey, well, zero downtime, it's a lot of problems, probably you don't need it. Now, this year I tell you, zero downtime is within your reach. I hope I proved that it's completely possible, and you need to tackle state. State is in 2 places, session, then you do session replication, and here I'm using SLCast, session replication through Spring Session, but you don't need to, but it just like is a nice example. And for the state that is in the database, you can use change data capture and data streaming, and it works as expected. So thanks a lot for your attention. Here are still the same info I always give. My blog, please check it. It's mainly about development, but every now and then I do some DevOps stuff. You can follow me on Twitter, and then I can tweet a lot of different stuff. If you are interested in the demo, you can do it at home. So here, everything is on GitHub. Please check it and try and play with it and find bugs and send me pull requests. If I got you interested in Hazelcast, please join our Slack. If you are shy, which is I can understand, and first you want to have some training, all our trainings are free. Go to training.hazelcast.com. And now perhaps there are some questions. Wow, I kept the pace, I kept the time frame. I'm very happy.
Thanks, Nicolas. We have one question. Like, does the solution that you showcase works with only containers, or?
Does the solution that you showcase works only with containerd? Actually, here the solution, what I showed you, uses Kubernetes, but you don't need to. is just I'm just here using Kubernetes for the rolling upgrades of the application pods. But imagine you don't run on Kubernetes, you don't run on Docker, you're just using like infrastructure-based stuff on-premise. It works the exact same way. It works the exact same way. So you don't need all the fancy stuff. I just put Kubernetes in the title because people love Kubernetes, and it was just a cheap trick, but it worked. But actually, you don't need to do it. The only real capability of Kubernetes that I used was to do the rolling upgrade of the pods, and even that, I mean, is just fun, but it's not necessary. You can do that manually.
Okay, thank you.
Thanks a lot for the invites, and I wish you
a wonderful demo.
Thanks. Well, it's always nice when the demo works, because, you know, there is always, it didn't work. And this morning I just tried it again, and of course it didn't work. So I just scratched my complete cluster and started from scratch again. So thanks a lot for the invite, and enjoy the rest of the conference, and perhaps see you at the next OSCONF. And remember, just check the resources.
Thank you, Nicolas. So with that, we move on to our next speaker. We have our next speaker, Paweł. So he's going to walk us on autonomous multi-cloud serverless deployment and optimized management. A little about Paweł. He is an experienced architect of IT solution, particularly in the field of processing large data set and machine learning solution. Well, in the year 2006 to 2015, he co-created the architecture of IT system solution for the biggest companies in Poland. In the year 2016 to 2019, he carried out projects in the area of cloud computing and AI, and deployed one of the most advanced AI solution for investment industries. So, and he's a technical director for Medolic multi-cloud optimization and management platform. That was a brief introduction, and a very warm welcome to Paweł. Over to you.
Thank you. Thank you. Can you hear me well? Thank you for the invitation. I'm really happy that I can present on this open source community conference, because I want to present our open source project, and also to have the opportunity to encourage you to participate in our development, so to become also the developers of our project. But yeah, let's start from the beginning. And thank you for the nice introduction. It is exactly as was said, as I'm working in the Melodic project, and we aim to build the open source multi-cloud deployment platform. So the idea, which is currently released and working, so you can download and use, the platform is to create the single universal platform for the optimized deployment and management application into using multiple cloud providers. So we are fully vendor independent and and multi-cloud. And we can deploy various types of the resources, including serverless, on which I put a bit more focus today. And the most important thing is that the platform is fully open source. It's released on the Mozilla license, so you can download, use for any purposes and without any constraints. And the idea is to model application once, and using Melodic platform to deploy to the selected cloud providers, and we want to select the most optimal deployment plan, the most optimal cloud providers, looking on various things like price, performance, and so on. I will tell a bit more later. And why to use that type of the platform, and especially the Melodic platform? Because it is probably the simplest and the easiest way to start using multi-cloud approach. Because if you are working with the one cloud provider, then after some time, all of the solutions, all of the software and scripts and so on are tied to the given cloud providers. So it is very difficult to move to another cloud provider. So using this platform and modeling in the cloud agnostic way the application, you are in the multi-cloud, and the application could be deployed to the different cloud providers. Also, our platform is not working only with the containers, but with containers as well. But it is also possible to deploy virtual machines, serverless components, and also big data stack. Today, I will show some use case applications which are using the big data and how they are optimized using multi-cloud approaches. And very important advantage is automatic deployment. So here the deployment to the selected cloud providers is fully automatic, and also there is automatic optimization of the cloud resources. So the platform is selecting the most optimal set of resources based on the defined criteria. I will also tell a bit more about that. First step, which is a part of the platform, is the CAML, Cloud Application Modeling and Execution Language, which allows to model both resources and application in the cloud agnostic manner. So this is a language similar to the Tosca standard, but extends in the Tosca in the various way. And as I said, it is possible to model applications, all of the components of the application, connections between the components, security rules, and so on. And also it is possible, and that's the very unique feature of that language and the whole melodic platform, is to model the infrastructure requirements. So we are not setting the exact infrastructure like the virtual machines with the certain number of the cores and memory, but we can define the requirements, and based on that requirements, Melodic is solving the optimization problem and find the most optimal set of resources based on the current situation of the application and current context. So we can model the requirements, constraints, and so-called utility function, which define us what means the best deployment. I will also tell a bit more on the next slide. What is this famous best deployment? Starting from the beginning, Melodic, after deploying application, is collecting metrics. So we are measure the CPU usage, performance, and also business metrics like average response time to the user or average job processing. And based on that metrics, we can calculate how good the particular deployment is for the given application, and we can focus on the business value, because usually the CPU usage or memory usage is related to the usage of the application, but from the business perspective or the user perspective, much more important is the, for example, average response time to the user or average time for the processing given job or any other values which are dedicated to the application. And of course, usually it is a trade-off between the cost, performance, availability, and other criteria for the application. If we want to have the minimal cost without other requirements, we can just not deploy the application, and then the cost of the deployment will be zero, but of course the performance will be zero as well. So that's not an expected way of the deployment. So usually this is some kind of, usually it is a trade-off. Yeah? I want to have the shortest response time to the user, but on the other hand, I also want to have the cost at the minimal possible level. Yeah? And the optimal solution is solved by Melodic. And how it works? Yeah, as I said, first step is to model application on the Melodic using the camel language, set the parameters, the requirements and other parameters of the application. And this is done manually, but after that, everything is done automatically. So after the initial modeling, Melodic is calculating initial deployment based on the parameters set by user, by DevOps and developers, and then it's automatically deployed to the selected cloud providers. So based on our prepared model, Melodic automatically find the most optimal solution based on the parameters set in the model and automatically deploy to the selected cloud providers. After that, Melodic starts to collect the metrics, both technical and business metrics, and based on the values of these metrics, Melodic decides if the new solution should be found or should we start the optimization process again, because the metrics values are different than originally set in the model. And if the decision is yes, so usually it is based on the certain threshold. So if the metric is bigger than a certain threshold comparing to the metrics set in the model, Melodic is looking for another solution. And after another solution is found, then application is redeployed on the fly. Yeah? Usually the redeployment means that the new components are deployed, new machines are added, and the communication is set to the new machines. Also, if, for example, the workload is lower than expected, then Melodic can remove some instances or downgrade the virtual machines to the lower resources to save the cost and still have the optimal solution. And that works in the loop all the time. So after the redeploying a new solution, the metrics started to be collected again, and new solution is found and redeployed. Of course, we can define certain thresholds to not redeploy all the time up and down, but only when the change is the most significant. So that's some kind of the practical tips and tricks how to use the Melodic, but in general, the whole optimization works in the loop. How the Melodic is built, yeah. As I said, we are very open for the new open source developers. So if you are interested in joining to our development team, then please go to our page and register as the open source developer, because I think that the project is interesting, and also it is built using the as pure microservice architecture as possible. So we have components, Dockerize. It is run using Docker Swarm. So the whole Melodic is working on the Docker Swarm cluster, and we are using control plane. For the control plane, we are using Mule ESB in also the community edition, so open source. And for the orchestration, so the logic and workflow orchestration, we are using the Camunda BPN, which is also open source, and all of the business logic is defined as a BPM process. So it is not hard-coded, but BPM process is executing through the REST API, this endpoints exposed by each of these services. And these services are dedicated for the resource management and deployment, for the optimization, for the adaptation. Also, we have the event management system to collect metrics and to provide these metrics to the platform. We have the security module and the UI module, because the whole platform is operated through the dedicated user interface, which is quite ergonomic one and usable. So that is the architecture of the platform. And again, if you are interested in joining to our development, you are very welcome. And how it works in practice. Yeah, I have two use case application. One use case application is pure commercial. Yeah, so the company called AI Investment is using Melodic to optimize the multi-cloud deployment. And the second use case is more generic one and can be used by the all application which are using the big data frameworks. So first one is the AI Investments. AI Investments is a company which aims to optimize investments portfolio using the machine learning and artificial intelligence method. They are using two types of the method. One is time series forecasting using the latest, most advanced time series forecasting method like transformer models or echo state network or settling machines. And the second machine learning models and the time series prediction is used to estimate the value of the financial asset, and thanks to that the portfolio can be optimized and more have the more efficient results in terms of the rate of the return and Sharpe ratio. And the second one are the machine learning methods for the portfolio optimizations. All of this method requires a lot of the computational resources, especially the virtual machines with GPUs, which are quite expensive in the cloud. So Melodic is able to optimize that application. And typical business goal is to train the certain like 50 predictions model in the 1 hour using, of course, as minimal number of resources as possible. And how it looks in practice. AI Investments has their own infrastructure on premises resources, so the training is started on that resources because they are the cheapest one, because they are already owned by the company. So the investment analysts start to train the models and to optimize the portfolio. And in that case, Melodic is estimating how long it takes to train these models using the on-premises resources. Yeah? The business goal is to finish the task in the 1 hour. If it takes longer, then Melodic deploy additional resources into the cloud, so additional workers on the virtual machines with the GPU in the cloud. And the resources are also used to train the models. After deployments, Melodic gets new metrics and check the estimated time. And if it's still too high, then add new resources. And after adding new resources, again, it's checking how long it takes to finish the training. And if the processing time is equal or below the estimated business goal, then the resources are kept and models are trained. And finally, after the training, Melodic is automatically removing the cloud resources just to save the cost. Yeah, and that works fully automatic, and both deployment and optimization is done fully automatic. So most important benefits for the AI investments company is effective optimization of the resources, which is very beneficial for the scaling of the machine learning training. And also very important is that using Melodic, the high availability of the application is also increased, because in case of the one cloud provider outage or the issues with the on-premises architecture, the additional workers can be deployed to the other cloud. And answering the question from the chat, yes, Melodic does support on-premises cloud, and in fact, in the AI investments, these on-premises are built on the OpenStack. So all of the private clouds which are using the OpenStack are supported. Also, the Docker Swarm and Kubernetes cluster are supported as well. So the Melodic can deploy the containers to the private cloud, which are operated using Kubernetes or Docker Swarm. Of course, the virtual machines and serverless can't be deployed to that cloud, but for the OpenStack, the virtual machines can be deployed as well, of course. And currently, serverless is supported only using the say public cloud providers. So that's answering to the question, and thank you for the question. Please, if you have more, please add. I will try to answer during the presentation. And some more, let's say, and concrete benefits. For the AI investments, the savings are quite significant, because AI investments initially try to decide what type of the resources they should use. They know that they will need a lot of the resources, and they calculate different options. One option was cloud only, and the second opposite option was to use only on-premises infrastructure. But in fact, the most optimal scenario is to use the combination of the cloud resources and the on-premises resources, and the savings are really huge. This is the total savings in the period of the 3 years. So for that company, it's the really huge savings, and it is achieved thanks to the proper optimization of the cloud resources. Very briefly about the next application, and it's also a very good and more generic use case application and example how to use the multi-cloud optimization. This is a typical Spark so big data application. This one application is used by one of the Polish universities for the finding the mutation or differences between the genome of the given person comparing to the reference genome data. It requires a lot of the computation, and that's the reason that the Spark big data framework is used, and Melodic is used for the optimization of that resources. So again, the processing of the data is started using the private cloud on resources, but if there are too much jobs or too many jobs to process, then Melodic automatically calculate how long it takes, and if the time is too long, then additional resources into the cloud are deployed. Of course, the resources are selected to be the most optimal one. And then again, Melodic checks how long it takes, and if it takes the finishing processing takes shorter than expected time. Then the resources are kept, processing is done, and after that everything is removed. So that's the two use case application. On our web page, we have more use case application described, so you can go and check that. But very briefly, how looks the typical workflow with the melodic, just to sum up. The first step is to model your application in this Camel language to have the cloud agnostic modeling. Then you need to deploy the melodic platform, submit your Camel model to melodic using the user interface, and start deployment of the application. And deployment also covers the optimization and reasoning parts, so this step is done fully automatically. Then your application is deployed, then just connect and enjoy. So that's quite simple. But it's not the end. We are still working on the melodic platform, and we are aiming for the even more advanced feature. The additional work is done in the Morphemic project, and the two core concepts, I just wanted to mention them very briefly. Two core concepts of the Morphemic are, the first one is the polymorphic of the architecture. So currently melodic is able only to choose the number and type of the resources, so how many virtual machines with the given number of the cores and memory. But the concept in Morphemic is also to be able to polymorph the architecture of the application. Yeah, so we are not only the optimizing number of the resources, which is quite simple, but also to change the architecture application to be, let's say, more efficient in terms of the cost and performance. And that's the first idea. So the new version of the melodic, will allow for the also changing and adjusting the architecture of the application. And the second core concept, which also answers the question from the chat about the autoscalability, is the proactive adaptation. Because currently melodic fully support scalability, automatic scalability, and it is based not on the certain rules defined, as it is, for example, in the autoscaling group on the AWS, but melodic uses the advanced machine learning and reinforcement learning algorithms to find the most optimal solution. But so we are able to find the most optimal solution. So the number of the workers for the given workload. So we have the metrics with the given workload, like for example in the AI investments with the number of the prediction methods. And based on that, we are setting the optimal number of the resources. But in the Morphemic project and new version of the melodic, we want to make a one step further. So we want to forecast the workload and scale application before the increased workload occurs. Yeah, so we want to forecast what the workload will be and to increase the number of the workers and number of the instances beforehand. Yeah, so before we get the bigger workload, and thanks to that we are not reactive, so we are not waiting for the application to start to lagging or increasing the response time to the user, but we want to be proactive and to increase the number of the resources beforehand. Yeah, it is very important, for example, for the e-commerce solution. because there are a peak of the users, and typical e-commerce solution do not want to wait, I don't know, 5 or 10 minutes till the new resources will be provisioned and up and operating, because for these 5 or 10 minutes the users could simply change the service provider and go simply to the another shop. Yeah, so here we want also to include this forecasting and proactive adaptation to the platform. Yeah, so that's all for my presentation. Thank you for the questions. And once again, I really encourage you to download Melodic, and also really encourage to join to our team and develop Melodic as open source platform. Here you can download Melodic. Melodic is hosted on the OW2, so the leading European open source community organization. So we have all support for the open source development. And also you can follow us on LinkedIn, Twitter, Facebook, and our Melodic website. So then there will be some information published, news, blogs, posts, and so on. And if you want to ask about the Melodic, do not hesitate to contact me. So again, thank you for the question. Thank you for the invitation. I hope you would find my presentation interesting. Thank you very much.
Thank you, Praveer. It was a very interesting session. Thanks again. With that, we'll just move to our next speaker. We have our next speaker, Sylvain. Okay. Hi, warm welcome to you, Sylvain. So he's going to walk us on, how he made a powerful cache system using Go. He's actually a full stack developer and passionate by development. He more precisely work on web development because it can show the developer the creativity. And he's a creator of cache system for traffic called Sewing. The cache system is compatible with any of the reverse proxy like Apache or Nginx. Since the version of 1.1, which he's worked on, he already experimented a template creation for a marketplace that can be retrieved at a particular address. So with that, a very warm welcome to Sylvain.
Thanks to you. So first, thanks to OSCONF organizers to let me talk to you about my side project. And obviously, thanks to all of you who are listening, and hope you're all doing well. So before diving into the subject, let me introduce myself and make myself proportion to you. My name is Sylvain Combraque. I'm from Lille in France. Then sorry for my baguette accent, but I try my best to speak as well as possible. I'm traffic contributor. I'm also creator of the cache system we'll talk about, and you can find me on GitHub searching my tag darkweek and darkweek_dev for Twitter. So let's replace the context of why I started to dev using Golang and how I came to do it. As I said, I'm traffic user since 1.4, contributor and helper. Then for those who doesn't know traffic solution yet, it's a reverse proxy created to manage containers architectures, and it's container first approach. It supports the hot detection deployment, the scaling. It load balances your request automatically using the weighted one Robin, and use only a specific port for all protocols. So traffic manage for you the service resolution depending host in entry. Then it's the pivot point of your infrastructures. It's like Kong or Nginx for those who have already worked with them, but really simpler to configure and to set up. Another good point is the fact you can install it on your development environment instead of Kong, because Kong is too wait. And you can continue your work after that. Then, as you can hear me, I love to use traffic, and I love this solution. But after a few months using this solution, there was an issue I was facing too. There wasn't any cache system internally to traffic. Then all requests would have to resolve the associated service. Then it took many milliseconds to be done. And I searched after a cache system solution, but nothing appeared to be as efficient as I wanted, or it was only POC, so it doesn't interested me. After many nights spent to look after that, I decided to create my first program in Go. The fact I was totally noob with this language, but it didn't scare me because I had a goal, and when you have a goal, you'll do your possible to achieve your goal in any way. It's different to start learning a language with a concrete project instead of learning a language with a tutorial or something like that. This project called Soin is actually in 1.4.4, and for the record, the release names are free beer names because I love to drink beers. And obviously, don't forget to leave a star to this project because I've got an oversized ego, and it makes me happy to view the stargazers count growing. And for those who are using Varnish, there is an illustration to show you how Soin is versus Varnish, and that's just for training, obviously. So let's see together how it's easy to set up through a demo. So I've got a repository, a folder, more precisely in my laptop, and I've got two different files, a configuration YAML file and a Docker Compose YAML file. If I try to show you what is defined in the configuration file, we define a default cache key and specify to Soin to listen on the HTTP port, and it will store the responses on a TTL, which is 10 seconds. Then after 10 seconds, the cache will be thrown in the bin. And if I show you the configuration for the Docker Compose, we have three services. The first one is traffic. The second one is who am I? So it will show you some information about the container and some headers in it. And the third one is the Soin instance, and it works with that. This is the minimal configuration to make Soin working. And I didn't say we define a reverse proxy URL key to tell Soin to call the reverse proxy behind the Soin instance. So if I just type Docker and it creates Soin, traffic, and who am I instances. And if I try to load the website, we can see it took 31 milliseconds. And if I refresh, it took 8 milliseconds. But as I'm streaming right now and other things, other processes are running on my laptop, it's a quite slower, but in production it's really really faster than that. And as you can see, we are adding a new header to the response called X from cache to tell Swan handle the request and served the response. So now let me explain how to build fast applications with Go and specify in my case what kind of Go features help me a lot. So first, I can't talk about Go features without mentioning the Go routine feature. If you don't know that, Go routine is basically a part of a thread which will run one task, one function detached from the main thread, and it will close if the main thread stops or if it reaches to the end of the function. In this example, we can see that a cost function will be delegated to another part of the thread to be more efficient, and because we don't need the result of this execution, we don't store in any variables the result. Then here the update cache eventually is really cost effective due to headers validation, RFC checks, and etc. And you can easily do concurrency with the Go keyword placed before the function declaration and before function usage. Then another big feature is the channel. We can wait in main thread for information or push data to the Go routine. And today we are Golang application without channels, and obviously Go routines doesn't exist, or it's really, really rare. A channel is like a bridge between the main thread that instantiates the channel and the associated Go routine. And for example, I use the channel to switch the incoming request and be able to coalesce them if needed, and only when the response is available, I return it to the client. With that, I can manage multiple connections at the same time on different or same endpoints. And as a channel, as a type, we can define our own channel. Like here, we are defining a reverse response channel that can take the same type as input and output. And you can only pass and retrieve reverse proxy. And retrieve reverse proxy type or nil. And a little tip, don't forget to close your channels because it can cause a lack of performances and make some zombified thread. Then I was facing an issue that Go doesn't support generic types at the moment. It will support them when Go in the second version will be released. So we have to find some tricks to be able to pass a generic object as generic as possible to have more flexibility. The solution is to apply the dependency inversion principle to decoupling software modules, thanks to Wikipedia for this definition, and use interface instead of the implementation. So you won't pass directly your instance, but you'll tell the Go interpreter you will pass an interface instead. Then it's a little bit tricky to implement an interface in Go, and sometimes you can implement an interface under the hood without knowing you're implementing it, because you are you have not any keywords like implements or any others. So in Swan, we have some providers to be able to let the user decide which kind of storage system should be used, depending the matched URL in the full version. Here, we are defining the type of each provider. Each provider defines same functions, the list keys, the get, set, delete, and init. And since the last version, you have the reset function to reset the data or any other actions you want to do. So to make generic objects, we can define an interface like the abstract provider interface, and can be part of an abstract provider interface array, for example. After that, we can pass our Redis or our Ristretto provider, and as the two structures are implementing the interface, it won't crash. But in your IDE, you'll have the auto-completion for an abstract provider interface and not your real object instance. So the power of Swan compared to Varnish is the configuration part, which is simpler than the disgusting VCL for Varnish configuration language. Here you just have to define a YAML, and it works like a charm. On the left, you can find the minimal configuration to be able to run a Swan instance. And on the other side, you have the full configuration for the full version containing Redis, etc. And in the last version, you have the support of Aldrich for distributed cache storage. Then, as it's YAML, you can use anchors. You can write scripts to create dynamically the configuration, and the most of all, the configuration supports the hot reload. Then you don't have to restart Swan if you change the configuration. But I plan to disable by default this feature in the future to avoid memory leak and avoid a thread running in the background from the start. Then keep in mind that existing keys are always stored and available in your providers when you change the configuration, but you can use the API to purge that, but we will talk about it later in this talk. So as traffic, Swan is container first designed to be compatible with as much as possible with existing systems. You can define a Docker Compose YAML file for Swan exposing the needed port and map the configuration file path, and be sure the reverse proxy is in the same network than Swan instance to avoid the external request and save milliseconds. This is the configuration for working with Swan out of the box. There is an available KG module and a traffic plugin, which will be released when they'll support plugins that use the unsafe library. Hope this day will arrive soon. I'm talking with them about an implementation to do that. So it was so funny to do this part, but I was facing the most complex part. The first one was the RFC implementation. I took time to blow a little because the RFC caused some traumatisms. And support RFC rule is really good to face and fight the depression, because you think you're done with that, but another rule comes and you have to rewrite parts of your code. The RFC for request for comments designs the semantics of the web and apps to homogenize and define the standards of your responses, your behavior, and don't let the creator be free about implementations, logical parts, and data processing. So here is an example with the RFC 7234. It's just the first page, and there are another 42 pages. So that was a pain to support that, but thanks to other developers that implemented it in the past, then I can take advantage of their existing work, like the cache control library from the Apache creator, and it's really good to see the community doing very excellent work in Go. So when you're implementing an RFC, you realize that just if-else conditions, and you can see in this example to manage cache control header, it's just condition after others to be able to test every cases. That's the same thing for the expire header to check if it had already expired or always good to be served, for example. Then another cool feature is the support for the request coalescing. That means when you get multiple requests at once on the same route with same context, you'll temporize all incoming requests and you'll request only once your backend, then use the same response for all temporized requests. That's pretty cool to be, because your backend service can be on cheaper server and couldn't handle all requests if it was on frontline. So thanks to Single Flight for providing a library that can be used to handle and coalesce requests. Then as Swan takes care of users and won't let them manage the cache through an API, it provides some endpoints and secures them with JWT authentication. At the moment, you can only list keys to avoid content leaking and purge cache for a resource or multiple by regex. So let's see together how it works and how I did it to make it as faster as possible without impacting the base cache system. First, the configuration about all the API endpoints are the following. You have to define the API block in the YAML file. Then you can override the main bus path, which is Swan API by default. At the moment, Swan supports only 2 APIs, but in the future, it will support more endpoints. For each endpoint, you can override the bus path, tell if it's enabled or not, and it falls by default. Then specifically for the security endpoints, you are allowed to define a secret and a list of users to be able to log in as these users. For the Swan endpoint, you can tell that you want to protect related routes behind the JWT security firewall. For the cache management, the default bus path is Swan, and you can send a GET request on the base endpoint to list stored keys, or send a purge request on an ID or a regex to purge it. So here are some examples about the results when you are sending a request on these endpoints. Okay. As you can see, the bus path route returns an array containing all keys stored in the provider, and on the full request, on the full request, you have for each provider, each key is related, and the provider will be the key of the associated array. And the purge request return nothing, expect no content either, to tell you the cache is now purged.
So we have one quick question. Does Soin supports SSL too?
Yeah, it supports TLS, and for the demo, I didn't show it, but it supports it. So the security API, we have the BusPass, which is authentication by default. The login request set an HTTP cookie if authentication is valid. Then the refresh endpoint returns new HTTP response, which tells that the previous cookie should be replaced by the new one. Then here is the result about that. And we have the refresh and the login path. But in your mind, you can tell okay, it sounds great, but I want to know how to cut this. So I will show you the magic under the carpet. Basically, I get the main bus path from the configuration if it doesn't exist. It will use the default value Swan API. Then after that, I load each endpoint using the initialize function, which take a provider and the configuration as parameters. If the endpoint is marked as enabled, I just create an HTTP handle func with and without trailing slash, and each endpoint have a property named handle request as the name specified to handle the incoming request. Then the path is built from the concatenation of the main bus path and the endpoint bus path, and the code is running at Swan startup only, and it takes only some milliseconds to be executed. Then the last tricky part is the key management. I'm using Ristretto for the cache storage by default, and it doesn't have a function or property containing the list of stored keys. It stores only hashed keys. So I had to declare it out of the Ristretto library. I called it key saver in the Swan code base. I didn't have inspiration to name it with another term, and because why not to name it like that? Then the key saver is basically a Go routine, and all actions on it will be run inside it. Get and delete function are asynchronous, and with this approach, I don't have any problems with concurrency as I try to write something in the array while I'm reading it. And thanks to the rlock and runlock functions to ensure nothing can edit our list while we are accessing it. So after this very long technical part, we can now talk about the deployment system. The deployment is secured by Travis CI to avoid regression. Then GitHub Actions get back the lead to deploy only tagged version on master and full version branches. First, the workflow for deployment. Tests through Travis are launched. The artifacts are built, and the last steps is to upload artifacts on the tagged commit to be able to download the OS and Arch associated binary. So here is a diagram to try to represent the Travis CI setup. And here is the configuration file about it. So first, I tell Travis to boot with a Golang environment. Then I add the Docker dependency to be able to run required containers. Then it ensures the compliance with every system. Then I decided to not sending emails. And after this setup, Travis will run the make create network to add the associated network, then run the make build dev command to prepare the container to run as development mode. And after that, it will run the make validate, which will group the linter verification. After that, it will run the test to handle any regressions. And finally, so we check that the production mode can be built and won't crash to ensure the compliance with users that use the latest Docker image. And after that, once it's merged on master and tagged, the GitHub Actions will be called and two jobs will be run. The first one is a binary generation to create artifacts depending the OS and Arch. It retrieves the tag name, pulls the tag branch, require Docker dependency, and enable build system to be able to build Docker images. Then it tries to log in to the Docker hub using secrets and build the prod container. In the minimal version, we are using latest instead of the latest full tag. And as you can see, here is the result on the Docker hub. Our image is tagged as latest and is ready to be pulled, and obviously it's tagged as latest full for the full version. Then the last step is the artifact generation and upload them to the GitHub release for the Go releaser action. In this example, we build for Linux, Windows, and macOS for each platform. And after that, we have our artifacts on the refilled release. Then here is my face when I release the new version. So just for those who want to see what is the power and performances of Swan, here are some metrics to view how many requests it can handle per second. It took around 35 seconds to serve each 101,000 requests. The max response time was 56 milliseconds, and the minimum was 0, but it took some micro or picoseconds, but rounded to 0 milliseconds. So it's not really right. And it's due to Ristretto powerful in combination with the asynchronous updates. So after all that, what's next in Swan? There will be fully support of Vary, but now it's on master and it has to be tested more deeper. So I don't release it now. And another big feature was the support to uncoalesceable requests, and it's now available on master. And I plan to support the cache statue, the new RFC for that, and obviously increase performances on the cache system. Then I plan to release a new stable version on the next week. And And obviously, if you want to contribute, you're welcome. Then here are some cool another side projects. Smerch, which is the open source pen test oriented platform. So you can check it and contribute on it. And if you want to use Caddy, I made a platform. It's https xcaddy.tech. My slides are not okay. An X is missing. And to finish my talk, I just want to say thank you again to OSCONF organizers and for all of you who are listening. And don't be shy. You can ask me whatever you want. I try my best to answer it. And anyway, I'm available on Twitter if you find some question during the night. And like Gordon Ramsay is saying, thank you, all of you.
Thank you, Sylvain, for a wonderful talk. One question, like, why did you choose the language Go? Any specific reason, or?
I missed something in the question, maybe.
Hello?
I didn't understand.
Why did you choose the language Go?
Because traffic is written in Go, and and because it's hype. That's just for that. So and because PHP doesn't fit to that, so
Okay.
I choose it.
Okay, because your paper or articulated had it, like unlike like Node.js and PHP, you found Go as interesting. So that was a quick question. Thank you.
One more question. So you use gRPC?
I don't think
you have used gRPC module, like protobuf.
No, I don't support gRPC, and I don't know how to use it. So
you mentioned RPC, so I thought gRPC.
What?
You have mentioned RPC in the slide. I thought it's a gRPC.
No, it's RFC.
Okay.
Okay.
That's not gRPC.
Okay. Thank you. Thank you for the wonderful session. And it was a very interesting one. Thank you again.
Thanks you to all of you.
So with that, we have our last speaker for the day. We have Anoop with us joining today to talk on deploy Spinnaker CD pipelines in Kubernetes. Let me introduce Anooptej to you. He is a software engineer for almost 14 years with expertise in multiple technologies. He is an Oracle certified DBA and currently working as a DevOps practitioner, working with the customers globally by helping them to adopt the best DevOps practices to automate various clients' SDLC. With that, a warm welcome to Anooptej. Over to you.
Yeah, thank you, Savitri. Thank you for the welcome. Hello, everyone. Thank you all for joining me on OSCONF 2021. I know it's a Saturday evening, and I don't want to, keep the session too long. So I'm Anooptej, and the introduction is already done. I'm a senior DevOps engineer at Opsimex. So our plan here at Opsimex is to basically deliver software without any human intervention. Without any human intervention. So today's talk, the agenda of today's talk is basically about the new trends in software delivery, and I'll be briefing about some simple challenges that we are facing in the existing tools and technologies in the process of faster delivery process, and why we have used Spinnaker, and what are the best practices of Spinnaker, and some of the solutions to deploy and deliver Kubernetes applications seamlessly into your Kubernetes cluster. So these are few highlights that I'll be talking about. And also, while I am talking about the process, I'll also demonstrate, the pipeline that that we use on a day-to-day basis to deploy our applications into not only Kubernetes, but also multiple cloud environments like AWS, GCP, Azure, and OpenShift, and so on. So this is basically a multi-cloud platform. So just a brief, introduction about what we do at OpsumX. So we are basically a continuous delivery organization, and we use Spinnaker majorly to achieve all of our continuous deployment process. And on top of Spinnaker, we have developed Autopilot, a machine learning tool, to perform the canary analysis of your baseline and canary deployments. And because we know that most of the enterprises are currently in the process of digital transformation to adapt faster delivery process of their softwares. We know that organizations are in the process of converting the applications into microservices and adoption of public cloud and containers, and moving most of the applications into cloud native application services and everything. So in this process, we know that there is a very fast adoption of adding multiple tools into your deployment cycle, which includes custom scripts and manual verifications and manual approvals. And also, all of this includes meeting SLA for your deployments. So these are basically some challenges that we have identified, in the deployment cycles, where maintenance of custom scripts are basically, especially when I say maintenance of custom scripts, when we are talking about deploying to multi-cloud deployments, and deploying your applications to not only Kubernetes but also multiple cloud platforms. So there are challenges because most of the modifications and everything, it is manual intervention needed. And talking of manual verification, it is very well known that there are error-prone when we are doing a manual verification during the test cycle. Because of multiple reasons, we might miss out a few minor things, which might end up to be a huge defect at the last, and so on. The list keeps on growing. And speaking of manual approvals, when you want your deployment to roll out or roll back, if you identify any issues, the ideal benefit, if you have the overall stages enough in your pipeline in a single pipeline, that would be a benefit. But in some practices, I have noticed that manual approvals are always time consuming, because the validation of your deployments and looking out of comparing your data of your deployments, your canary data, your deployment data, your overall the Git commits data, the governance data which has been shown from your Jira. So all of these validation and approvals, it takes quite a long time. So to achieve all of these challenges, what we have found is Spinnaker, where this is a tool open sourced by Netflix in the year 2014. This is basically a multi-cloud continuous delivery platform, which supports your deployment into multi-cloud, Kubernetes, OpenShift, AWS EKS, GKE, Azure AKS, and not only that, if you have some of your monolith applications to be deployed into virtual machines, like say your on-prem infrastructures, you can plug in Ansible playbooks and deploy them on the go, and with the help of AWS inbuilt AWS stages, so you can deploy your infrastructure directly from a pipeline to your AWS EC2 instances or ECS deployments, everything on the go. And there is a huge community out there, and on a day-to-day basis there are lots and lots of discussions happening about the issues users are facing, the kinds of latest updates Spinnaker is evolving around. So there is a huge community around. You can check in on spinnaker.io website and log in, and you can feel free to contribute whatever contributions you have. So a simple pipeline infrastructure, a simple continuous delivery pipeline in Spinnaker basically looks something like this. When a developer commits the code, an automated trigger executes, and the build process. So as I have mentioned, Spinnaker is a continuous delivery platform. It can be plugged in. So this is basically developed with pluggability in mind. You can plug in any kind of tools to Spinnaker. So you can plug in your continuous integration tools. You can plug in your Docker. You can plug in your test tools if you have JMeter, Selenium, or if you have any manual test cases that you are using through script. So you can plug in anything and add it to your Spinnaker. And if you have any vulnerability checks of your images like SonarQube or AquaSec or anything, so you can plug in them so that your security checks of your images can be done on the go before the deployments are being promoted to the production, right? And as I've told, Spinnaker is a Kubernetes native, so it has multiple. Spinnaker itself is a multiple microservices. It has a combination of deck, which is a UI, gate, which takes care of the API endpoint communications, cloud driver, which communicates to all the cloud providers that you are configuring. IGOR takes care of your continuous integration, handling your continuous integration communications. So like that, Spinnaker is a combination of multiple microservices, and it treats Kubernetes as a first-class citizen. And you can roll out your deployments at a fast pace to your Kubernetes platform. Let it be a managed Kubernetes in either one of the platforms, AWS, Azure, or GKE, or OpenShift, or an on-prem Kubernetes. And your deployments can be rolled out in multiple approaches. Let it be a JSON-based manifest, a Helm chart that you want to deploy it directly from Spinnaker, a customized format, or a JSON. So all of these formats are inbuilt, supported by Spinnaker. We don't have to make any manual tweaks at the backend. So it's all inbuilt. All you have to do is, if you want to push your deployments as an artifact, you can just push your deployments as an artifact, or if you want to push your deployments as as a text, you can just copy and paste your manifest in a deploy manifest stage, and your deployments can be proceeded further. And role-based access control deployments. So for each and every environment, like you have a development deployment going on right now, and when you're promoting the deployment to UAT, and you want the exact stakeholders of UAT to approve your deployments. So on a stage basis, you can add manual judgment stages, which is again on native stage available within Spinnaker. So in that, you can select the respective roles of your LDAP to the respective stakeholders whom you want to approve your stages, and they can approve. Only that particular user group can approve, and only then your deployments can be promoted to the next stage. And not only that, for making sure your deployments are being promoted safe, there are inbuilt deployment strategies like blue-green, which in Spinnaker's language we call it as red-black, where you can choose the number of versions you want to keep them active on Spinnaker, and the number of versions that needs to be removed. So Spinnaker takes care of all the traffic shaping of your blue-green deployment of your deployments. So if you're deploying a V2 version of deployment, and the traffic needs to be redirected from V1 to V2, there is a minimum downtime. When I say minimum, it is milliseconds of downtime, and the entire traffic shaping is it's handled by Spinnaker. Spinnaker has Orca, which takes care of the entire orchestration part. So it handles basically the overall traffic shaping and everything. And as soon as your deployment is active, you can visualize your deployments in the UI right here. So this is a simple visual approach of how Spinnaker looks. You can search all of your applications. You can create a project, and under one project you can have n number of applications. Under one application you can have n number of pipelines created. And as I've told you, Spinnaker natively supports multi-cloud deployment process. You can directly deploy your applications into AWS. This is how a simple AWS deployment structure looks. When you have your image, when you have your developer approved any code, committed any code to your, let's say your dev branch or the master branch, the pipeline triggers and it initiates the build. So as soon as the build is executed, so for AWS, what exactly the difference here is, it will bake all your artifacts. So once your Jenkins job, the build is completed, all the artifacts will be placed in your S3 bucket. And as soon as that's taken care of, so there are some prerequisites.
Hi, Anoop. Can we just take few questions? Like,
sure.
How is Spinnaker different from Jenkins X?
Okay, so one quick difference here is you can visualize the entire deployment process. Your execution details and everything will be in detail. And not only that, when you are doing any canary analysis or anything, you can visualize the reports of your canary baseline comparison and your cluster details, like post deployment, if you want to access your application. So you don't have to get back to your Kubernetes cluster and access the applications in a different UI. You can just look out for the details here. I don't see my load balancer. I'm sorry.
Also, like, how is it different from Argo CD as well?
Okay. From Argo CD, the only difference is Argo CD basically supports Kubernetes-based deployments. So all of the deployments that you're trying to push to Kubernetes, that's pretty much it handles. But Spinnaker, it is not only promoting your deployments to Kubernetes, you can also launch an EC2 instance with Spinnaker. So as you see here, I have an AWS deployment done. This is not a microservice. At my AWS in the backend, I have an EC2 instance launched with my instance type scaling and the load balancer details. I can create AWS firewalls directly from the Spinnaker UI. I can create load balancers directly from Spinnaker UI. So you can perform multiple actions on your cloud platform using Spinnaker. You don't have to revert back to AWS UI, create a load balancer, and try accessing it from Spinnaker. So yeah, instead of minimizing your deployments only to Kubernetes, Spinnaker supports an extra, an extra layer. It adds an extra layer by adding your deployment cycles into cloud platforms like AWS, Azure, GCP, OpenStack. So you can also deploy your applications into private cloud like OpenStack by baking your artifacts and deploying your applications as an infrastructure into OpenStack deployments.
Is Spinnaker an open source?
It is an open source, yes.
Okay. And can Spinnaker work as a build tool?
Not really. So for continuous integration, we need to plug in Jenkins or Travis CI, Circle CI, Bamboo. So all the current continuous integration tools, the build tools that is available, Maven, all the build tools that's available in the market right now, all of these are supported or are natively supported with Spinnaker.
So another question, is it native to Terraform?
It is not native to Terraform, but we can customize and we can add Terraform as a stage with Spinnaker. So if you're looking at my screen right now, I have a pipeline with which I am managing my infrastructures on AWS, Azure, GCP, and I'm in fact creating an EKS cluster directly using my Terraform plans available with me.
Last one, is Spinnaker only for KA8S, or it can deploy changes into VM?
It can deploy changes into VM. If you are using any Ansible playbooks or any of your custom scripts or anything that you have, any of your configurations of your applications or anything, it can deploy changes into VM directly. But based on your current configurations, we just need to plug in them to Spinnaker as a custom stage to your pipeline. That's pretty much it is.
Okay, what deployment strategy does Spinnaker support?
So speaking of deployment strategies, Spinnaker inbuilt has deployment strategies like blue-green, which in Spinnaker we call it as red-black, and Highlander, which basically terminates all of your previous server groups and keeps your latest deployments active. And you can create custom deployments as well. If you have any custom deployment strategies that you want to define, you can define your custom deployment strategies. I am not using any custom because blue-green pretty much works good with me. So I'm going ahead with blue-green right now. And when I go ahead with blue-green, I can define the number of requirements I have. So when you leave the blue-green deployment, when you are using the blue-green deployment strategy in your clusters, in the Spinnaker UI, in your clusters, you'll have your latest version of deployment active and the previous version of deployment inactive. It will just be disabled. However, in your cluster, this particular container will be running at any given point of time. If you realize that there are any defects or you identify any issues, if you have your pipeline still running, you can roll back from your pipeline at any point of time, or else you can just click on your relevant server group and go to the actions, roll back. You have any reason, provide the reason, and just submit it. So as soon as the submission is done, Spinnaker just doesn't do a kubectl apply and proceeds with the deployment. It waits for the end-to-end health status. If you look at this particular scale here, it will wait for the end-to-end health status. And once your health status is 100% good, only then that the traffic from your latest version to the previous version will be reverted back. And as soon as the your previous version of deployment is stable, then the traffic will be reverted back completely and your application will be active. So basically with this, the downtime is completely minimalized. It is as good as a simple refresh and your application will be active on the go. I hope that answers the deployment strategies and how the traffic shapings and everything takes care of. Okay, I would take that as an yes. So speaking of some benefits and best practices that Spinnaker handles. So you can, as I've been mentioning all through the demonstration, you can integrate any of your continuous integration tools that's available. And Spinnaker has inbuilt monitoring So Spinnaker comes with, the open source Spinnaker comes with Kayanta, which takes care of your continuous verification process, which can compare your baseline and canary metrics alone. But if you remember, I was talking about Autopilot in the starting of my demonstration. Autopilot is an inbuilt tool at Opsimex, which takes care of canary baseline analysis of not only metrics but also logs. So that is a simple difference. And
okay, one more question. Is there a way to make your pipelines compliant to standards if we have to follow SOX?
Absolutely, yes.
Okay.
Yeah, absolutely, yes. You can. So with the open source Spinnaker itself, if you look at the pipeline here, there is a permissions tag. And with this, you can basically control your role-based access control. And if you want to implement some policies to your pipelines, that needs to be customized. There is a little bit of tweaks that needs to be done. You can reach out to me, and I can walk you through how all of this needs to be done. All of this can be executed. All of these customizations can be tweaked around, and it can be executed.
So does it support rolling updates too?
Yes, it does.
Okay.
Rolling updates, rollback, all of these are inbuilt. And if you want to add any custom traffic shaping any custom traffic shaping integrations, like if you want to integrate Istio or anything, that is your choice. You can definitely integrate it, but not necessarily that is required, because Spinnaker can handle all the blue-green strategies and everything by default. So yeah, rolling updates, Spinnaker handles it. That's absolutely good. And Spinnaker can deploy microservices as well as monoliths into multi-cloud platform. And if you want to convert your pipelines as a code, Spinnaker comes with a command line interface which is called as Spin CLI. You can convert your pipelines and pipelines as a code, and you can templatize them. You can modify this, and you can create your pipelines, everything using Spin CLI. And I have been mentioning about the inbuilt deployment strategies that Spinnaker has. It can handle Highlander, red black, which is called as blue green, and canary deployments. So all of these are inbuilt with Spinnaker. And your notifications can be triggered to email, Slack, Teams, SMS, and you have any other notification methods like one of my active customer currently, they wanted WebEx Teams notifications, so that can also be added up. And yeah,
does Spinnaker support Helm chart?
Yes, it does.
Okay.
I think I have covered it as part of the slide. Yes, Spinnaker supports Helm chart. And if you want to bake your artifacts into an artifactory and deploy it via Helm chart, even Spinnaker supports that. I think I have walked through that pipeline, but if I did not, it might be, I might have missed it. So you can add your artifacts. So wherever you are storing your artifacts, you can add them. And Spinnaker has a render engine by default. So Helm 2 and Helm 3 are the defaulted render engines. And in addition to that, Customize is also one of the render engine, which can with Customize, basically you can add your additional customizations into a file and just put it across. And you can define all of your artifacts over here. And in the deploy stage, you can just point it to your artifact, that is your Helm chart, and it can push your deployments into your Kubernetes with no issues. And in this particular stage, right now, I did not look out for any rollout strategies. If you look out for rollout strategies, by default, as I've mentioned, there is red, black, and Highlander. So you can look out for either one of these. So red, black is the blue, green strategy that I've been mentioning about all the time. And some of the best practices that Spinnaker handles is blue-green deployments. With the help of Kayanta, you can have automated canary analysis, which can take care of your metric analysis of your deployments on the runtime during your deployment execution. And it can generate your metrics. And currently, Spinnaker supports metric tools like Prometheus, Grafana, AppDynamics, Stackdriver, Datadog. You can integrate all of these, and with all of these tools, you can execute your automated canary analysis on the go. And deployment, rollbacks, rollouts, all of this can be done. Baking configuration can be done with your Spinnaker. Just as a best practice, avoid baking your secrets, and secrets should always be provided on runtime. So just to avoid any risk of your exposing your secrets to the public. And
So is it CLI or GUI based?
Spinnaker is a UI. Spinnaker is a UI based. But if you want CLI to manage your pipelines, some of your pipeline templates and everything, so there is Spin CLI also available at the backend.
Okay, thank you.
So you can configure your secrets with secret management like Vault, and deploying experimental versions like Canary and Canary deployments. So always make sure to deploy your experimental versions into lower environments before promoting it to production. And Spinnaker has already some of the best deployment strategies. But if you are using any other strategies that is not available in Spinnaker, please do join the community and feel free to provide your suggestions. So we can try to integrate them and put them as part of Spinnaker, so that it can be available for all the users who are using Spinnaker right now on the open source community. And as I've been mentioning, monitoring and capturing your runtime metrics with Kayenta. So Kayenta is an inbuilt canary analysis tool that comes with Spinnaker as a package. But if you want to use Kayenta explicitly, not with Spinnaker, but separately with any other CD process that you're currently following, you can absolutely go ahead and integrate Kayenta. This is available as a separate individual distribution also. And role-based approvals, which I have already mentioned. So in the pipelines, there is manual judgment. These are some stages, the types of stages that Spinnaker has by default. Automated canary analysis task. Ansible job is a custom job. You can still add it. AWS code build is a manual, and bake manifest comes inherited with Spinnaker. And Canary, as soon as you have your Kayenta enabled, Canary analysis and Canary stages is available by default. Check preconditions, so that if you have some preconditions for your deployments, like in my Canary analysis pipeline right now, I have some preconditions. It's just that once my Canary score is greater than 60, I just want my deployment to be promoted to production. So if you have some of the spell expressions, you can input some spell expressions in this stages, and with that, your deployments can be promoted to production on the go. You can add your test suites. So right now, my current test suite is coming from Jenkins, and at the back end, I have programmed everything manually. There are some scripts that I have written, and I've configured it as a test case from my Jenkins shop. And if you're preferring to use Selenium or JMeter or any other tools, we can always plug them into Spinnaker. Just a minor tweaks here and there would be required. We can always plug them into Spinnaker, and we can use them on the go. With any kind of tools can be plugged into Spinnaker, no questions asked. Customizations can be done as per your requirement, because Spinnaker is a completely declarative tool. Whatever the user wants to be, whatever the user has in his mind, it can be integrated, can be targeted, and your deployments can be targeted according to your current the way you perceive your deployments to be, you perceive your deployments to look like. That's exactly, you can create your deployment cycle using Spinnaker. And speaking of the multiple stages, manual judgments, cloning your server groups, running a concourse job, creating load balancers. So there are multiple stages available inbuilt with Spinnaker. And as we speak of manual judgment, any groups that you had and that you add here as part of your permissions, I think I am not using the latest version. Okay, I'm sorry, just give me. Okay, I think there is an issue logging in. So basically, I think I'm using the older version of image right now, which is why it is not showing the exact configurations. So when you have your LDAP configured and when you define your, the group of users that you would want to access this particular application, and as you define the permissions for these groups, when the pipeline is getting executed in the manual judgment stage, you will be seeing, there will actually be a different set of visual here, which is called authorized groups, where you'll have a drop down to select the list of groups to approve your deployments. So only the stakeholders, whoever is available in that group, only they can go ahead and promote the deployments or approve the deployments to the subsequent environments. Apart from these users, nobody else can approve, so that your approvals are safe and confident. And at the same time, in this deployment, during this approval, the user can always provide reasons. And if you have any preconditions, as you have seen here, if you have any preconditions that you want to check out on the UI, you define the preconditions. You will be able to look out all of your preconditions in the manual judgment as per the instructions that you have defined. So as soon as the preconditions and everything is being met, is meeting your expectations, then you can go ahead and approve. And once the deployment is approved, it can get back to get to your production. And according to your deployment strategy, the rollout strategy applies, and the deployments get promoted to your production. In case if you identify any issues in the precondition stage itself, you can automate with the spell expressions that you have. If some of your criteria is not being met, if some of your deployment process is not being met, just provide your preconditions, the set of preconditions that you have here, and automatically the deployment, if it wants to get promoted, it will get promoted. If not, it will just get rejected right here. And some of the best practices as part of canary analysis. So when you're using Kayanta for your canary analysis, always make sure the lifetime of your canary analysis is a little higher, and you have multiple intervals of your analysis, so that the reports that is getting generated, multiple reports get generated, and it is absolutely accurate for the deployment that you're executing. Because every time a new report that gets generated, it will Kayanta basically generates the report from the scratch. It will start scraping the metrics that you define in the canary config. Any metric that you define in the canary config, it will scrape out the metrics as you declare, and for every interval it will generate the report from the scratch till the end, and it will keep generating multiple metrics for multiple intervals. So with this, I think I'm done with my demonstration. Thank you for your time, everyone. There are some sample pipelines available in the GitHub link that you're seeing here. And on my on our website at Oxomix, there is a detailed Spinnaker course available. You can just jump in and know more about Spinnaker. And if you're interested in contributing in, please join in spinnaker.io and feel free to give your ideas on Spinnaker.
Thank you, Anup. Thank you very much. It was very interesting and very interactive questions we had for the day. Thank you for answering all of those. A wonderful session. Thanks again. With that, I would like to wind up, today's OSCON. So I would like to thank all of you for your active participation and open dialogue panel discussion, which was very interesting. We look forward to continuing beyond this event, the very stimulating and instructive exchange of ideas we had today. So I trust that we all will take home further inspiration on how we can foster the ideas and discussion we had today. Appreciate and express my gratitude to all in making this event a successful one. So thank you all. Stay tuned for more such events coming soon. Thanks again. So bye-bye.